Hello everyone. Thanks for joining, subscribing my YouTube channel. Uh, I got requests from students that can you create a particular course where you can give us the differences in between different SD-WAN, and three main SD-WAN at the moment in the market are, that Cisco Viptela SD-WAN, VMware Velocloud, and SilverPeak. So what I have done here that I have created this particular video. In that, I will start with Cisco Viptela SD-WAN. Then you will find a VMware Velocloud video. And then finally, you will find SilverPeak. So in this 3-in-1 video series, or in this 3-in-1 video, because this is only one video. So in this video, maybe it will be lengthy, like 6 to 8 hours, but you will get the knowledge. So once you complete this video, you will get the knowledge related to Viptela, related to Velocloud and SilverPeak. And then you can create your own notes that, okay, Cisco Viptela is working like this, SilverPeak is working like this, and VMware Velocloud is working like this. Obviously, when you want to do the POC, you have to create your own lab related to all three. Then you have to go and compare the feature in between all these three. And then you can make a decision that, okay, I want to go with Viptela, or I want to go with SilverPeak, and or I want to go with Velocloud. Now, all these three SD-WAN, they have their unique feature. So for example, Cisco SD-WAN, it's very good for enterprise network. It's suitable for enterprise network because it has ISR router, high performance routers. This is going to support all the features that we have in the SD-WAN, plus the other features that we have with Cisco SD-WAN is the security. Means all type of security that Cisco SD-WAN is supporting, because inside ISR router, you can go and create the containers, and then you can use it as a firewall, IPS, IDS, Cisco Umbrella can be integrated, and other appliances related security we can go and add. So that's one of the advantage we have with the Cisco SD-WAN. Now, because of the evolution of Cisco SD-WAN, they are supporting nowadays multi-cloud as well. They are supporting voice gateways as well. So if you go and check the features, like every 3 months, Cisco is adding some new feature inside Cisco SD-WAN. And that's why it's quite hot in the market. Now, with compared to Cisco SD-WAN, if you come to the Cisco Velocloud, you'll find that it is suitable for cloud related SD-WAN. So what does it mean by cloud related SD-WAN? There are, nature of SD-WAN. So some SD-WAN are enterprise related, some SD-WAN are secure, like FortiGate or maybe Palo Alto. If they introduce their SD-WAN, so you'll find that they are security related. Some SD-WANs, they are cloud focused SD-WAN, like Juniper SD-WAN or VMware SD-WAN, because what these companies are doing, they have their gateway. So they have their cloud gateway near to the cloud resources. So either it's a SaaS or infra as a service. Their partnership with all these vendors like Amazon or other cloud vendors, they have partnership with them, and they are placing their gateways nearby these clouds. Okay, so again, you have to write it down on a paper. Okay, Cisco SD-WAN has these 10 high features, then VMware Velocloud has these 10 high features, then SilverPeak, and SilverPeak is one of the SD-WAN which is application oriented, because you know that SilverPeak is a company, was a company, you can say, because now it is acquired by some other, at least SilverPeak SD-WAN. So SilverPeak was the primary company who was doing the optimization, application optimization. So SilverPeak SD-WAN was quite popular in early days because people are looking for application optimization, and SilverPeak was the best. So initially, if you go and see the trend of the SD-WAN, you'll find that initially SilverPeak was doing one, or maybe it was on two. Even if you can go and check the Gartner report as well, as per Gartner report as well, if you go and see that VMware, SilverPeak, and Cisco SD-WAN, they have close fight. But initially, Cisco was lagging behind. Now it has the pace, and it is gaining the pace, and it is reaching towards the Velocloud, and maybe it will compete as well. But again, aspects are there different. So with respect to security and enterprise, Cisco is very good. With respect to cloud integrations, with respect to applications, with respect to enterprise level security, you can say Velocloud is good. And again, if you go and compare with respect to all the application optimizations only, okay, so SilverPeak is have the mastery on that. So that doesn't mean that Cisco, Viptela, or Velocloud or SilverPeak, they are not doing application optimization. They are doing at certain level. So you can think like this, that you have expert level product, and then you have um, what you can say that professional level. So suppose if you have 3 level of certifications like associate, professional, and expert. So if you are looking for expert level in application, go for SilverPeak. Expert level in security, go for Cisco. Expert level in cloud integration, go for Velocloud. Okay. Anyways, you please watch all these recording, and you can make your decision as per your requirement. You can go for any of these 3 vendors. Now, the first and foremost question that is coming in our mind is that why we need SD-WAN in first place? Because we have other solutions and already the traditional network is running fine, there is no problem. Then why I need to go to SD-WAN? Why I need software defined wide area network? Now, if you see that at present we have issues with the traditional network. So yeah, traditional network is going fine, but you can see again, this is some study you will find online as well. Source is IDC. Security requirements related to web and internet option. So I need one sort of fabric, one tight fabric that will provide security not only in premises but the application going towards the internet. Complexity associated with interconnecting multiple transport. That is again one key. So for example, if I have my branches and data center situated geographically dispersed, or they are situated across the geography. Now, for example, you have branch 1 and branch 2. You are running, say, MPLS transport, you are running, say, internet, you are running some LTE, etc. With the SD-WAN solution, what you are looking for, that all these transport will be not a part of your maintenance, or you can think that all these transport, your network, think that I am independent of transport. So what does it mean? That means these transport, irrespective of these transport, your data can flow. So either it can take MPLS or internet or LTE, but the end goal is end-to-end packet delivery. So what does it mean? End-to-end delivery means that your traffic is started from your branch, in between whatever transport it has, it will reach to the destination. That is the meaning of independent of transport, means it is not dependent upon what type of transport you have in the middle. Alright, then you need such type of fabric, correct? These are the problems that we are discussing at the moment. Need to further analyze the visibility into the application and resources delivery in the network. That's a huge. That means suppose in the traditional network also you do not have much visibility of the application. Why? Because the traditional networks, they are not built for application. Mark my words. Say the traditional network is there and you are running application. Now you are building the network as per the application. Both are two things. Correct? So now I am building the applications centric network. Initially we have network and then we are running the application. So that is the shift we have. So that's the reason whatever features or whatever SDN solutions we have. So for example, in terms of WAN, we have wide area network SDN solution. In a LAN or in a data center, we have, say, for example, Cisco product is ACI, application centric infrastructure. This is the solution for the data center SDN or data center automation, also you can tell. Now all the solution that you are checking here, the nice thing about all these application related solutions are that we have end-to-end visibility. So not only we have the visibility to the application that is coming from one location to other location, but we have the visibility to the SaaS based application as well. So for example, if your application is hosted over cloud, say Office 365, etc. For those applications also, you have the full visibility. All right. So now you can see the security, the complexity with relates to your multiple transport. You don't have better visibility for the application. Managing consistent user experience for on-site enterprise app and off-premises cloud application. It is actually difficult to manage the cloud-hosted application. In-house management of enterprise WAN. Now, what you have that say in the SD-WAN solution, what you will get that you have something called management plane, you have something called intelligency, you have control plane, and you have something related to data forwarding plane. So you have data plane. So now I have the data plane devices who are basically responsible just to send and receive the data, but the instruction and controls they are getting from the control plane, and overall management to the data plane devices, to the control plane controllers or the devices, to the cloud hosted application, to the reporting. We have separate devices inside the management plane. So now you can see that one box has been offloaded. If you see any Cisco device, you will find inside the Cisco device, a router or switch, we have the control plane, we have the management plane, we have the data plane, everything one device is doing. Now I have offloaded these things in different planes, and independently I can enhance the capability of the independent planes. That is also one feature. So that's why we have the independent management plane. Cost-effective delivery SaaS, software as a service application, that's true, that we have discussed. Growing annual cost provide additional bandwidth. That is also huge. So if you see this type of network where you can create application aware routing. So for example, in traditional network, you will find most of the time one of the link is idle. You're not using active type of load balancing by default, or you are not using one of the link most of the time, or other link you have as a standby. But in case of SD-WAN solution, there are measures, there are ways that first of all these links will be active utilized. And in case you have some backup resource, so by default that traffic will go with the backup link. That means you are going to utilize all your links efficiently. And interesting thing here in the SD-WAN that you can do this load balancing or load sharing of the application per application. So I can utilize the link. Say suppose I have application 1, application 2, application 3. So I can create the rules that okay, application 1, this is active, this is a standby. Application 2, the first link, this is the first link and this is the second. So likewise for application 2, this is active, this is a standby, this is active, and like that you can do active standby. Means you can create rules application specific, and that's the power we have in all these SD-WAN solutions. Now we can do the audit and compliance report, management of the connectivity of remote branches, that is also huge. We have a ZTP zero touch provisioning type of features that we can deploy the remote side without doing much configuration changes or without doing much of hassle or without tension, you can say in one word. Simply one non-techie guy, he can go to the branch, he can connect the cable to the ISV, and poof, after 5-10 minutes, this device will come up and running like that. So these features we have. Then appliance sprawl at the WAN edge, time to provision, that's the same thing. So not only you can deploy the devices, but you can add new services, feature, etc. So these are the hurdles that we have in the WAN or wide area network challenges, and all these hurdles has been solved actually with help of SD-WAN solution. We'll see in the upcoming sessions recordings. Let me stop here. Continuing the WAN challenges that we have now, you can see the same thing, that in the traditional network I have disjointed solution. Means for everything I have something. What does it mean? That for VPN solution you have routers. Say for routing towards the edge, towards the core, you have certain routers. To connect with the different ISP, also you have some services or routers. For security, you have firewall. For again security, you have IPS, IDS devices. For WAN optimizers or to application optimization, you have WAN optimizers, etc. So now you'll see that, okay, you have engineers who is checking the VPN settings. You have network engineers who is checking the routers, routings, BGP, and all those things. You have security engineers again who is creating the rules for firewall, IPS, IDS. You have engineers for WAN optimizers or to check the application optimization, etc. Now, if you consider all these disjointed type of services or application, what will happen? It will increase the operational complexity. That's why you'll find that it will increase the operational cost as well. So not only you are increasing the operational cost or the complexity, but you are increasing the number of devices as well. Maybe some of the devices are not being used, so we are not using the devices as per their hardware capabilities. Maybe uh, we are using the device for more number of say packet cycles as well. So same packet is flowing from my router to firewall, and then again it is coming back to router and then firewall, and then it is going to cloud. Maybe these things may be possible in the traditional network. Why? Because what is happening that in the traditional network, that network is not ready for the cloud as well. So for example, if I want to go outside to the cloud, again I need some firewall in between, then my traffic will go to the firewall and it will go to the cloud. Or maybe I have my branch and he want to go to the cloud. First the traffic will unnecessarily go to the data center and then it will go to the cloud. Depends upon the design. So if I have SD-WAN solution here where inside the router itself I can have features of firewall, IPS, IDS, etc. Directly I can go to the cloud. So why I will use more bandwidth to go towards the data center and then I'll go out? Or why I will give this packet more number of cycles inside the fabric? Remember, by default in the traditional network, we don't have concept of fabric. Means I do not have unified infrastructure. Unified infrastructure means, say for example, this is one of the unified infrastructure. Everything is tagged, for example, A. So everything is belonging to A. In traditional network, it's not like that. It's fragmented. You have security, put firewall. You have something, put WAN optimizer. You have IPS, IDS, etc. So we don't have full end-to-end solution. Means if it is there, but it is in the layers and it is not inside a fabric. You have to join different solution in a single, try to make a single infrastructure, correct? Now, although you have taken so much of MPLS bandwidth and you are tied with the ISP, still you are not able to use the bandwidth properly. Why? Because some of the application of in traditional network, even we don't have concept of the application load balancing. So some of the links are not fully utilized or even 100% unutilized. So all the time it is working as a standby, and you are not able, although you have the bandwidth, but you are not utilizing it as a fullest. They don't have the application awareness, so that's why we don't have even full visibility what application is coming, what application is going out. Even if you do not have full visibility, again it's difficult to provide the bandwidth. Write the code related to application aware routing or application aware ISP A versus B, etc. Because we have the disjoint solution, so that's why we have the fragmented security as well. All these constraints, if you add, then it's very difficult to scale up now. Because say for example, if you want to open a new branch, there you want to implement one of the router, but that router is dependent upon the MPLS circuit. It will take approx 6 months. Some places it is taking 1 year just to get this MPLS provisioned at that particular site, because again it will go to a project cycle life management, something where you need to send the requirement, then approval, then cost, then project management, then it will reach to MPLS, then they will take time, then it will deploy, then you purchase new router, you send to the branch, then you take a maintenance, then again you will deploy the router. Like that, it will take some time. Obviously, it's not that easily a scale up type of thing. But suppose in a branch or everywhere we have internet. So simply we have options that we can use the virtual devices as well. I can deploy a device within 1 month or less than that, and I can scale up. So that one type of a scale that easy to deploy in terms of scaling. But other thing is that you can add other devices in the existing network as well, so that scaling is also possible. So deployment is possible. You can increase the number of devices as well, because say if you are using virtual devices, it's very easy to deploy. Considering all these things, your cost will increase, your operational complexity will increase. So as per Gartner, if you see the Gartner report, you'll find that they are telling if you are using SD-WAN solution in proper manner, that means obviously the licenses and the requirement, the bandwidth, the throughput, all these considering, you can decrease 40% of the amount. So it can go, depend upon design, it can reduce your overall operational cost in between 40% to 60-70%. It depends that how you're deploying all the services. Uh, are you taking unnecessary licenses and all those things if you consider. Now, what type of players we have? Say at the moment the SD-WAN thing come into the market, all the network solution companies like say uh, now here you can see a small company like Velocloud, Viptela, Versa, SilverPeak, Citrix, Riverbed, etc. But all the company either they started their solution regarding SD-WAN, or these companies acquired by the big player like Velocloud. VMware has acquired this company. Viptela, Cisco has rebranded everything inside the Viptela, and this course is again related to Viptela plus the new features added. Now Versa is for SD-WAN for the ISP. SilverPeak is again SD-WAN for enterprise network, and they have nice WAN optimizers and some other features. We are going to see the comparison chart as well. Citrix, they have started the Riverbed, Talari, Iseka, Nuage, Juniper. Now you can see n number of SD-WAN solution. What a customer can use, what a customer can choose. So where I should go? I should go to Velocloud, Viptela, SilverPeak, Citrix, etc. So it's very important that for your infrastructure, what you want to choose. Uh, why Cisco is the preferred choice at the moment? Because first of all, the Cisco TAC services are better than any, undoubtedly. Cisco is investing a lot for the innovations and new ideas. That is the other thing, and they have the vision as well. Now, Velocloud also you'll find that okay, because the SD-WAN solution is new in the market and what the solution architect think inside that particular premises, so they can go to Velocloud and they can choose Viptela or they can choose any other vendors. Now, when we are talking about the say SD-WAN solution for the enterprise network, then you have certain options. As per my recommendation, if you're asking, I will go to Cisco Viptela. Why? The reason behind this is the next slide. So you can pause the recording, you can go and check what are the components we have in all this solution. By the end of day, they are using the same thing. That's for true. But what is the stability and what are the feature capabilities, etc. we have, and plus if I raise certain cases, who will provide me the best security? Because say whatever brand we have, whatever options we have related to security, by the end of day, it depends upon what type of services I am getting. Because as a company, I will not wait for the resolution. So I log a call to certain vendor and then I am waiting. That means I have loss in my business. That I don't want. Now again, if you see the services, we know that Cisco is the best. But if you see the feature comparison, what you will find that okay, with respect to feature, say for example, I'm checking here the Cisco Viptela or Cisco SD-WAN solution with respect to new router in the SD-WAN solution. Say ISR is very old and most of the branches at the moment you'll find Cisco ISR routers, but ISR as a SD-WAN component, this is a new thing that we are going to discuss here in this list. Now you can see here that if I use ISR specifically, the control plane is centralized, the management plane is centralized, the scalability is very high, the predictive analytics is yes, NFV capabilities, okay, network function virtualization, not all the companies they are using. So even I can drop this feature. Now if you compare with the Velocloud or the SilverPeak, even no. The layer 7 firewall, yes, I can make, means we have the container features in ISR, we can do that. The inbuilt IPS, yes, the other vendors, even they don't have those features. WAN optimization, yes, we have virtual VAS feature inside the ISR. I can create app nav features and I can do that. No, yes. In SilverPeak, the WAN optimization application optimization is there because generally SilverPeak was known for their application optimization. Mature routing stack, yes. Say here we don't have. Support for non-Ethernet interfaces, ability to run voice gateway, yes, we have this ability inside the ISR router. See, ISR is already a mature hardware, mature product. So it is supporting all these features that we have in, or I can say that all most important features that we have here in the list, the ISR router is supporting. Say cloud on ramp for infrastructure as a service, yes. The software as a service, yes. So that's why you can choose the ISR routers and you can use inside your say SD-WAN infrastructure. Most of the companies they have the ISR router. We'll see later on that what models are supported. This should be 4400. We'll see that 4K series supporting that. What image you need, we'll go and check in the list. Say 16.9 or 16.11 and 10 and 11, etc. So it's very easy actually. Suppose if you have the hosted control plane over the cloud, already you have the ISR routers for the migration purpose also. Whoever company they are using the ISR router, for them it should be the natural migration. Otherwise, we have other options also that you can check. If you are comparing the price, so maybe some other vendors, they can give you with some lesser rate, or maybe someone is using VMware data center product like NSX. So at that time they can use VMware SD-WAN solution, etc. Okay, so all right, we have studied a lot about the comparison, the restriction with respect to the traditional network, means the problem in the traditional network, and what are the vendors that we have for the SD-WAN, who is the best and who is providing much more stability, features, capabilities, etc. So let us stop here and we'll study more in the upcoming sections. Now, what is SDN and what is Cisco SD-WAN? Most of us, we know that SDN is a term that you can decouple the data and the control plane. So if you decouple the data and the control plane, what will happen with that? For example, say, think like a normal Cisco traditional network where you have boxes. So where you have the routers. So I have a number of router over the data center and the branches. Now, if you see the traditional network or traditional devices, you'll find that in the same box, you have the management plane, you have the control plane, you have the data plane. Now, while doing this thing, what will happen that you need high-end devices, first of all. Now, suppose if I don't need high-end devices still, uh, what is the use case if I decouple the data and control plane? And that's the key here with us. So suppose all the branch devices, they have the data and, for example, when data plus the control plane, data plus the control plane means all these devices, they can take their own decision while processing the data, correct? So all these devices have data and control plane together. Now this is something you can think like, oh, this is a distributed type of architecture. In SDN, in software defined network, what we are doing, that we are taking the control out. So now I have centralized control plane and then I have the data plane devices. So suppose if I do all these things, what is the benefit I have? That's the important thing that we need to understand. Now, if you see the definition that SDN architecture, the control and data planes are decoupled, network intelligence and state are logically centralized, and the underlying network infrastructure is abstracted from the application. This is the most important line we have. So now what you are doing, that you are decoupling the control and data plane. So whatever intelligence you have for that particular fabric, now you have centralized intelligence from one brain or one central brain. You can take decisions for all these devices. So how these devices will do, say for example, routing, how these devices will do, say, policy forwarding, how these devices can take other decisions, correct? So for that you have the common central intelligence, that is your control plane, and you have decentralized or you have data plane in the other dimension. So what does it mean that, say, if you think like this, say, okay, I have two coordinates, like in normal algebra we used to study, say, x and y coordinates. Now you think your data plane devices, they are sitting inside the x-axis, and you have data plane devices like here. Now with this x coordinate, you can think this as a physical. This is the physical world that is sitting here. Now what I can do here, I can have multiple abstraction of this physical world. So what does it mean that I have, say, view? I can have view 1, I can have view 2, etc. I can have abstraction, and then on the top, means on the top layer, I can have different logical views. So I can have logical view 1, logical view say 2, logical view say 3, Now, what does it mean by logical view from the physical architecture? Generally, if you see other terms, you'll find that they are termed as a tenant. So they may be one customer or business unit or etc. But from the physical infrastructure, you have logical uh, views. So in our case, say for example in SD-WAN, SD-WAN is nothing but two terms, software defined wide area network. Now in SD-WAN solution, you may have physical topology, like you may have two branches, they are in mesh, they are partially mesh, they are say hub and spoke, maybe they are point to point, like that. These type of traffic communication you have. But one of the say view, he is thinking devices they can communicate like point to point. Other view can think, okay, it is working as a hub and spoke. Other view can think, okay, it is working as a mesh topology. Now this is the thing we are telling, that you have the segmentation. So logically, you have different views of the physical infrastructure, and this is possible because of one feature that by default SD-WAN is supporting, is the segmentation. Okay, so you can see the power here, that once you decouple the physical and the logical thing, or you can say like once you decouple the data plane and the control plane, at that time you have these many features that is listed here. Okay, let me go back. I think I jumped one slide. So yeah, SD-WAN. So first of all, what we'll do, that first of all, we'll study about all these things that is written here, and we'll try to draw a picture out of that. Okay, why it is so, etc. So for example, let me open this slide. Yeah, for example, I am telling that, okay, all right, the SD-WAN solution, or say SDN solution, a way to optimize common link utilization in the network in enhanced and the application driven routing. Remember, what is the feature of SD-WAN solution? The first solution is that you can create application aware routing, and here we are listing the SDN features. Later we are going to add WAN inside that, so this will become SD-WAN, correct? So application aware routing, like in traditional network, it's very difficult to load balance the application over multiple ISPs, MPLS and internet. This can be achieved with help of SDN solution, an open solution for VM mobility in data center. Now, in this particular list that we have here in our slide, you will find that this is with respect to SDN. Now, SDN you can categorize in, so for example, LAN, and you can categorize in WAN also. So SDN for LAN, again, you can categorize in two part. One part is, say, uh, campus area network. Other part, you can think this as a data center. So for campus area network, Cisco has introduced a DNA, digital network architecture. For data center, we have ACI fabric, application centric infrastructure. And here in the WAN side, the SDN solution is Cisco SD-WAN Viptela. So we have SD-WAN solution. For all these solutions, you will find that you have obviously decouple of the data and control plane. Some of the point listed in this particular slide, they are telling, okay, if you use SDN solution, then you have VM mobility. So in ACI, yeah, you can move the VMs, the endpoint from one place to other place seamlessly. There is no problem on that. Now this is the common for SD-WAN. This is actually for SD-LAN. Then a way to reduce the capital expenditure on my network leveraging commodity switches. Yes, that's correct. So once you have this type of a structure where you have decoupled the control and data plane, now you don't want control inside a box, or you have less control inside the box, then you can use some less expensive routers or switches to do all those things, because you're offloading the hardware capability for the edge devices or for the branch devices, correct? So that means automatically it will reduce the cost, and that's true. Then a solution to build a virtual topology with with optimal multicast forwarding behavior. Actually, that is true. When you study ACI fabric, then you will find, okay, you have VXLAN type of virtual extensible LAN type of infrastructure. Behind the scene, the control for this data forwarding, or for this data plane attribute or data plane functionality, that we have the VXLAN. The control is residing over multicast, and not only that, you can run the VXLAN within the data center. But suppose if we have two data center, say DC1 and DC2, then you can extend that control from one place to other place, that you can extend your L2 layer 2 extension from one location to other location, etc. This is something like related to data center. This is also related to data center SDN. This is related to SD-WAN. This also can be mix of SD-WAN and SD-LAN, no problem in that. You can have this common feature. So we have some common feature related to SDN that can be used in the LAN, that can be used in WAN, that can be used in other SDN solutions as well. Correct? Let's see other points. A means of a scale my fixed mobile gateway and optimize their placement. Yes. Now this feature actually is in the data center also, where you have the mobility feature, but mostly we want this feature inside the campus area network, or inside the LAN that is residing uh, towards your branches. So suppose one of the branch, I have the LAN infrastructure where I have WLC, where I have say ICE, where I have different technologies are there. For example, Lisp we are using locator separation ID protocol just to decouple the data and control plane, and there also you have VXLAN as a data plane. So if you have VXLAN, that means you can scale your data plane capability, you can provide the mobility feature with help of SDN. Okay, a way to distribute policy, intent, and DOS prevention. Now this is true with SDN. So this particular point is true with SDN. This also is true with SDN. This is also true with SDN. Now a new SDN or SD-WAN particularly. So inside new SD-WAN solution, you will find that these ISR routers, you can enable firewall that we have seen in the previous video. I can enable IPS IDS feature. I can do some sort of WAN optimization. Plus, we can integrate with DNS based security that Cisco is providing. They are telling that that is Cisco umbrella. So we can easily integrate our SD-WAN solution with the Cisco umbrella to provide security from the DOS attack. Apart from that, we know that now we are in the world of the distributed infrastructure, where I have the control plane somewhere and my data plane devices are spread across the geography. So now from the single place, I can send or push the policies to the data plane devices. Okay, so we touch all these points at the moment. Let's stop here and we'll continue, and we'll see other points as well, that what are the features and benefit we have when once we are adding the SDN to the LAN or the WAN or other infrastructure. Okay, so let's stop here and then we'll continue from here in the upcoming recordings. Let us discuss rest of the things. Now you can see that in the SDN solution, we have a platform for developing new control planes. And that's true actually. In our SD-WAN solution that we are going to discuss, you'll find that yes, we have the control plane, we have the data plane. This control plane, we'll come to know that in our SD-WAN solution, that is the SD-WAN solution, we have vSmart. Now, in this vSmart, we have intelligence built on. Means from vSmart, I can manage the routing, I can manage the security keys, I can manage the policies. So that's why you can see that, okay, a solution to automate network configuration and control. All right. A means to get assured quality of experience. Yes, in Viptela, in Cisco SD-WAN, we have quality of experience. Actually, this is related to cloud services. So suppose if you are running, say, Office 365, say GoToMeeting, where I'm recording all these things, any type of software as a service SaaS application, then you do not have track, means you can't track what is the loss, latency, and jitter. That's why we have one term called quality of experience inside the SD-WAN solution, that you can track or optimize, the track and then optimize the SaaS based applications. Okay. Then a way to optimize broadcast TV delivery by optimizing the cache placement and the cache stations. Yes, that's also true, that because now you have the centralized solution, and that is not related to actually the SD-WAN solution, but you can run this broadcast services over SD-WAN solution. So we have the centralized solution, say vSmart, and then the data plane devices. They are offloaded from the various things or from the various tasks that my control plane can manage. So for example, routing, IPsec tunnels, policies, etc. So that's why we can have some fast delivery system from end to end inside the data plane. That's true. A way to configure my entire network as a whole rather than individual device. That's again one key, because now we are talking about a unified fabric, and all these fabric devices are managed via the management plane. So I have common management plane, say in our case that is the vManage. So from vManage, I can manage the components of the fabric or the devices inside the fabric with help of template, or in ACI we have objects. So everything is object, and you have object and objects of object, inheritances, and all those object oriented things from where you can manage everything. And that's true. So from the central management plane, you can manage the entire fabric. That's the key actually. We have an open solution for customized flow forwarding control in between data center. Now, you can see in this particular slide, you have something related to data center automation, something related to SD-WAN. So this particular point is related to data center optimization. Most precisely, say layer 2 extensions we can do. So I have the controller that can help me to stretch the fabric from one place to other place. That's true. Develop solution at software speed. I don't want to work with my network vendor or go through lengthy standardization. That's true. So nowadays, what is happening, whenever solutions and design they are going to be proposed or they are going to be built, at that time the application engineers or application developers or the server guys, they are sitting with the network guys and they are telling, oh, I need to run my application over the infrastructure. I don't want to see any network. So like that, they're telling that I want application centric infrastructure rather than network centric infrastructure. And that's the key. We have in our SDN solution, either SD-LAN or SD-WAN, that yeah, things are, uh, so we are thinking application and then we are building the infrastructure, rather than we are thinking network and then building the infrastructure. That's correct. A solution to build a very large scale layer 2 network, that's related to data center, that yeah, you have say VXLAN features that you can extend the VXLAN, you can extend the data plane. So you have data plane extension from one place to other place, and you can scale it. That's the nice thing, that you can scale it, the data plane devices, irrespective of what's the location and identity, you can stretch. Actually, same is true with the SD-WAN solution also, because now you have the centralized control plane. So whatever geographical locations you have for your data plane devices, they have high scalability, because they can build the data plane tunnel or IPsec tunnels in between, and the overall overload for building the IPsec tunnels is very less, because they are forming all these IPsec tunnel automatically, and by default, like that is full meshed. A means to do traffic engineering without MPLS. That's the power of control plane. In our case, is V smart, V and smart. It has lot many intelligence, so it can do traffic engineering without MPLS. Even we are thinking all these ISP as a transit. So independent of transport, that's the key, one of the key feature of SD-WAN, that it's independent of transport. Okay. Then a way to scale my firewall and load balancers. Yes. Now, if you see the new product that Cisco has offering inside the SD-WAN, that is the ISR routers, where you can have the containers for firewall, say IPS, IDS systems. Then you can do virtual WAS, means you can do the application optimization. You can integrate the fabric with DNA. You can integrate the fabric with Cisco Umbrella, not DNA. DNA is again a term used for LAN automation. So you can integrate the fabric with DNS. Actually, I want to tell DNS security, that is the Cisco Umbrella. All right, so then you have these features related to security and the load balancer and the firewalls. A way to build my own security encryption solution. Yes, actually by default it is secured. So this SD-WAN solution, at the moment you bring up the control and data plane, your tight IPsec security will start and running, and then you can redirect your traffic towards the application firewalls, and even you can have the containers and you can run the zone-based firewall inside that also. So those possibilities are there. Solution to get a global view of the network topology state. In short, I can tell that this point is nothing but the visibility. Now, due to all these application awareness and all these type of infrastructure and the analytics that we have end-to-end visibility. I can say in terms of SD-WAN that I have full visibility across the fabric. So inside that fabric, and even I'll show you in the vManage dashboard in the upcoming section, that with help of vManage dashboard, at the moment you open the vManage dashboard, you can see, okay, how many vBonds are there up and running, how many vSmarts are there up and running, how many vEdges are up and running, vManage up and running, then what is the top talkers, what is the health, what is the control plane information, what is the inventory, what is the transport health, etc. So you have so much visibility with the SD-WAN solution. So these are the main things that we have, means these are the driving force that why we want to integrate SDN with the WAN. So if we integrate SDN with the WAN, that will make my SD-WAN, and then inside SD-WAN we have these important features. Okay, so I hope you understand all these features and the new capabilities if I use SDN, then inside my SD-WAN, and that's the driving force to go for this new technology. Now the next question is coming to everyone's mind is, where Cisco stand in this SDN solution? Means, okay, we have seen that there are so much benefit if I use SDN solution, software defined network solution, correct? But where is Cisco standing in this market? And what type of product that Cisco has for to support this SD-WAN solution? Now, if you see Cisco blueprint, you will find that what Cisco innovation we have in this particular domain, in this particular SD-WAN or SDN solution, you'll find that, okay, let's break down the infrastructure. So in infrastructure, what are the things you have? You have, say, branches, you have, say, WAN, and then you have data center, correct? Branch Cisco term is like campus area network. The WAN, you can think, okay, you have wide area network, that's the common thing. Data center is a data center. If you see that what type of customers we have, say in general, we have two type of customer. One is enterprise level customer. One is the service provider, correct? Now, so with respect to Cisco solution, so for example, with respect to enterprise, Cisco solution with respect to ISP, what type of branch automation, wide area network automation, data center automation, that we can see. Now, mostly Cisco is focused on enterprise solution, but there are so many devices which is supporting ISP infrastructure as well, like most of the ASR routers or maybe high-end Nexus switches that ISPs are also using inside their infrastructure, irrespective of SDN solution. Now, when we are talking about this SDN solution, then let's see one by one what type of things that Cisco is offering. First of all, branch. So see, this is my branch here circled, and this branch I can refer as a campus area network. For this campus area network solution, Cisco has offering SDA, software defined access, SDA. Generally, the main frame or the common name for SDA, software defined access, is DNA, digital network architecture. Inside digital network architecture for campus automation, we have software defined access, SDA. Now, the other hand, you can see that then we have the data center automation. For data center automation, Cisco has one very popular SDN solution, that is the application centric infrastructure, that is ACI. Other very popular VMware solution is NSX. But Cisco is offering ACI, where you have leaf and spine and those type of concept. Now, where our SD-WAN is fitting. So in between the data center to the branch offices, I have WAN automation, or I have WAN as a SDN solution. So that's why we have SD-WAN solution. And then again, inside SD-WAN also you'll find so many components. So DNA also you'll find the components. The SDN also you have various components. For ACI also you have various type of components. So what is the common in between all these automations or all these solution? The common thing is you have controller. So you have controller from where you can control these infrastructure. So for example, DNA, you have DNAC, DNA center. For SD-WAN solution, we have various components in the control management and the orchestration plane, but the engine from where you are going to manage the entire infrastructure is something called vManage. And here in ACI also we have the management plane or management device, that is the EPIC controller, application centric infrastructure controller, something like that. So we have EPIC controller, some C series server where you can do all these stuffs. So these are the controllers from where you can manage your different infrastructure. Now what Cisco is proposing, that by the end of day, means by the end of all this migration and solution integration, from DNA center you are able to manage the vManage, means your SD-WAN, and your data center, that is your ACI, and DNA center is already there for the branch. That means you should have one common. So now Cisco is telling, okay, we are moving towards a common controller, management controller, a single pane of glass. So from where I can manage the LAN, the WAN, and the data center. So this is the Cisco vision, and Cisco is moving on this particular area. All right, so let's stop here. All right. So Cisco has its own SD-WAN solution. Uh, Actually, it's not. Cisco has acquired one company for this called Viptela. Cisco purchase or acquire this company, Viptela, and then they have integrated the SD-WAN solution that was initially offered from Viptela. So now, even you are not seeing this term like Viptela, even the devices, if you see, say V Edge, V stand for Viptela. Later we'll see what are the components of the SD-WAN solution. But now Cisco has their Cisco SD-WAN solution. Basically, Cisco start their WAN journey, and better word is that they have enhanced their WAN into intelligent WAN. At the same time, so many vendors, they come with different approaches to automate and to provide better solution for the SDN plus WAN solution or WAN offering. So at that time, Cisco closely looked to different solutions, and then they acquire Viptela, and now we have the Cisco SD-WAN solution. Now, now we are talking about Cisco SD-WAN solution. So what are the components we have inside the Cisco SDN solution or Cisco SD-WAN solution? And in future, we can use the term as a Cisco SD-WAN simply. So I'm going to use this term SD-WAN, not SDN plus WAN, for our future references. What are the things we have? General things that we have in all the SDN solution, you will find control plane. So you have control plane. Then what you will find? You will find data plane. Okay. And then here you will find one other plane also, say management plus orchestrator plane. So here you can see the list also, the data plane, the control plane, and the management plane. So the actual movement of the data traffic will happen where? Obviously the data plane. So data plane are the devices hosted in the branches, in the data centers, in the cloud, maybe AWS cloud. They are actually there to forward the data or for do the actual traveling, or they are there actually to take the data and send somewhere or receive somewhere from somewhere like that. So data in terms of application data or any type of data traffic. But they are getting the instruction from where? So they are getting the instruction from the control plane. So now you can see the offloading of the data or the decoupling of the data and the control plane. So we have the data plane and we have the control plane. Data plane is only there to send or receive the data traffic, but as per the consultant of or consulting the or getting the instructions from the control plane. That is that we have the intelligent plane here. So here we have V edge, say Viptela edge, and now we have ISR or ASR devices. We'll see that complete list of the devices supported. In the data plane, control plane, we have purely software like vSmart, vBond, vManage, etc. So now in the solution, you can see that, okay, I am getting the instruction from the control plane to forward the data. Okay, and this control plane has, say, control connections with the vManage and the vBond. vBond is the orchestrator. vManage is something that from where you are managing the entire solution, entire Viptela fabric or entire Cisco SD-WAN fabric, etc. Okay, so important thing here to remind, and we are going to discuss more and more about this thing, that the data plane traffic has separate tunnel. That tunnel is IPsec, from where the data will from where the data will transfer inside that tunnel, and this tunnel has so many characteristics as well. They are getting the instruction from the control plane, that is the separate tunnel, that may be TLS, that may be DTLS. From where you are getting the control plane information or control information, that is nothing to do with the data traffic or data information. And then these controllers are managed via the management plane device, that is the vManage. Uh, that means inside the vManage, I have databases for all these devices. I have a configuration repository for all these devices. We have some store. We may have backup. We may have different stuffs inside the vManage. We'll see the architecture of vManage as well. Lately, you can see that I can connect or attach this vManage with the third-party API tools as well. Inside the Viptela solution, we have inbuilt API as well. But if you want, you can connect with some third-party tools for the automation for the APIs as well. All right, so this is the overall solution that we have inside the SD-WAN, so, Cisco SD-WAN solution, and this is just the top view. That you have the controllers in that you have the actual hardware or physical devices, hardware, physical and software devices in the data plane. You have the controllers in the management and the control and the orchestrator plane. That's true. One thing that we can note here, probably in the other part of the section you will not see, that all these devices actually they are paired with, so we'll see some sort of overlay protocol is running in between, and for all these data plane devices, their first interaction, so firstly they are interacting with the control plane device, that is the smart device, VS Smart. Its name is VS Smart. It's a smart and intelligent device to do various stuffs. And lately, they are contacting with the orchestrator and the vManage. Means they can send some uh, packets just to update or just to check about the view and etc. We'll see more on this. But at the moment, you can, if you see this diagram closely, or if you think this solution closely, that your data plane is tightly coupled with your control plane, and that's true actually. We'll see later on. So the main two component that we have in the SD-WAN solution is the VH or the branch routers as a data plane, and the control plane, that is the VS Smart. These devices are also very significant, but we'll see the use cases in the upcoming sections. Let's just stop here, and we're ready to move to the actual implementation and theory and the practicals behind this SD-WAN solution. So far, we have discussed about the problems that we have using traditional network, or in traditional network, we have so many problems. So what solution that Viptela is offering? Obviously, whatever problems that I have in the traditional network, overcome to those problems will be the solution. So here you can see one of the biggest advantage that we have in any type of SDN solution, that this is independent of transport. Separate transport from the service side. You'll come to know what does it mean by service side VPN and transport side VPN. But one thing for sure, that all these solutions are, all these SD-WAN solutions are independent of transport. So what does it mean? It means, suppose if we have different branches separated either via MPLS or internet or any type of broadband service, irrespective of what type of transport you have, these things will be seen equally from your edge or from your branch side devices or from your data center devices. That's why these are actually independent of transport. All these SD-WAN solution. Okay. Now the second thing here, that because we have decoupled the control and the data plane, and all the intelligence is with the vSmart or smart devices in the control plane. So that's why we have centralized routing intelligence and segmentation. How SD-WAN solution offering the segmentation will come to know, that we have say VPN 0 for transport, then we have say VPN 1 to VPN 511. So in between any number starting from 1 to 511, I can use as a service VPN, and then I have one VPN called VPN 512, This is used for the management VPN. And in this regard, you can see that, okay, since you have the segmentation of the VPNs or across the VPNs, that's why you have the segmentation feature. So you can see two highly desirable and important feature independent of transport, segmentation, centralized routing. The other major benefit we have that this network will secure itself automatically. So what does it mean? At the moment you bring up the control plane and then you add the devices inside the data plane, at the moment we'll do this bring up process, all these data plane devices, they will form IPsec, full mesh IPsec connection in between them. So at the moment you bring up the control data plane, they will secure themselves and you need not worry about the IPsec key scaling and the device IPsec scaling or multi-type of IPsec tunnels or point-to-point IPsec type of tunnel, etc. Your all these configuration, so for example in Cisco we are using DMVPN or other site to multi-site of VPN solution, all these things will be offloaded. At the moment you bring up the control and data plane, your IPsec will up and working. Then we have centralized management. Yes, we have management plane called vSmart. So from vSmart, I have a view of entire Viptela fabric, adding control plane, data plane, orchestrator plane, management plane. Everything I can manage from one single pane of glass. That means that we have the centralized management from the vManage. Then you have policy. So if I add the points in a single place, like if I have vSmart, so vSmart I can do centralize routing. From vSmart I can do centralize policy management. From vSmart they are doing the key management as well. So vSmart they can do all these things. So point number 2 where we have the centralized routing, and 5 they can done with vSmart. Then cloud readiness, yes, that's true. So at the moment in the traditional network, it's very difficult to track the software as a services or applications. So for example, Office 365. Now it's very difficult for all the branches who are using Office 365 services that they can track the performance of the application. So what is the latency, jitter, overall throughput of the application? And that is true inside the SD-WAN solution, because now we have one term called quality of experience, QoE, quality of experience, and they have the index value from 1 to 10, from those index value you can track the feasibility of the application or overall throughput of the application. So now you can see if I summarize all the features, so I have the centralized routing, I have the centralized policy management, I have the vManage from where I can manage the entire fabric, I have cloud readiness. This solution is independent of transport, and this is going to enable the segmentation. All these high features, high capable features we have, and that's why this solution becomes so flexible. And if you compare with the traditional network, you'll find that you can do at least 40 to 50% of cost saving, because you have all these features inbuilt inside the SD-WAN fabric. So now let's summarize that what we have studied, that this is independent of transport. This is the point number 1, independent of transport. The other feature that we have, that when we are deploying the branch sites, I can do zero touch provisioning. So at the moment you connect the device to the ISP facing interface inside VPN 0, that is the transport side VPN, then it will take the configuration, it will get authenticated, it will upgrade its image if it is running low image, and then your device or branch will up and running. So it's very minimum thing that we need to do. I don't need expert at the remote location to do the bring up process. From the centrally managed device, I can do this bring up. At the moment we are bringing up the control plane and the data plane, they will fully secure the data plane. Then we have the feature called segmentation. Here you can see different VPNs I have. The N last value is 512. That is for management VPN. But by default, these VPNs will not communicate. Sometimes you can refer this VPN as a Cisco VRF, virtual routing forwarding instances that we have, that you have, okay, VRF 1, 2, 3, 4. And by default, these VRFs are not talking to each other. So you need to do the route leaking in between so they can communicate. And here also I need to create central policy from VSmart to leak the route between these segmented VPNs. All right, so you can see the features are growing now. All these important features one by one, we can just add the feature. Okay, I can add. Okay, I can add. So, okay, this is given supporting this independent transport. Yeah, ZTP. Yeah, a secure fabric. Yeah, segmentation. Yes. Can I create multi-topology? So this is little bit complex type of feature. Once you do the lab, then you can understand. So since I can create the segments, say I have VPN 10, VPN 20, VPN 30 and 40. In that, so in that case, say VPN 10 can have the mesh topology, 20 can have the star topology, and 40 can have hub and spoke type. So you have physical connectivity, but on the top, that means you may have a different type of physical connectivity. When I am going to take the logical abstraction of that on the top layers in terms of networking as well, or in terms of networking, then for those VPNs, I can have a different view for those network that is there in the segmented VPN. So for some VPN, I can have VPN 10. For some VPN, I can have 20. For some VPN, I can have 30, 40, because these VPNs are on the device, okay, but they are part of fabric. So one branch, two branch, three branch, DC1, DC2, etc. So for all the VPNs, when we are creating the rules, they are like same. It's advanced type of technology, or advanced type of topic, I can say, that we can understand later on. So at the moment, if you're not able to understand, don't worry, but we have multi topologies supported inside the segmented VPN for the same physical connectivity when we are taking the logical abstraction off, is the complete statement. All right, then we can do the service redirections. Means if you have your firewalls or load balancers or other type of service devices, you can redirect the traffic with help of vSmart towards your firewalls or load balancers. So these are the, say, robust and the secure infrastructure features we have. Next, they can do application aware networking. So I have full visibility over the topology, over the network. I have complete WAN path control. I can create the applications aware routing. So I have that facility that I can do, say, app aware routing. It's a huge feature inside the SD-WAN. Means you can classify the application like HTTP, like VoIP. As per the SLA of HTTP, you can give ISP1, ISP2. As per the SLA of voice, you can define the SLA, and then it can, if they breach the SLA, they can go to internet or MPLS like that. So application aware ISP provisioning you can do, or application aware circuit provisioning you can do with help of app aware routing. Because why? Because you have full WAN control, you have control over your network, you have visibility over your network, and you can push the policies centrally from the central control plane. Then we can put the local policy like QoS. We can provide the security as well. And finally, on the top layer where I have the vManage, the management engine, from where I can manage the entire infrastructure. I can monitor. I have the full visibility. If I want, I can connect with the third-party tool for automation, orchestration, etc. And one nice thing about the vManage is that from vManage itself, you can manage all the devices. From vManage itself, you can push all the policies, templates, configuration. From vManage, you can itself do troubleshooting and reporting. But if you want, you can add some third-party tools as well, like for reporting. You can enable cloud reporting as vAnalytic. You can do some sort of automation with third-party tools, etc. So now you can see that you have full visibility, full feature, full encrypted facility, and all those things in the SD-WAN solution. Next, we have the components of the SD-WAN. We have two type of devices in SD-WAN solution. Mostly you'll find the controllers. So we have the controllers related to, say, control plane, orchestrator plane, and the management plane. Then I have devices in the branches like edge devices or the branch routers. We'll see the long list of these edge devices, supported devices towards our branches. In this section, let us discuss about this control plane devices or about all these controllers. So we have vManage, we have vSmart, we have vBond. Now all these controllers, vManage, vSmart, and vBond, they are software. That means you need hypervisor. So on the top of hypervisor, say ESXi or KVM, you can install these images. All right, so let me show you the link from where you will get more detail about these type of controllers. What you have to do, that you have to go and you have to open the URL, that is https sdwan-docs.cisco.com. Now if you go there and if you want to know more about, say, how I can install this particular ESXi over this particular controller or these controllers over ESXi, you can go and search, say, for example, ESXi, and then say create vBond VM on ESXi, create vManage VM instance over ESXi. For your study purpose, what you can do, you can download this from this PDF link and then you can study. Let me scroll down and let me show you that how you can do that. First of all, you need the image, correct? So also you can see step by step we can see here. So I can install over ESXi or kernel based virtual machine, that is the KVM. See the server hardware requirement. These are the links you can go click and open on the other page. What is the server hardware requirement I have for the vBond orchestrator, for the vEdge cloud routers, for the vManage NMS server. So you can see that for managing 1 to 250 devices, 16 virtual CPU, RAM, OS volume. Now because vManage is a type of server who need database. So that's why you'll see that I need, say, 500 GB data store, 25 Mbps it is supported. It is supported 3 vNICs. So what are these 3 vNICs and what is this specification? We'll see. We'll discuss later on. So one thing that we can mark here, that all the other controllers, they have only 2 vNIC requirement, correct? But vManage, you can see I am requiring 3 vNIC. See, all these controllers, they have minimum requirement of 2 vNIC, and here you have some sort of understanding. If you have some sort of understanding to the VMware, ESXi, and hypervisor, then that will be good, well and good. Apart from that, in the same link, you can see that I can check the vBond VM instances over ESXi, KVM, over AWS, installation of cloud routers, etc. So you have so many nice links here, even how you can install the or upgrade the Cisco IOS XE. All right, so from here you can see what is the server requirement to install this particular controller. Once you have to go and log into your vSphere client, again very much VMware related stuffs. Then you need to deploy the OVA. Now question here that from where I can get this OVA. The answer is Cisco download site. You need a proper CCO account to download those images. So you can see that image will look like something like Viptela-v manage. Once you call that OVA, then everything is like a step-by-step. You follow the step-by-step thing. Simply you have to give the data store because this is the vmanage. Then you can give the thin or thick provisioning. Thick provisioning is something that is recommended. All right, so you can see you can do all these steps, and once you do all these steps, once you add extra VNIC to this particular server, you go step by step, you complete all the process. Then by the end, what you will find that your vmanage get installed. Once your vmanage will get installed, then you can go and log in. So here you can see this particular step, that start the vmanage VM instance and connect to your vmanage console. Once you connect to the console after the boot up process, you will get this nice page called vmanage login. You can go and log in, no problem on that, and then you can do the configuration. We'll come back to this configuration and all, but this is the way that I can go and install the vmanage server. Later we are going to discuss more about this, so we'll discuss more about other stuffs as well. But this is the way, more or less, you can install all the controllers, not only the vmanage, but rest of the controllers over the ESXi. Now, why I need 3 VNIC versus 2 VNIC to all the other routers plus the controllers? The answer is, say, what is happening? Later we are going to study about this thing, that in this SD-WAN solution, if suppose this is a device, for example, this is the vmanage device, what minimum things he should need? So what is the minimum requirement it has? It should go and connect to ISP, or it should go and connect to the other devices, but it should go and connect the ISP. So that's why all these devices, they have something called VPN 0. So you should remember this, that I have VPN 0, that is termed as a transport VPN. I have VPN say 12511. Those are service VPN, generally used for the edge routers or the branch routers. Then you should have VPN 512. This VPN is used for management. This is management VPN. So that means you need at least 2 VNIC. One is for VPN 0, one is for VPN 512 for the controllers. Then why I need extra? Why I need third NIC? Because later we have one concept that is telling that for the redundancy purpose, you can create cluster of vmanage. Now, if you create the cluster, say cluster of 3 different vmanage, then you need one extra VNIC to sync the database. And that VNIC is something like message bus. So I need one extra VNIC to sync the databases across the vmanage. That's why in the vmanage I need 3 VNIC, one for syncing the database. All right, so let's see that what are the use of all these controllers. We have 2-3 use listed here in these slides. So with help of vmanage, I can certainly manage the entire Viptela fabric. I can integrate with the RESTful API. I can do the configuration management. I can do the monitoring. I can do the troubleshooting. I can do all sort of management with help of vmanage controller. That is my central management engine. Then next, I have vSmart. That is the intelligence inside the fabric. With help of vSmart, what are the things I can do? I can do centralized routing management, centralized policy management. So inside policy management, the service chaining, the traffic engineering, the app route policy, the net flow or C flow type of template, the data policies, the control policies, all those things will come inside centralized policy management. Apart from that, for the scaling purpose, they are doing the encryption key management as well. So both the propagation and you can see the propagation and transferring the key. Once they have the key, they bypass to the other branch like that. So yeah, we can use the term as a propagation. They are propagating the keys from one branch to other branch, from one DC edge device or one branch device to other branch device, and the DC vice versa, etc. Then finally we have the orchestrator plane that is termed as a V bond. Okay, so it's actually very interesting in the fabric. So anytime if any device want to join the fabric, wants to leave the fabric, who will they contact first? They have to update that information to the V-bond, and then the V-bond will work on behalf of all these requested to update the vManage and the vSmart that, oh, I have this device moving from the fabric. Now you can change your topology view. You can change the way you are seeing the fabric. You have to modify that. So he is someone who is working on behalf of, because you want to communicate with the global vBond as well, like the Cisco vBond server for ZTP processes. So it's recommended that it should be internet reachable, or it should have one public IP. That's why we are deploying this inside the DMG. It is using for the orchestration, means entire orchestration authentication the vBond is doing. It is helping us to securely bring up the fabric. All right, so these are the use that we can have with control plane devices. Let's just stop here. Next, we have data plane devices. You can see here we have data plane devices like vEdge, because Cisco has acquired this company. So now if you go and check what are the data plane devices I have, you can go to this site that is SD-WAN docs cisco.com. Inside that, you can go to software features. Let me navigate you through all these places. So once you are inside the software features, then you go to 18.1 release. So if you go to 18.1 release, or maybe say, let's see what releases we have. It's started actually with 14.1 till 16.2. It was with Viptela. 16.2 onwards Cisco has acquired, and then they put licenses. Means sometimes I used to get questions that can I bring up my own lab over Eve or over GNS3 or over any other emulator? The answer is actually it's difficult because of licensing features. So if you have license from the Cisco, then you can do that. Without license like GNS3 or other say for example viral, over viral also we can't emulate or simulate this fabric. Now suppose if you want to do a study about the hardware, you can go to any of the release, say for example 18.1, and I want to know that over 18.1 which type of data plane devices supported and which type of applications. If application means, is it supporting segmentation, is it supporting IPv6, is it supporting QoS, is it supporting optimization, Cloud Express, SaaS based application, etc. You can go and list down all the features that it is supported related to all the applications or related to all the networking features or cloud integration features, etc. So if I go here, release notes 18.1, why I am doing so? Because I want to show you that say 18.1, you can see from 18.1, March 30, 2018. Below are the main products featured in Viptela software 18.1. The Cisco's ISR 4331 router runs on 4331, and then you can see that from 18.1 Cisco ISR they start supporting with so many caveats and so many other stuffs. Now if you move to, say for example, 18.4 release, now we have 19.1 where we have EIGRP support as well. So for example, if I go to 18.4, which is one of the stable releases of SD-WAN fabric, now here you can see the release note, and inside the release note we can see that okay, now this branch devices, they are supporting iOS XE release 16.10, WAN release 18.4 onwards, or from there. What type of devices that are supported? So supported device list, you can see that okay, I can support iOS XE, say ASR 1000, ASR 1001 to HX, ISR 1000 and various series of ISRs. Then here you can see almost all the ISR routers with iOS XE, that is 16.10 and onwards, they are supporting inside the SD-WAN, along with the traditional VH routers like 100, 100B, 1000, 2000 and 5000. Now what are the features and what are the supported security features as well? Not only the normal features, security features as well supported in the ISR, because ISR you can work or make ISR as a container, and then you can install firewall or IPS IDS WAS application. Then you can run, say, firewall application, IPS application, URL filtering. We have DNS filtering, Cisco umbrella, cloud local domain bypass umbrella, etc. So now you can see these are the features. Still some of the features, they are not live yet, but they are going to be added in the upcoming releases, because at the moment Cisco is doing so many innovations and they try to add so many different plugins inside these devices and inside these feature and the product list. So ISR routers, you can simply go and check from Cisco sites and you can check the data sheet related to individual devices. Apart from that, you can see the VH devices are also supported, and like Cisco, you'll find okay, what is the LED status, what is the SD card slot, serial console, Ethernet management, USB control, what is the LED here, and the USB, etc. So like normal Cisco devices, normal uh, networking devices, you have all the slots, LED, fan, power slots, etc. The only new thing you will find in these VS devices, that they have some inbuilt something called TPM chip. So these devices have inbuilt TPM, Trusted Platform Module. Here you can see TPM chip for anti-counterfeit and secure authentication. Why they have? Because now we want the physical level security of these devices. Now these TPM chips, the OEM, the original manufacturer, they are putting different type of RSA keys inside this, and later we'll discuss more about why this is important to bring up the fabric or these devices whenever they are shipped with the TPM chip and the RSA keys inside that. It's almost like automated, means they have now capability that automatically they understand the organization security in terms of the certificates, so they can easily receive the keys, they can install the certificate, and they can join the Viptela fabric. So that's one of the use case with this trusted platform module chips that we have. You can see that Viptela, they have not only started the branch routers from the higher end to the mid-size branch to the low side branch, but they came with the solution of the Wi-Fi type of antenna based devices or routers as well. Okay, so these are the product list that we have. You can go and navigate to the link and you can check both type of devices, either it's a VH device or it's a ISR, ASR,
etc. Let us discuss about the lab topology. In our lab, we have two data center, say DC1 and DC2, and two branches, branch 1 and branch 2. So here you can see that I have DC1 and then I have DC2. Now, what is the IP schema we are using in DC1? In the LAN segment, let me draw the LAN segment here. So in the LAN segment, I have 198.128.128.0. Let me write here. So in the LAN, I have say 198.128.128.0/18. All right, and in the DC2, you can see in the LAN segment, I have 10. So 10.2.0.0/24. So these are the LAN IP addresses we have in DC1 and DC2. Likewise, in branches also we have LAN. So in branch 1, the LAN segment is 10.3, for example, 00. And in branch number 2, that is say 10.4.254.0. This is connected with one of the router that has subnet of 10.4.0.0. So these are the LAN sites that we have. Apart from that, we have the IP addresses assigned that when my V-Edge routers. So let me highlight here that how the Viptela fabric is, or how this SD-WAN fabric is. You can see here in between these yellow circle or yellow box, we are running our SD-WAN fabric. Now, with the DC or with respect to DC fabric, you can see that these DC devices, they are connected with CE routers. So I have MPLS CE, I have Internet CE. Again in DC2 also, I have MPLS, this is MPLS CE, and this is Internet CE. They're connected with the CE routers. Obviously, they will connect to PE, and then that will go to P routers, like that, this infra. But in the branch devices, they are directly connected to say MPLS, and they are directly going to watch the internet. So for example, in branch number 2, this router, this is branch number 2, one router has dual connection, but in branch number 1, I have two routers back to back connected. In between, I have HSRP or VRRP as well. Generally, we have VRRP. So in between, I have VRRP, but one router is connected with MPLS, other router is connected with the internet. So like that, we have the connectivity in the branches. Now, let's come back to the data center. Here you can see in the data center, the connection is bit complex. So here I can see that one of the V-Edge router is connected with MPLS, and then it is going to watch the internet. And then bottom also you can see the MPLS PE and the internet PE. Now good thing here is the IP address schema is very simple. So it is starting with, say for example, 172.168.10.2, or you can take 0 as well as a network. So 10.0.1.2 as the interfaces to watch the SD-WAN and to watch the CE router. So now 172.168.10.0, then 11.0, then 12.0, then 13.0. So you can think, okay, I have IP address 10.0, .11, .12 and .13. Likewise, if you go to DC2, the IP address is starting with 172.168, say 20, 21, 22, 23. Straightforward. We have IP addresses to watch the CE devices. Likewise, if I go to the branch and if I see what is the IP address to watch the ISP, so to watch the MPLS, always it is starting with 172.168. So here 3 dot, 0 for example, and the other branch 172.164.0. Towards the internet, we have IP 100.64. So for example, in branch 1, that is 3.0, and branch 2, that is 4.0. So now you can see all the IPs that we are going to use in this infra. Lastly, we have system IP as well over the boxes. The system IP is nothing but you can refer as loopback 0 address that can refer all the interfaces, and we have one unique system IP per box. So in our infra, we have 7 edge routers. How the unique system IP we have? We have unique system IP, say for DC1, that is say 10.1.0.1, DC1 VH2, that is 10.1.0.2, DC2 VH1, that is 10 to 0.1, and then 10 to 0.2. Likewise, in branch, this will start with 10.3 0.1 and then 10.3 0.2. Finally, we have 10.4.0.1. So starting with 10.1, then 10.2, then 10.3 and 10.4. So say if you ever see this, so for example 10.1, immediately you will understand, oh, this belongs to DC1. If you see 10.3, immediately you can understand, okay, this belongs to branch 1. So this is the IP schema we have, and apart from that, these devices, that whatever we have here in our infrastructure, these devices have something called site ID as well. So that site ID, all these branches on data center, they have site ID. Site ID, what is the use case of site ID, why we are using the site ID, we'll learn more and more in the upcoming sections. So this has the site ID 100, this is the site ID of 200, this is 300, and this is 400. Now site ID is nothing but the grouping of the devices in the same branch. So a data center has site ID 100, then all these devices has site ID 100. That means they belong to a site which is referred with a number 100. So grouping of the devices with same logical number is the site ID. So this is the overall topology we have. Let's stop here. Obviously, while we perform the lab and doing various tasks, we'll understand more about the IPS schema and the flow of the traffic in upcoming sections. Now the next question is that how I can bring up the control and data plane. So obviously in the SD-WAN, first of all, I need to bring up the control plane. Once the control plane is up and running, then I need to add the data plane devices. So overall, my control and data plane will come up and running. That is, my SD-WAN fabric is up and running. So control plane, that means that I need to bring up the management plane and the orchestrator plane as well. So we have to bring up the controllers, to more precise, and then we have to bring up the data plane devices. What are the steps involved for the bring up process? So for example, in case of control plane bring up process, I need to first of all install the software over the ESXi. I need to run up those operating systems over ESXi. So these things will be there in our lab. So for example, ESXi or KVM, whatever hypervisor you are using. So we have the images you can download from Cisco site and you can install over them. Then what are the steps again I need to do? So first of all, install all the control plane devices or all the controllers over the ESXi. That is the step number 1, 2, and 3. The fourth number and the onwards, you'll find that we have to do the minimum configuration. So for example, here we are talking about say vManage, vBond, vSmart. We need to do the minimum configuration. What does it mean by minimum configuration? Minimum configuration means that you have to do the configuration. So let me go back and get one slide where I can draw. See, what does it mean by minimum configuration? In normal Cisco routers, if you go and type show run, you can type show run, you will get output like what is the host name, what is the DNS IP or IP domain IP, then what is the AAA configuration, then what are the interfaces configuration, then what is the routing configuration, then what is the SNMP etc. Like that you will get one long output, correct? When you are doing the show run. Now if you go in the SD-WAN and if you type the show run command, you will find the configuration output in systematic way. Like first of all, you will find the configuration that is system wide. So you'll find system wide configuration, and here also you are doing show run like in Cisco. Then you will find VPN 0, VPN 12511, that is the service VPN, and then VPN 512, that is the management VPN configuration. Then finally you will find the policy configuration. So this policy may be local to the device, or it may be coming from the controller. So it may be coming from centralized location. Only these options you have, or these configuration breakup we have inside the SD-WAN devices. Now, yeah, if you go inside system wide, you have so many things. If you go inside VPN 0, you have so many things. If you go inside policy, you have so many things. And here we are talking about the minimum configuration. So that means if you are doing the minimum configuration, you have to do the mandatory configuration related to system-wide configuration. So you should do system-wide configuration, then you should do the mandatory minimum configuration for VPN 0, because this is your transport VPN. Here you have to do the configuration, and if it required, you can go and do the configuration for VPN 512, that is your management VPN. So if you do all these configurations, they will fall under minimum configuration. After that, you should do IP route, static IP routing towards the gateway. So if you do these things, minimum configuration plus the IP route configuration, you can bring up or you are going towards to bring up your control plane devices, because after that you have other steps also like certifications and all. Now because we are already here, so what are the things I have inside the system wide configuration? So let us discuss this. So inside system wide configuration, you have 5 very important, you can say mandatory configuration. You should give host name. Then you should give what is the system IP. Remember, this system IP was nothing but the analogous to loopback 0 address. This IP is over the box, and we'll see what is the significance of system IP later on. You should give the site ID. So what is the number? In that number I have grouping of devices. So if I have 100, number 100 at a site ID, and I may have 10 to 15 devices inside that site ID, means they belonging to same site. That is the grouping. Alright, then you should reach to the vBond. vBond is nothing but your orchestrator. So all these devices should have reachability towards the vBond IP address. And then finally you should go give the organization name. Why the organization name? Because you should have common organization name inside the certificate. So it is required for the certification process that you should have constant or common org name to all the control plane devices plus all the data plane devices. Alright, so these are the 5 things that we should give inside the system wide configuration when we are configuring the system. Then we have the VPN 0 configuration as well. So what are the things I need inside VPN 0? VPN 0 is something that your transport VPN, and you are connecting that transport VPN. So for example, first of all, you have to go inside VPN 0, then only you can go to any of the interface. So you have to go inside VPN 0 and then you have to give the IP address. Inside VPN 0, I should give the IP route as well. And that's it. It's not much required. We'll see some sort of other configuration also inside VPN 0. We need to configure this as a tunnel interface as well. Those things we'll see in the configuration. And then finally, you have VPN 512. Here also you can give IP address, either a static or dynamic via DHCP, because generally they are used for out of band management, OOB management. And then finally you have to give a static route. So IP route command you can give pointing towards the gateway. So these are the minimum configuration that we need to give to the boxes to bring up. Now what are the other things that we have to do? So do the minimum configuration. Okay, so step 1 2 3 4 5 6 done. Then I should have inter-controller connectivity, that is the IP router statement, static routes pointing towards the gateway so they can reach to each other. Then generate the CSR. 8 and 9, they are related to CSR or certificates. So we'll see later on in the upcoming sections that how the certification process done inside the fabric. Let me quickly show you the configuration related to the system-wide VPN 0 and if you have VPN 512 also. The next we have the vEdge bring up. I'll skip this slide. We'll come back when we'll deploy the edge devices, or we'll see the steps to deploy the edge devices. Now here you can see this is my system-wide configuration. So first of all, I can go like in Cisco. You can go to the privilege mode. You can type configuration T. You will come to this global mode. Here you can type system. Then you will be inside this system wide configuration where you can go and configure host name, your organization name, your system IP, site ID, vBond IP. Now here instead of IP we can use the DNS as well. Means this DNS is glued with more than one IP. So if one particular vBond will go down, still you have, say for example 1.1, and then for example I have 1.2. Both are pointing towards vbond.cisco.com. So if it is down, still the devices are reachable to the other vBond IP addresses. Very straightforward configuration. You can see there is nothing much on this. Then we have the VPN 0 configuration. Inside VPN 0, what are the things? So I can go inside VPN 0, and I told you that for vBond we can use this type of DNS setting as a primary and secondary. This is my vBond IPs .11 and .21. This is actually the DNS IP, but for vBond I can use this particular setting or this particular configuration. Host vbond.cisco having IP this and this. Then simply I am going over interface, assigning the IP address, static IP address 1.10/24. Then you should go inside tunnel interface. We'll discuss more and more about this tunnel interface. But if you go inside the tunnel interface, most of these configuration are by default. You do not need to do anything. If you want, you can turn on certain services. If you want, you can turn off certain services, like that. Then simply do no shut, and then you can give one static route pointing towards the gateway. Now same way I can go and configure VPN 512, and then I can go over interface, say ETH1 is the interface. Here I can go and give IP address, whatever IP address I have, and then finally obviously no shutdown like in Cisco, no shutdown. Then finally I can go and give IP route, and if I have this default subnet pointing towards the gateway, I can give the IP and the subnet, just like in Cisco also we are using these things. Now once you do all this configuration, you should run these commands, like you should go and check what is the configuration with the show configuration command. I will show you in the next video how you can check that via CLI. And then you should do commit. Generally we are doing commit and quit. It's very much similar in Cisco ASRs, and in the, even in the Juniper routers also we have such type of arrangements, and we have such type of hierarchy of the statements, that you are going inside VPN 0, then you are going inside the interfaces, then you are going inside the tunnel. So uh, what is the order here? That you are typing like this. Say if you are coming from Cisco world, conf t, then you are inside global configuration mode, then you are typing VPN 0, then you are conf VPN 0. I will show you all these things in the upcoming section. Then here you are going inside, say, interface ETH0, then you are inside, say, VPN 0 ETH0, then you are obviously you are giving IP addresses and all those things. Then from here you can go to tunnel interface. Then finally you are inside VPN 0 ETH0 tunnel, and then you can do the configuration like that. Finally you need to do the commit, and if you want to come out you can use commit and quit. Alright, so these are the basic configurations, minimum configuration related to bring up the control plane. This example we have seen with the vManage. Next we'll see what are the configuration and the change in the configuration with respect to vBond and the vSmart. Let us continue our discussion with the vBond and the vSmart deployment. So we have discussed that we have 5 mandatory things to be considered in the system-wide configuration. What are those? We should have the system name, we should have this system IP, site ID, your organization name, and the vBond location. Apart from that, we need to configure the VPN 0 and VPN 512 configuration as well. So these things are very important while we are doing the deployment for the, say, vBond, and when we are doing the deployment for the vSmart as well. So what I will do next, that I will go and log into the system, and I will show you the configuration. Here in the slide I can see that this should be vSmart, because here you can see vSmart. So I'll correct that slide here. This is the vSmart deployment, because everything is related to vSmart. Then I can go inside the vSmart, and then I can give the host name for the DNS type of vBond that I want to create. So these are the IPs for the vBond. This is the IP for my vSmart, the VPN 0 IP, and then static route pointing towards the gateway. I'm going to log into these devices and I'll show you the configuration as well. So let me go back and show you the vSmart and vBond configurations. So I have my vSmart here. First of all, let me show you the system-wide configuration. Simply I can go and type show run system. You can see the system-wide configuration. Next, I will show you the VPN 0 configuration. So here I have the VPN 0 configuration, and if I configure 512 for the management purpose, that also you can see. In this case, I'm using VPN 0 as my IP address. So inside that VPN 0, this IP address is used to connect to the gateway, and I'm using this IP as a public IP as well. So what is the hierarchy? Like in Cisco devices also you are going to conf t, but here you can go inside VPN 0 if you want to configure the interface, or you have to go inside system. Like in Cisco also, if you type question mark, you will get so many options. So here you can see these are the options related to the system wide configuration, correct? So for example, if I want to give the host name, I can give host name. If I want to configure the site ID, I can give the site ID. say for example 1055. If I want to give the system IP, I can give the system IP. I have to give the organization name, so I can give organization name, and finally I should give the vBond IP. So what's the vBond IP I have? Say 4444. Now once you've done all this configuration, you can go and type top. You can go top of this, and then you can check show configuration. So I can go here and I can check the configuration. So these are the things now I want to go and push. These are the things change in the configuration. For that I should do commit and quit. So you have to type this commit and quit, or you can type commit. It is recommended that before doing any commit, you do the validation. So I can do and I can check validate. Simply I can use validate command, or I can go and check say commit, and if I do commit check. So either you can use validate or you can do commit check just to confirm. At the moment it is telling that you can't do any CLI change because it is managed via the vManage. So all this configuration that you have seen here, I have shown you because just you have a reference on that. Next we have the vBond. So for vBond, if I go and check show run system, the only difference you will find with respect to say host name and the system IP and the org name and the vBond is the that the vBond statement. So here you will find that if it is a vBond, then we have to use this local. So vBond, IP of the vBond, and then the local keyword, and then the vBond only. This is optional. You can use, you can't use like that, but you have to use local. So you have to tell this vBond, oh vBond, you are the vBond with this local keyword. Then same, we can configure the system like we have done the other systems, and the same we can go and check the VPN 0 as well. So I can go here and type show run VPN 0. You can see the VPN 0 configuration. I don't need to use any tunnel or anything here. So I can leave it everything default, but I have the configuration, I have the IP route. Same I can go and check VPN 512. In this example, you can see that yeah, I have the IP DHCP client for vBond only. And if you want to check the IP configured over the interfaces, you can go and check show interface description. So then you come to know, okay, although I'm using IP DHCP client, is something I want to take the IP automatically, not the static IP. I want this via the DHCP server. The DHCP server is not functional, so that's why I don't have IP address assigned here in this interface. In our lab purpose, we are using all these public IP addresses for all the controllers. So for example, for vManage, we have IP address, say 198.168.1.10. For vBond, you can see that IP is 1.11. Like for vSmart, we have IP 1.12. This is vManage, this is vBond, this is vSmart. Then you will find other IPs also because we have two vSmart and two vBond. So you have 22 and uh, maybe 20n. Yeah, so we have 20 and 22 also. We'll see later on. We have these many controllers, 5 controllers. So with these IP addresses, I can go and log in. So once we're done up to this point, what I need to do, all these controllers should have inter-controller reachability. So I should ping from here to my vManage over the VPN 0, that is reachable. I should go here and I should ping to my vSmart, that is .12 over VPN 0. Even I have the other controllers as well, say for example 21 and 22, we'll see later on. And then I have 22 as well, so those are also reachable. So this is the way that we can go and complete our steps. Say from step number 1, up to step number 7. Later we are going to discuss about the CSR and how we can work on those CSRs. Let us continue our bring up process. So first of all, I need to go and log into the vManage server, and I have to put the organization name and the vBond IP. So I can go to the administration and settings, and then I have to give the organization name and the vBond IP. How you can do that? Let me show you. Let me log into the vManage server, and from the vManage server I will show you that how you can do that. So give the URL and HTTPS with the URL, give your username and password. Once you give the username and password, you will log into your vManage server. Once you are inside the vManage server, then from this dashboard here you can see that I can go to the administration and the setting. So inside the setting, you will find that you have option to put the organization name and the vBond IP. Once you give the organization name and the vBond IP, the next task you have to do is to add the control plane devices. Now I have my vBond and my vSmart that I want to add here. So I'll go to the device list. Here you can see that you have option of vEdge and the controllers. I need to go and click to the controllers, add controllers, say for example vBond. So once I click here, you can see that okay, you should give the vBond IP and then uh, generate CSR and send to the semantic for signing. Yes, it is already added. Then I need to go and add to vSmart. Now here the difference. Now you can see the difference. Now when I am calling the vSmart, at that time it is asking that is it a TLS or DTLS. But if it is a vBond even, it is not asking DTLS and TLS, because by default it is DTLS, SSL over UDP, and we don't have option, like we don't have tunnel option that I can create TLS based tunnels with respect to vBond. So that's one difference we have. Now I can use DTLS or TLS to generate the CSR, and in this way I can generate the CSR. Now the other question here is that okay, we have generated the CSR for the vSmart and the vBond. What about vManage? So for that, what you can do, you can go to the configuration and the certificate, and then you have the option that you can go to the vManage, and there in the controller, so you can go to the controllers and then you have option that you can go to the vManage and then you can generate the CSR. See, generate CSR. Likewise, you have to generate the CSRs. So let us go back to the PPT. So once you add the devices, then you need to go and add the controllers. You can add the controllers like that. For vSmart, you have option of DTLS and TLS. Once you add the controllers, then you need to generate the CSR for the vManage as well. So you can go and generate the CSR. RSA signature for the vManage. Actually, that is the CSR that we are going to generate. Now, one thing you can mark here, that while you're doing all this process, keep an eye here in the bottom. In the bottom, you can see that we have some things or some tasks to forward. So I can add device, generate CSR, upload the certificate, update the vBond. Okay. So at the moment, what we have done, we have added the device and we have generated the CSR. Correct. So that's why you will find two greens in the bottom. So at the moment you generate the CSR, you can see add device, and along with the add device you have generated the CSR. All right, great. And there is one difference here. If you see that if you are adding the vBond, means if you are in the vSmart and vManage, the update vBond option you will not get. But suppose if you are in the vBond,
This is taken from some other vBond. So suppose if you are inside the vBond, then why vBond will update itself. So that's why we have only three check mark: add device, generate CSR, upload certificate. Okay. So what is the next task we have is to upload the certificate. But to upload the certificate, it should be permanent certificate. It's not be CSR. So from the CSR, what we need to do, that with help of the root server, I need to generate the permanent certificate. That will be .pem file, permanent file. So I have my certificate authority or root server from where I am putting the CSR, and then I am getting the permanent certificate related to vBond, vSmart, vManage. I will download those certificates, and then I need to install those certificates inside the vManage dashboard. Correct? So we are going to install that, but before doing installation, we have one step. So what we have done so far, that okay, you have say added the devices, then we have generated the CSR, then from CSR we have generated the PIM file inside the root server, whatever certificate server or root CA we have from there. Now I have downloaded that as well, those certificates inside my local drive. From there I want to install these things inside the vManage dashboard. But before that, we should install. So this is the last step we have, that we should install the root certificate to controllers. So what we can do here, that okay, we know that there is one root key or public key we have. I want to install from the root server that particular public key to my to all the controllers, actually to all the controllers, to all the data plane devices. Everywhere you have to run this command, maybe some different format, but you have to request to root search and install. Maybe the method will be different here, but you have to install these certificates. So once you install this certificate, now the final stage is to install the permanent file. On the top you can see, once you go and click there, then you can upload the .pem file from whatever place I have from there, and then in bottom you can see upload certificate, update we want. So these two steps will proceed. So if I go next, you can see I have uploaded the certificate, and now in the bottom you can see all the check marks done. Likewise, I have to do the same step for the vSmart and vBond, because we have three different .pem file. I can go and install. Once I do all these steps, so once you've done all these things, then what you will find, that inside your dashboard you will find all green. So now if I go and click to my dashboard, you can see that I have devices added, say vSmart, vBond, and vManage is there by default. So this will be the final output that you want to see. And once you install your vEdge devices as well, then here in the edge device column you will find numbers. All right, so let's stop here. This was the method or the process that you have to do to install your certificates, or we can see in general term that to add the control plane devices to the vManage dashboard. Next, we need to deploy the vEdge. Let me show you the steps to deploy the vEdge. So for example, if you deploy one vEdge or more vEdges, the steps will be the same. So here, I'm going to deploy one of the vEdge, say branch 1, vEdge 1. You have to give the minimum configuration. Remember, the minimum configuration related to system-wide configuration was, you have to give the host name, the system IP, site ID, the org name, and the vBond IP. Once you do that, then you have to go and configure VPN 0, VPN 512. These are the minimum configuration. Plus here you have to give the IP route towards the gateway. So IP route towards the gateway. Once you do all these minimum configuration, here you can see that over VPN 0, over the interfaces, the IP addresses, these things we'll discuss later on. Once you give this minimum configuration plus the IP route,
towards the gateway to the VPN 0 and say VPN 512. Now here you have to do the authentication as well, authentication plus installation of the certificate as well. So what is the step now I have? First of all, I need to install the root key. Generally it is shared public key. I need to install over all the devices. Remember in the last section we have installed over the control plane devices or over the controllers. The same thing, the same public certificate or the shared certificate from the root CA you need to install. That's the first thing. Now, because this is the edge devices or this is the branch devices, so you can see that maybe you have thousands of branch devices. Now, all these thousands of branch devices, you are not going to do the manual installation of certificate because that consume lots of time. Rather than you will do some automated way to validate the certificates to install the certificates. So now here we have an important key point, like for control plane devices, because control plane devices are always less than the data plane devices. So in control plane devices we are doing the manual installation of certificates, but over the data plane devices we are going to do the automated way, because here the number of devices are very high. I can't do and go and add the VH certificate one by one to the for all the devices, correct? So that's very important point we have. And so then again you can ask why I am doing manual for the controllers, because anyways if you are doing those things manually you're providing some sort of more security to the infrastructure, because your control plane should be 100% secure. Data plane also secure, but if any problem with the control plane or the controllers, they can harm the entire data plane devices, even entire branch data center, etc. So now to make this data plane automated certification installation, or to make this installation of certificate towards the data plane devices automated, what you can do that you need list of serial number and token. So again we have one important thing, that while we are talking about the data plane devices we need some sort of serial number, chassis number. Now this serial number and chassis number you will get from the Cisco. Cisco will give you one list that you need to install. So not need to install but need to upload. So you need to install this file, that file. So what about this file and how I can upload? You have to go inside the configuration. You can see configuration, devices, then devices. And last time we have added the control plane devices. Here you have to upload the VH from .viptela extension. So how we can do that? Once you upload that Excel type of file, at that time it will ask you, and this is actually very important step that you need to check mark. What is that? Validate the uploaded vEdge list sent to controller. So you are sending those file, those updated list to your vManage dashboard. Now here you can see once you are uploading, you have the chassis number and you have the serial number in terms of token. Token is nothing but one time password. That first time it will be used for the authentication by the vBond, because vBond is doing authentication all the time. We'll see all these things later on. But by the vBond first will authenticate the serial number and chassis ID, and then he will bypass that information to the vManage and vSmart to build the tunnel. We'll see, we have a long list of process for this. What are the step number 1, 2, 3, 4, 5, etc. We'll see that. So now you have uploaded this file here, and Viptela bring up services are something based on white list model. So now you have the list of devices, but where it is? vManage.
Who is doing the authentication? Who is the authenticator or authentication plane? vBond. That means that internally vManage will send those lists to the vBond. That means once you upload here to the vManage, vBond have that list. And then if any data plane device, say one of the branch, try to connect or try to join the fabric, they will first contact the vBond, then they will contact the vManage. So vBond has to validate first this VH serial number chassis ID, and then only it will be authenticated, or it will be uh, joined by the fabric, because then the vManage and vSmart, they will form the permanent tunnel. So what is the last step in this? Last step is this, that since you have the serial number and the token, you need to activate. So these things I have taken from the serial, say remember .viptela file I have uploaded to the vSmart controller. Once you upload that, it's very interesting. So once you upload that file, let me go back. You have option to download also. Here you can see, let me highlight. Now, if you download this, you will get .excel or CSV extension. That means you are able to open in the Microsoft Excel. This will be in Excel format. But whatever you have uploaded to the Viptela, they say, for example, vManage dashboard to the Viptela controller or the vManage controller, that extension is .viptela. If you have this file, you are not able to open this file. You will open, but you can't get anything. Some sort of encrypted file, some other level of encryption. But once you upload to the vManage dashboard, then you can download that and you will get .csv. From there, you can copy the serial number and the chassis. So from that list, I have copied the chassis number and the serial number. Once you have this chassis number and the serial number, this is token actually, nothing but one-time password. It will be used for first-time authentication between the controllers and the edge devices. So the final command that you have to do for the final authentication is that request vEdge cloud activate chassis number token number. Once you do this, behind the scene your vBond will authenticate with the vEdge device, and he will tell, oh, this is the same database that I also have. Then he will bypass that information to the vEdge, and this is the bring up process for the edge devices. So once you bring up all your devices, here you will go and see your counters will increase. So 2, 3, 4, 5, whatever number of devices you do all these steps, all these processes, then you can see all the devices in the dashboard up and running. So let's stop here and we'll see more theory, what is happening behind the scene, and then we want to do the verification as well. So what are the CLI and the dashboard commands, or the GUI commands are there to do the verification for the, say, for the control thing, like for everything, say for control plane devices and the edge devices, or the branch edge devices. So for control plane and data plane, how we can do the verification. Let us do the revision that what we have studied so far to bring up the data and the control plane. Obviously, first of all, I need to bring up the control plane, and then only I need to add the data plane with the control plane. Now, while you are bringing the control plane, say, for example, vManage, vSmart, and the vBond orchestrator, what are the things they are doing? So they are forming permanent tunnel. This tunnel may be DTLS, this may be TLS, but we know this thing that vBond only support DTLS. So that means whatever tunnel I have with the vBond, that should be DTLS. Here you may have TLS or you may have DTLS. A strong authentication PKI certificate, 2048 bit keys. This DTLS TLS are highly secure using AES standard, that is the advanced encryption standard of 256 bit, and they are using the whitelist model. That's correct. So all these devices actually, they are checking that, oh, they belonging to the same organization. They should check
various parameters. So let me show you that what parameters all these devices they are checking. Now here in the diagram also you will see that valid certificate serial number, org number, org name. So org name and org name, organization name and the serial number. How they are doing the authentication? Certificates are mutually exchanged and mutual authentication take place. V1 validates vSmart and vManage serial number against the whitelist. So whatever list he has, he will validate the serial number. Correct? So V1 he is validating the serial number. Then what vSmart and vManage want to validate? So they are going to validate the certificate org name. Now these devices, they are checking the certificate org name. So V1 is validating the serial number, and the vSmart and the vManage, they are validating the org name. And then once they are satisfied, means once they do the two-way authentication, or we can say the mutual authentication, then they will form the permanent tunnels, permanent TLS or DTLS tunnel. On the other hand, when we are talking about, say, the vEdge router, vEdge router, we have discussed this earlier when we have discussed about the hardware of the branch routers. They are coming with something called TPM chip. Now what is this TPM chip? TPM is nothing but trusted platform module. And in this particular TPM chip, private and public keys are generated on the vEdge router. Certificate is generated, signed by Avnet. Certificate is loaded inside the TPM light chip on the vEdge router. vEdge routers has a root CA trust chain for semantic root. So these process we have seen earlier, that what you need to do, you need to install the certificate in case if it is a cloud router. And suppose if it is a hardware router, even you don't need to do anything, they will install, means the OEM will install the certificates inside that. Only thing that you have to do is to validate the chassis number and the serial number. So we have validated the chassis number and that token, and that token, once you authenticate with the token, that is the one-time password, OTP, then you will see that serial number as well. But what is the process? Let's see. We know that we have the orchestrator in the organization, that is vBond. So certificates are exchanged and mutual authentication take place between vBond and the vEdge over encrypted tunnel. Remember, it's a very important point that vBond is forming temporary tunnel. This tunnel is temporary. Let's see that why this tunnel is temporary. Now vBond validate vEdge router serial number and the chassis ID against the white list that actually behind the scene vBond is getting from vManage. So we have uploaded the .viptela file, and that .viptela file again the vManage will update to the vBond. That's why vBond has that list. Now the vEdge router validate vBond certificate organization name. Then what this edge device will do, he will check what is the certificate org name, because remember, inside the organization all the org name, so inside the viptela fabric related to same organization, inside all the certificates you should have same organization name, otherwise they will not do the authentication. That means your control plane will not sync with the data plane, or you can see that in the first place they will not form the DTLS tunnel. So if they do not form the DTLS tunnel, that means I do not have communication between the control plane and the data plane. And not only this, but I do not have tunnel between the control plane devices to other control plane devices. So everywhere we need DTLS or TLS tunnel. Now, provisional DTLS TLS tunnel is established between the vBond and vEdge. vBond returns. Now, from here you can see vBond working on behalf of. So he will return the list of the smart controller and the vManage. So what this vBond will do, that he will tell, hey vEdge, you can have the list of the vSmart and the vManage. And then what he will tell to the vSmart and vManage, that IP vEdge IP address. So they'll come to know how to reach to the vEdge. vWAN notify vSmart and the vManage of the vEdge router public IP. Provisional DTLS TLS tunnel between the vWAN and vEdge is terminated. So uh, once the vSmart knows the vEdge and vEdge knows the vSmart and vManage, vice versa, then this tunnel will be broke down. And now I do not have tunnel here because now they are going to form the permanent tunnel with the control plane devices vSmart and vManage. Now what vManage and vSmart will do, they will validate the serial number chassis ID, they will validate the serial number chassis ID of vEdge, and what vEdge will do, he will validate the org name of the vSmart and vManage, and then they will form the permanent tunnel. So now you can see that the security is really tight here, means they should do the mutual authentication. They should form the permanent tunnel, first of all, across the controllers, and then from the control plane to the data plane. And then only your Viptela fabric will come up and running. All right, so let's stop here. In the next section, we will discuss about how we can verify. Remember, few of the things happen here automatically. What are the things? So at the moment you bring up the control plane, that means your DTLS connection or TLS connection is up and running. At the moment you bring up the data plane tunnel, so let me write here. So control plane means your DTLS tunnel is up. Your data plane bring up means your IPsec tunnel. So not only the DTLS tunnel, but your IPsec tunnel will also come into the picture. So I have control plane here, and then I have data plane and data plane. We need to check this carefully. So from all the data plane devices to the control plane, you may have DTLS, you may have TLS, but from data plane to data plane, you have IPsec tunnel. So these things we are going to verify. And most of the things are happening behind the scene automatically, and that's the true power of any type of SDN solution, that you have proper optimization whatever you have seen in the traditional network. So whatever we have done so far, let us verify via the CLI commands. Now suppose if you want to check the control connection is up or not, what are the things you will check? First of all, you can go, the first command that you want to check is show control connection. That will be the first command. Now here you can see in the output show control connection. Let me run one more time. That you are getting the DTLS connections between your, say I am in the branch. So from my branch router I can see, I can go and check that okay, what are the control devices I am connected with, means say vSmart, 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 vSmart and vManage. So how the topology is, let me quickly refresh the diagram also. So how our setup is, that say for example, I have one branch where I have two vEdge routers. Suppose this is branch number 1 that we have. We have two ISP, say MPLS and internet. Over these two ISP, because I have vSmart 1 and I have vSmart 2, so say I am here at the moment over this device. So I have one control connection over MPLS, one control connection over MPLS, means two control plane device, so two control connection over MPLS, and I have two control connection over internet. Apart from that, I have one vManage also in the network. So I have one connection with the one active connection actually with the vManage. Now here you can ask that why I don't have one more connection over internet to the vManage. Actually, it will be a standby. So I don't have active connection to the vManage controller because that is not needed. So technically, my control plane is vSmart and my data plane devices are vEdge. So that's why we have direct active tunnels with the vSmart. But with the management plane, I have one active tunnel. It may be over internet, it may be over MPLS, it may be over LTE. It depends that what particular path you choose to reach the vManage. Later we'll see that okay, you can change the path also. We have option to do the traffic engineering related to reach to that particular controller. So this was the first thing that you want to check. The second command is that you want to check what is the control connection, and let me show you local properties. So if you go and check the control connection local properties, then you will get to know much more detailed output. So what is the personality of this device? This is the vEdge. What is the org name, organization, SP org name, certificate status install, root certificate install, certificate valid, duration, what is the DNS name, what is the site, what is the protocol, what is the port number, system IP, and token was something like OTP. So now it is invalid because now I have the serial number, etc. So you have the detailed information about the connection, local properties, and now I'm going to run one very important command. Generally, we used to run that command to do the troubleshooting. So that is connection history. If you run the connection history, you can see you have various legend. So for example, bind PTR, board ID not initialized, say CRT, VRFL, failed to verify peer certificate. Now if you scroll down and if you see tear down and then these like DSC, VDB, no error, etc. DC, on fail. So these detail about all these things, you can go on the top and then you can verify. So what was the DC on fail, etc. All these outputs, the full form and the what is the meaning of that, so DTLS connection failure. So suppose if your tunnel is not coming up, it is not working, say for example with VBond it is showing tear down, that means you can go to the control connection history and you can verify why it is not working, at what time it broke down. Time in the sense that what was the reason behind that this certificate is not properly installed, or what was the time frame last connection was. So those sort of information you will get. Finally, if you want to see the certificate installed in the device, you can go and check the certificate install as well. So you will get the full idea about the certificate, because remember from the CSR we have generated the .pim file. Okay, so this is something certificate, that is a .pim that I can see here. So these are the thing that we can do to verify, like basic few commands to verify the control connections and the certificate. If I type show history and just to give you the commands that we have done. So we have done show control connection, local properties, connection history, and certificate install. Now next we have to go and verify the data plane as well. Now again in the connection, you can see that various fields are there. So what is the peer, what is the peer site, domain peer, private peer, what is the uptime ID, etc. It's very straightforward. You can go and check, like once you run this command, you can see, okay, this is the system IP, this is the site ID, this is the domain ID, this is the VPN 0 IP, private port, public port, etc. So those things you can go and run the command, and most of the thing you will find it's very easy and straightforward that we can go and verify. Now next thing is to check the data plane. Now we have discussed this thing, and this is actually huge in this type of automation, that once you bring up the control plane, whatever data plane devices you have, that will come and they will form actually by default full mesh IPsec tunnel. So that is actually good. And say I have two data plane device, obviously you have your ISP. So you will find IPsec connection they will form in between that. Now important thing here to understand this, that now these devices, they are not exchanging their key values directly with the other side devices. So what does it mean? Suppose in the normal Cisco environment, you have 3 routers and you have say point to multi-point IPsec running on. In that case, what is happening? All the devices, they are sending and receiving the key value. So they can form the point to point, or they can form the IPsec tunnels. Now suppose this is only 3 devices. What if you have 1,000 devices? That means all the devices, they will send the keys 999 times, and that's the huge number. Even if the number of sites will grow, even just to manage or just to scale the keys, it's very difficult. Means a device, how many keys he can exchange, and then he can store, and then he can track those things. Here we are sending the key to the VS Smart, that is my control plane device, and then we are sitting idle. My only job is to send that keys to the VS Smart. Since the VS Smart is working as a router reflector, now his responsibility is to forward the key to the different branches from where I want to form the IPsec tunnel. So what he will do, he will send this key to other side, and other side key he will send to this side, and then they will form the IPsec connection. So now here you can see the complexity is very less. In the traditional IPsec configuration, the complexity is n square. Rather in SD-WAN, it's only n, the key complexity, key exchange complexity. And other thing, we know that at the moment we bring up the control and data plane, my IPsec will start up and running. So here I can see, although I have different VPNs, you will study more about that. So I have single pipe over VPN 0. Inside that I have tunnel for VPN 10, 20, 30, etc. The important thing here, you can see the definition or the points. Each V edge advertise its local IPsec key to whom? To VSmart. Symmetric encryption keys use asymmetrically, and that's actually nicer statement. So why? Because then VSmart is sending these keys here, and again he will also send his key here, and he will send that key here, and then they will form the IPsec tunnel. Okay, so that's why the symmetric encryption keys use asymmetrically. That particular statement is true. So once you have your IPsec tunnel, the other thing that is on by default is to track this IPsec tunnel. Now these IPsec tunnels, whatever end-to-end tunnels I have, obviously by default it will be the full mesh IPsec tunnel. Now who will track the liveliness of this particular tunnel? So BFD is there. At the moment tunnel is up, BFD start tracking those tunnel. They will send 1 second of hello timer they have by default. They are sending those hello keep alive to the remote end, and they start tracking the tunnel. So if I list some of the features that is coming up at the moment I bring up the fabric is, say once you bring up the fabric, then your tunnels like TTLS tunnels are up, not only with the control plane but with the data plane also. Your DTLS tunnel will be up. Third thing will be up and running is the IPsec. So you have full mesh IPsec up and running. The fourth thing, that automatically BFD will start tracking the IPsec tunnel, and we have so many use cases for this particular BFD. This BFD is used not only to check the liveliness, but it is useful inside the app aware routing policies as well, where you want to track the application loss, latency, jitter, overall performance. Okay, so loss, latency and jitter, those things you want to measure. So these things will be on by default. Even later we'll study that fifth number is the overlay management protocol, that will also on. So few of the services, because this is the optimized SD-WAN solution, at the moment we do those things, the other services will start kick off and they will be running. Now let us go and verify some of the commands related to data plane. So here I am inside the branch 1, and I can go and I can type show IPsec, inbound connection, and I can go and check outbound connection. Later we'll discuss more about why I have these many number of tunnels, and we'll see in the vManage dashboard section. I will cover these things, that these many tunnels why we have. Other thing that I can go and check, that is the show BFD session. So whatever number of uh, whatever number of tunnels you have, the same number of BFD sessions will be up and running, because all the tunnels by default they are tracked by the BFD packets. So for example, I'll give you one example here. Say I am in branch and I have two routers here. I have two ISP connected. Say for example, connected to data center DC. So I have one device here, one device here. How many tunnels they will form in just in these number of devices? See, he can go like this, he can go like this. Now he can go like this, he can go like this. You have 4 tunnel with one device. Okay, and since you have DC1 and DC2, so that's why you are seeing 4 plus 4, 8 tunnels. At the moment the branch 2 is down, so that's why. If I go and show you the inbound connection, you can see 1, 2, 3, 4, 5, 6, 7, 8, 4 over internet and 4 over MPLS. Now I am at the branch 1 VH1. With help of system IP itself, you can identify that what type of tunnels means from where to where. So already you are in branch 1, you are going to DC1 VH1, DC1 VH2, DC2 VH1, DC2 VH2. Then to reach DC1 VH1, you can go via MPLS, you can go via internet, and vice versa. You have 8 different tunnels, and that's why you have 8 BFD sessions as well. Alright, so let's stop here. Our next topic is vManage dashboard. What are the things we have inside the vManage dashboard? So let me log into the vManage dashboard. Here you can see on the top, or even you can think like this, okay, you can divide this dashboard into certain columns and certain rows. So you have columns, the first column where you have the device status, what is device is up or down, rebooted, what is the certificate status. In the row number, so sorry, this is the row not column, we have this type of column. So in row number second, we have the status of the say control plane. It's down, fully down, partially down. The site health views, we have transport related informations. Even I can see the percentage utilization as well. One by one we will expand and see all those things. Then in the third row you can see that you have the inventory, the VH health, transport health, and finally in the bottom you can see the application and their health. So app aware routing and the top application or the top talkers. So at the moment I log into the vManage dashboard, this is the front panel. This is the front of that. Yeah, behind the scene we have different databases who are storing the configuration and all these statics. That is different thing. We'll check later on. But this is the front view. Now you can go here and expand all these tabs one by one. So we have inside dashboard, we have monitor, configuration, tools, maintenance, administration, and vAnalytic. And all these tabs, they have different purpose. So obviously as name suggests monitor, I can monitor the entire fabric. With configuration, I can do the configuration. So not only the device configuration, but configuration related to policies, configuration related to cloud integration, everything I can do from the configuration. Then we have tools like, and I can do the SSH or run some administrative commands from the tools. Then I have maintenance from where I can reboot the device, upgrade the images for different controllers and the data plane devices. Administration, where you have one main tab called setting. You can go inside the setting and then you can do the settings like what is the org name, what is the vbond IP, you want to create banner, you want to enable new features, you want to enable vAnalytic, etc. So you have multiple options inside the administration that you can go and enable. Then
Inside the administration itself, we have the manage user. So the user is like read only or write, read, or the full privilege, etc. It is recommended from Cisco that you use cluster of at least 3 vManage. So with the cluster manage, you can cluster the vManages with this particular tab. And finally, you have this vAnalytic that is nothing but the cloud reporting. So if you want to send all this data to the cloud to check what is the application health, site health, etc., and you want to generate the reports in PDF form, so that for that you have to enable this vAnalytic. So let me expand all these tabs and you can see what are the options I have inside all these tabs. Later in the course, we'll go one by one to all these tabs and we'll see more detail about that. Tools, you can see SSH, rediscovery, operational command, maintenance, software upgrade, device reboot, administration, and vAnalytic. Now, so let us go back to the dashboard, and from the dashboard, now it's very interesting here that from the dashboard, from the vManage dashboard, I can go inside vSmart dashboard or vEdge dashboard or vBond dashboard. So for the individual device dashboard, you can go from this dashboard. So what does it mean? I can click there to the up arrow, green up arrow, and then I can go to the more. I want to see the device dashboard. Now this device dashboard is nothing but the vSmart dashboard. At the moment you logged in, you're by default here, control connection. So that's why it is showing, okay, you have 4 control connections, like 2 vBond, 1 vManage, and 1 other vSmart. You can scroll here and you can see the detail about the control connection. So on the top you have the graphics. You can visualize that, and in the bottom you have the connection in detail, not only the control plane but the VS devices as well. So by default you can see at the moment I enter, I am here at the control connection, but if I go on the top like application, so application are related to VS devices. So that's why if I go inside DPI, deep packet inspection, you will not get anything. Event flows, you will not get anything. But yeah, interfaces, I have interface. So Ethernet interface and system interface. What is the operational status? What is the IP address, etc. I can see. TCP optimization is again related to the edge devices or branch edge devices. So you will not find here. And the WAN, TLOC, and tunnel also related to the edge devices. So finally, what are the things you can see here? You can see the control connection, then you can see the system status. So let me click the system status. Now because this is a virtual device, means it's a software, so we'll not find the hardware related thing like module, temperature, USB, power supply, etc. You can see what is the CPU, you can see what is the memory utilization at the moment. You can go and check events where you will get the major and the critical and the minor events. Even you can go back in the time and you can get the historical data as well. On the top, you can see that we have the filter option. I can go here, click the filter and the severity component event. So I can search, correct? So if you have so many events, you can go back in the history. You can search what particular event you are looking for from here. We have ACL logs, we have T-shoot. T-shoot is actually important. So from the GUI itself, from the dashboard itself, I can check the ping trace route. And in the VH routers, you'll find these options also enabled, like what is the device bring up, control connection, tunnel health, app route, simulated flows, etc. So suppose from the GUI itself, you want to ping. You can go here, you can give any of the IP. So for example, I'll give the vManage VPN 0 interface IP. So I know that is 198.1.1.10. And I can give the interface. Then you have probes like ICMP, TCP, UDP, source, destination, etc. You have don't fragment, by default disable. You can go and check the advanced option as well. So at the moment I just wanted to do the ping. If I do the ping and scroll down, you'll see that it is generating the ping and we have the nice output in the GUI. Alright, so let's go back. On the top I can click and I can go back. Likewise I can do the trace route. Now the other important tab
I have here is the real time, and I can have some sort of CLI type of output. So I can check the OMP related thing, reboot, software version. So if I go and click software version, it will show you what software version is running, like 17.1112, which is on at the moment. You can see the other devices are there, false, false, false. But at the moment, the running version is 17.2.2. Likewise, I can go and check the ARP table. Now these things I can check via CLI as well, correct? So let me show you that how you can check this via CLI. You can go to the SSH terminal inside the tools, and then you can scroll down where you have the vSmart 1. Let me create some space here so you can see the output. Yeah, so the CLI inside the vManage will come is something like embedded type of CLI. I can increase the font size so you can see this. So ARP, and then if you want to see show version, just all these things that we can see from the GUI as well. Now if you want to reach to that GUI via different view, so that option is also there. You can go to the monitor. So let me show you. I can go to monitor, network, and from there also I can go to the individual device dashboard, like for example vSmart 1. So in the real time you don't have so many options that you can see in the CLI, but still you have important things that you can check from the vManage dashboard itself. Likewise, I can go back to the dashboard, and then same way I can go and verify the vBond, because vBond is nothing but it's the orchestrator, correct? So from this orchestrator, say the application, the DPI flows, everything will be the same that we have discussed about the vSmart as well, because we don't have optimization and flows and all those things with the control plane devices. But if you come here to the orchestrator connection, like in the vSmart and vManage, we have the control connection, but this is the orchestrator because the vBond is orchestrator. So orchestrator connection, I can see, I can check the system status, the events, the ACL logs. I can go to troubleshooting. Just now we went inside the troubleshooting, and I have done the ping and the trace route. Here I can see the simulated flow option is also there. Then I can go to the real time, and here also I can see how many commands I have. So here again I can see less number of commands. Few of the commands are, say for example, orchestrator related. We know that we are inside the white list model, where whenever you are giving the list of the devices to vManage, he will upload the vBond. Now those list, if you want to see, you can go and use this command, that is orchestrator valid vEdge, orchestrator valid vSmart. It will show you the valid vSmart. It will show you the valid vEdge, orchestrator valid vManage ID. It will show you the valid vManage ID. So for example, let me go to the orchestrator valid vEdge routers. Do not filter, and then you will get the list. So at the moment 1, 2, 3, 4, 5, 6 devices are operational. One is valid but it is not deployed, because in our infra we have total 7 vEdge routers. Here you can see in the list 6 is operational valid at the moment, 1 is not deployed, so that's why it is not showing in the valid state. So this is the way we can go to the vSmart dashboard and the vBond dashboard. Let's stop here. In the next section we'll go inside the vEdge dashboard and we'll see the other options as well. Let us continue and let us go inside the vEdge device. Now if I log into the vEdge device, one thing you can see that for the vEdge device that I have some numbers. What is that? So along with system IP site ID vEdge device model, I can see that BFD is 8, OMP is 2, control is 5. So what does it mean? BFD directly points towards where? It is pointing towards the IPsec connection. OMP, what is overlay management protocol? We are going to discuss about this, but this is something peering to vSmart. So I have one vEdge router and I have two OMP peers, means I am peering with vSmart1 and vSmart2. Then control connection, this control connection is nothing here, nothing but your DTLS connection. So over the MPLS, I have two, because I have two vSmart. So I can reach to two vSmart over MPLS, and over internet also I can reach to two vSmart. So that's why 4, and then 1 is for vManage. So that's why I have 5 here as a control connection. Now let us go inside the individual dashboard, device dashboard, and let us see what are the things I have. Likewise, I have in the vSmart that I can check the application, DPIs, flows, but see, vSmart, those things means options are there, but I actually can't see those things, correct? Why? Because these things are related to data plane flow or data plane traffic. Now, if I go and click, say, application and DPI, inside deep packet inspection, I can see some of the traffic that is going on, say network service and a standard. Then I have this filter option. I can check the VPN, TLOC, what is the local and remote TLOC. We'll come to know about that. Remote system IP, these option I have here in the bottom. You can select or deselect. So if you deselect, you will not see the graph, or whatever graph you want to see, you have to go and check. Percentage of total traffic is 93%. Usage is 106 MB. Then I can go and click to the flows. Inside the flow, this is for 24-hour by default flow. I can see what are the IP addresses from where I am receiving the flow. So in the bottom, you can see that you have flow destined to 10.3, that is the branch. 10.3, that means one of the branch. So I am here in the data center. So my data center to the branch, that is 10.3.0.10. I can see the flow and the usage of the traffic. Now you can see, so I can even filter. Now you see how powerful this tool is. I'm inside monitor, network, application flow, destination IP, the destination model. So I have this type of visibility that I can go and check, okay, this is actually the remote IP from where we logged in. So I have the flow of traffic destined to this particular IP, or you can see what is the flow source, how much MB, what is the percentage. So let us go back to the flows, and inside the flow you can see, if you want you can uncheck these things, so you can check the individual flow and the usage of the traffic. Not only this, but you can go and go back and forth in the time, the historical time, and you can check the flows as well. Then inside interface, so here you can see these are the interfaces, what are the operational state, and these interfaces, if I say mark one of the interface, you can see, okay, uh, the time July 18 and the RX, TX, kbps, all these things are there. Now suppose you find so many charts and you want to filter out some of the charts, then you deselect it. So if you are specific to gig 0/1 interface and the flow, then you deselect all the other interfaces. Then you will see only gig 0/1 and flow related to that. So this option we have that we can select or deselect the interfaces, and then we can go and check the flows. Alright, so this was the interface that we can check. Even we have checked the flows as well. Now TCP optimization, we haven't done TCP optimization in this case. So this is the default. You can see in the bottom, non-optimized throughput. This is without TCP optimization. Then inside that I have the flows, WAN throughput. So WAN throughput we have seen. Then I have the flows. So I have two flow here. One is the application flow. One is the TCP optimization flow and the top talkers, etc. Because nowadays everything is based upon the application. Now we have the network who is supporting the application. So we have the application based network, either it's a SD-WAN or SD-LAN or any data center. So we have these features. A nice thing about all these solutions that now we have end-to-end visibility. Initially we don't have such type of visibility, but now you can see that we have visibility. Even you can see I can go to WAN and I have this T-lock option to check what T-lock I have. So T-lock is nothing but I am in the data center. I have two ISP connection. One is related to MPLS, one is related to internet. So that's why it is showing two T-lock here. And over the T-locks, what is the jitter loss and latency I can see. Okay, because we have the visibility, so we can go and see those things. Then what I can do, that I can go to tunnels also. So we'll see that how many tunnels we have. Earlier we have seen that overall we have 8 different tunnel. So 1, 2, 3, 4, 5. Let me scroll it down. 1, 2, 3, 4, 5, 6. I can see 6 tunnels here. And let me scroll down so I can see all the tunnels. I should have 8 tunnels. And because why it is showing 6? Because we have deselected 2. Let me select all the 8. So I have 8 tunnels, obviously 4 over MPLS and 4 over internet to reach different sites. Now with the individual tunnel, I can go and you can see on the top you have the chart option related to say loss, latency and the jitter. And it's actually very useful when we are running in the production environment where we are very specific about the throughputs over the tunnel, what is the loss, latency and jitter parameter for the tunnel. So these things become very handy. Then we have the control connection that we have earlier. We have seen this control connection over MPLS and internet that we can see here. Then we can go and check the system status because this is also a software device. So that's why you will not see much about the hardware things. But yeah, I can see the CPU and the memory. Then we have the events. We have the ACL logs. Now inside the event I can go and I can expand any of the events. So you have the more option, check the device detail. So this is a VH1, AWS service, local gateway 0. Like that we have the latency and loss. So that's why we have this major event that is triggering. Then ACL log, then the same we have the troubleshooting. Here in the troubleshooting, you can see that now you have more options because now we are talking about the data plane device. So we can go and check device, bring up, trace route, tunnel, health, app route, etc. So now we have much more options in our T-shoot section. And finally, in the real time also, because this is the VS device and this device is supporting so many different data plane traffic. So you can see I have options, so many options. Although these options I can go and run via the CLI command, but here also you can see that you have option that you can go and check all the protocols basically and policies and the interface and the TCP optimization users, VRRP information, etc. So we have all these things that we can go and check from the individual device port. Then on the top we have the other things. So let me go back to the dashboard and let's at least complete the first row. So then I have this reboot and then I have warning. If I reboot any of the device, the counter will become 1 or 2, etc. All right, so let's stop here and in the next section we will check the other options that we have in the vManage device dashboard. Let us check rest of the tabs that we have. So next we have this control plane. I can go and click. It is showing yes, you have these 8 control. So you can see that okay, the VS Smart 1 control connection, DC1 4 control connection, DC1 VS2 4 control connections. Few of the control connections are common. So at the moment everything is working up There is no partial down, there is no control down. Then next we have the site view and the total site and the connectivity. It is showing you have three sites. So you can see I have site ID 100, site ID 200, site ID 300. That means I have total three different type of sites, and these sites, they are connected via the IPsec, and we have total 8 individual IPsec tunnels. We have counted down already. That is 4 for over MPLS and 4 over internet. Then transport interface distribution. You can see that most of the links are less than 10 Mbps. I can go and click this chart to see the overall. You can see the interface count and the overall upstream percentage, downstream percentage, who are the devices, what is the percentile utilization for these devices. It's very straightforward, correct? You can go and click and you will get the output for the 14 interfaces that we have related to different devices. So I can see what is the interface, what is the average utilization for all those interfaces. All right, then I can go and click the vEdge inventory. At the moment it is showing that 6 is deployed, total is 7. Yeah, one vEdge device is down at the moment. Which one? Which is this one? I haven't deployed, so that's why it is showing like this. Then vEdge health, you can see that 4 is normal, but 2 is giving the warning. What warning it has? So you can see the memory is overutilized. All the CPU is normal, but memory is more than 70%. So that's why we have the warning. We don't have any error. The error is 0. Then transport health. One thing I want to highlight here, you can see one square box. Now this is something, if you click this square box, then it will get expanded. So let me click here. You can see now I can see the transport health with respect to chart and with respect to details, that is the table. On the top, I can go and check the latency and jitter, etc. Then I have the time frame also. So 1 hour, 3 hours, 6 hour, etc. I can see average loss, latency and jitter related to the transport. Then finally, I have the top application. Now these top application also, you have the box, you can click to expand that box. Here also you have the DPI, here also you have the flow option. Now one thing you may noted that this is showing you the aggregate, means irrespective of what devices and what VS devices at which location, we are getting the, say, DPIs and the flows. Now, if you want to see all this information related to one individual device, then you have to go inside that individual device and then you have to check the flows and the app route, etc. Correct? So we have this thing inside the individual device as well. But if you want to see overall inside the Viptela fabric, so what is the RTP, what is the unknown, what is the DNS, what is the SIP, all these applications you can go and check, and you will get one overview of all the devices, how they are reacting, what is the top applications. Then finally we have the application aware routing. Application aware routing, again I need to enable this feature. By default it is doing, because by default we have the policy called allow. So it is going via the default tunnel. But we have option that with help of VS Smart controllers, I can go and create app aware routing policies. I can classify the traffic like HTTP or SIP or RTP or any type of business traffic, etc. I can classify, I can group with respect to application, with respect to application family, and then I can create the policies, and then I can go and visualize that also. So we have nice visuals here. I can see one of the tunnel, that is a branch 1 VH1 MPLS to the DC1 VH2 MPLS. It is utilizing 15% of the overall bandwidth of overall tunnel utilization. So here I can see that You can see the loss, and so overall I can see here in the, if I go to the loss, and I can see 15% loss in the bandwidth, correct? So 15% loss is a huge. And at what time? So it is 24-hour counter. If I go and click 1 hour counter, chart is loading. Last 1 hour I can't see that particular tunnel, so let me show you this. If I go to 24-hour, I want to see the percentage of loss for branch 1. So what is this channel? Branch 1 VH1 MPLS. So branch 1 to VH, branch 1 to DC1 tunnel, and DC1 VH2. So let me scroll down. Branch 1, let me deselect all those tunnel. So branch 1 to, actually this I am looking for. So I can go and deselect all those tunnels. Let me deselect all those tunnels because I want to see the percentage loss over this particular tunnel over the period of time. So not 24-hour, say 12 hours. I can see 2% loss. 24-hour, if I go, at what time? So in this time frame, say 0 to 4, not exactly 0 to 4, but loss is like decreasing and again increasing, and after this time, that is 18 July 7:30, the loss is less than 3%. So now it is 2.41%. So overall, what bandwidth you have and what percentage of loss you have, you can see the latency and the jitter, and then you can see the RX and TS octets. So all these things you can see that how powerful this tool is. I can go, first of all, I can select a branch. For that particular branch, I can select the tunnel with that particular tunnel. So I may have two tunnels. So I can select tunnel A versus tunnel B. And that's the power of the app aware routing as well. So I can create a policy, and if the SLA will breach, then it will prefer A versus B. That's the app aware routing policy we have. So all these things we can go and check, and the bottom ones are really very nice, the top application and app aware routing policy. Apart from that, all these options or all these things that we can see over the front panel of the vManage dashboard is actually very important as per our VIPTELA standard, or as per our SD-WAN health and the device monitoring. Alright, so this was the dashboard tour, and let's just stop here. How we can configure the VIPTELA devices. Now we have multiple options to configure the devices. Uh, what we want in SD-WAN VIPTELA, that we want to configure everything from vManage. So I have one management plane, that is my vManage, and from there I want to manage all the devices configuration and everything. So that's why over the vManage, I can go and create the templates. We have that option that I can create template, and these templates I can push to the devices. So that means if I have template and that is for device configuration, that will be device configuration template. Now in vManage we have option, either this template is CLI template or CLI type template, means whenever you are going and typing show run, so whatever output you are getting, the same type of thing you can copy paste to a template in the CLI format. The second option we have, that we can create the device template from the feature template. So we have different small feature templates inside the devices, inside the vManage, and from that small templates we can create a big template for the device template. So you can think like this features very much similar, like you have small programs. Say I have one template for OSPF, one a small template for OMP, one template for SNMP. Like that you can group a small templates, and then you can group inside one big template that will represent the device template or device configuration template. So these options we have that from the vManage, we can configure the devices. Apart from that, we have ZTP process, zero touch provisioning for the V-Edge devices, and then we have plug and play option for C-Edge devices. Okay, so these are the all configuration options we have. Let me show you that how a particular configuration look like. Either it's a feature template or it's a configuration via CLI, but in both the case you have these type of things. So inside system, last time we have discussed about this thing that you have the big container called the device configuration. Inside that you have system wide configuration, you have VPN wide configuration, you have policy. Now this policy may be local, that is local to that particular device, or it may come from vSmart. Okay, so these are the important things we have inside the configuration. So we can see that, okay, inside system wide configuration, I can give the host name, GPS, AAA, OMP, SNMP security, system IP, site ID, org name, vBond, etc. VPN 0, where I am creating the tunnel that is going towards the control plane. It is going towards one VH to other VH. That's IPsec tunnel. So these options we have that I can give VPN 0 configuration, interface wide configuration, and I can give routing configuration as well. Then we have the service side VPNs. There also we can give the interface based configuration, VRRP. Uh, we can create over the interface whatever features we have, we can do that. Then we can give the IGP related configuration. We have VPN 512 for management. We have local policy. So once we move on along this course, and once we are going to configure, build all these templates, then you'll come to know these important things. Now system-wide configuration, as we have discussed earlier as well in the bring up process. So again, if you want to write it down, what are the components of the configuration, you have system-wide 1, then you have say VPN wide, so either VPN 0, 512, 12511, and then you have policy. The overall look and feel of this particular SD-WAN configuration is that hence these are your edge devices. So in between them, like from your VPN 0, you can go to your service provider. Behind this VPN 0, so you may have VPN 10, 20, 30, where you can build different type of configuration. Say for example, app route type of configuration, cFloat or NetFlow type of configuration, SNMP, AAA, etc. So overall, whatever we have studied in the traditional world, you have to add some automated features here in the SD-WAN. So what type of automated features? Now you have the centralized control plane. So how the data plane will communicate with the centralized control plane, that is the OMP protocol you have to add it. You have full automation of the VPN tunnel in the data plane. So like that you have to compare between the traditional and the SD-WAN world. These are some examples that how you can go to the global configuration mode like in Cisco, and you can do the system-wide configuration. So let us stop here, and the next section will continue discussing and will build our own template related to device configuration. Let us discuss that how we can go and configure the devices. Because this is the SD-WAN fabric, all the devices, they are part of fabric, so they should manage via the vManage. So that means I can create the device configuration template from vManage, and I can push to different devices. We'll see that what type of devices we can push and what are the templates we can push. But to understand this configuration template, first of all, we should understand the configurations inside the SD-WAN fabric. So what type of configuration and configuration hierarchy we have in the SD-WAN, we should understand that. So from vManage, I can configure the devices via the CLI template, via the feature template. These are the two options we have. Now suppose if that device is not managed via vManage, so you can locally log into that device, and via SSH or via any login method, you can log into this device and you can do local configuration as well. But if the device is detached from the vManage. If it is attached, then we can do CLI template, we can do feature template, and then we can create the configuration, and then we can put that. Now either it's a CLI or it's a feature, we have variation in this. We'll see that in CLI also we can create variables. In features also we can create variable. Both the way we can create the variable. We'll see later on. Before that, let's move on and understand the configurational parameter, or what are the configurational things we have in the device. So suppose if you go to Cisco switch and if we type show run, so inside Cisco switch or Cisco router, if I type show run, then you will get the host name, then you get the detail about, for example, DNS, then you will get some other AAA configuration, some other parameters you'll get, then you'll get interface configurations, then you will get SNMP, then you'll get final configuration, whatever there. But if you go to the vEdge and if you type show run, you will get these type of configuration. Means first of all you will get system wide configuration, then you will go and get VPN wide configuration, then you will go and get policy configuration. Now we know that this VPN can be VPN 0, that is the transport. It can be from VPN 1 to VPN 511, that is service. It can be VPN 512, that is the management. So transport, service and management VPN, related configuration, related routing configuration, etc. we can create from here. In policy, you can have local policy to the device. So for example, QoS, ACL, port mirroring, policing, etc. Or the policy can come via the vSmart in terms of global policy. So you may have global data policy that the device will download. So these type of configurations you have inside the box. So we have system wide configuration, we have VPN wide configuration, and we have policy. Apart from that, you will find very small minor things inside this. Let me highlight you all those things. So here you can see that you have system wide configuration, you have VPN wide configuration, inside that you have interface routing configuration, you have again service side VPN configuration, you have management, and you have policy. In policy you can have a global data policy that will come from vSmart to the edge device. So how you can go and configure this? It's straightforward. You can go and configure via the CLI as well, but that should be non-vManage mode. If you are going to configure via the GUI, via the vManage, then you have option, either you can do the configuration via CLI template or you can do the configuration via the feature template. Like Cisco, go to the conft, you are in global configuration mode, type system, give the system related command, exit from here, type VPN, give the VPN commands, and etc. You can carry on like CLI. But because this is the SD-WAN fabric, everyone is referring that you should use the templates from vManage. Your device should be managed by vManage. So these things we'll do later on with respect to vManage. System-wide configuration, what are the parameters you have? Host name, GPS, clock, AAA, logging, TACACS, OMPS, NMP security. Now, neat and good thing about this, with most of these things that you are seeing here, so in SDN solution, these things we can refer as an object, and group of object So this object is nothing but termed as a feature, and if you group certain features, a feature for example AAA, feature SNMP, feature OMP, all these features you can configure and attach inside a single configuration that will be your device feature template. Correct? So we'll see later on that for all these uh, options, all these variants or parameters, we can create one template, and then we can call inside any number of device feature template, and that's the reusability as well. So not only that you are creating the object, but you can reuse that, and that's the true power of the SDN solution. Likewise, we can create object for VPN 0, VPN interfaces, management interfaces, and then we can go and call inside the main function. Now how this VPN 0 configuration look like in from the CLI? Even in the GUI also you will get the GUI option, like the options where you want to check, uncheck, you want to put some value inside that, those options you'll get. But to understand the configuration, understand that how it is working behind the scene, we should understand the CLI equivalence as well. So once we are inside the VPN 0, I can go inside the interface, I can give the interface name, tunnel interface. I can go here actually and I can assign the IP address as well. Tunnel interface, inside tunnel interface, what features I have, allow services, bind, carrier, color. So we know that we should give the TLOC information, what is the system IP, what is the color, what is the encapsulation. So these things I can give along with, you can see along with encapsulation, I have preference and weight. Very much similar to BGP, preference higher is better, weight is also higher is better. So I can give one preferred tunnel towards vSmart rather than other while putting higher preference and the weight value. Then if you want to exclude certain controller group, this controller group is nothing but group of vSmart. So what you can do, suppose if you have vSmarts, you can create group number 1 and 3 vSmart are part of group number 1. Then you have other group, that is group number 2. 2 vSmarts are part of group number 2. And if this vEdge don't want control connection with this group of vSmart, he can use exclude command. We can give the hello interval, tolerance and time, last resort circuit, low bandwidth link, max control connection. Again, if you want to limit the number of control connection towards the vSmart, whenever we are telling about control, control means vSmart. So you can limit the number of control connection. If I give max control connection 1, so this guy will form only one control connection with the vSmart. NAT refresh, interval, port hop, vBond as a stun server, we manage connection preference. So you can see there are a lot many options, and obviously all those options they have their use case. So for example, we manage connection preference. If you have two transport, MPLS and internet, and your vmanage is referring one of the transport, by default the load will be 5, so range is 1 to 8, higher is better. So suppose if your control connection from your vEdge to vmanage, it is going via MPLS, by default weight will be 5, and if you want that control connection use internet, you can give number more than 5, maybe 6, 7 or 8. So you will find that you have active connection in this direction. Obviously this connection will not tear down, it will work as a backup. So if any problem in this connection, automatically the backup connection will come back. So that's why we are using this command vmanage connection preference. So here you will go and give tunnel interface and then the color, for example MPLS, and if you give weight, either decrease the weight less than 5, or if you give 6, that means the vEdge will follow MPLS or will prefer MPLS to reach to vmanage. That's the meaning of this. So, alright, so we can stop here, and in the next section we'll discuss more about the template and the structure and the use case. Let us discuss more about the template. So what are the configurational template? More precisely, the device configuration template. Devices, say define all device configuration parameter, enforce device configuration consistency, compliance across entire network. So what these things is that, okay, if you are managing everything from the vManage, then you can maintain the standardization and the you can maintain the common type of template, and that's the term called standardization, to all the branches. Either it's type 1, type 2, type 3 branch, means you can categorize which type of branch you have and which type of feature that particular branch needed. According to that, you can create the template. You can say that standard type of template for that particular location and branch, and then you can push. So that's why we have the configuration consistency and the compliance across the network, allow high degree of device configuration customization. That's true. We have that feature that you can create variable. We have the feature that we can do the customization of each and every entity inside the running template. So not only that we are creating new template, and the running template that is attached with the device, there also we can do the customization. Simple bulk device configuration provisioning using variables. It's very easy. So first time you will find that, okay, it's a bit difficult to create the template, but once you have all the object, you can reuse the template. You can push that single template to n number of devices with slight differences. So those are the power and feature we have. And finally, everything is managed by the vManage with the GUI mode. Even we can have the CLI template as well, but by the end of the day, your vManage is GUI. So we can manage everything with the GUI mode. Now, I told you that we can create the variables. So in feature template, we'll see that. I'll log into the device and I'll show you that. In feature template, you'll find that while you're creating the template, a small objects for different features like OMP, security, VPN0, interface, etc. At that time, you have option that you leave that inside template you have configuration. So leave those things as a default, or you set some global number 400, 500. So that will be set for all the devices in that particular template or with refer to that template, or you can create variables if you are using the device specific thing. This default will be blue color tick, this global will be green color globe, this device will be wireless type of router. So let me log to the device and let me show you this thing first. So I am inside the vManage dashboard. Let me go to the dashboard first. You can go to the configuration and you can go to the template. Now here you can clearly see that you have device, and then you can create the template. You have feature. So if I go and click to the create template, you can see again you have template, device template from feature template or from CLI template. CLI template means simply you can put CLI numbers, CLI value, whatever show run is there. Now when we are talking about the template from the feature template, and so for example which type of device you want to use, in my case I have vEdge Cloud. Now if you go, for example, if you go to AAA, and I'll give the name of this template, say test AAA and test AAA. Now if you see here, this blue color that I was referring, this blue color is default. If I scroll down, you can see this green color globe is global. You can go and put global value, and then if you want to define the variable, then you will get wireless router type of icon. So if I go and click here, you see this is the fixed value. If I go and fix some value here, it will be fixed. I can't change it. This is device specific, means it is a variable. And again, if you want to do some sort of cheating, you can go here and you type your hint. So not only that it will be variable, means while you push this template, it will ask you hint for me. Whatever number if you put the same thing while pushing the template, it will show you, oh, hint for me. This is the number, this is the IP, this is the site you are looking for, and then the default is default. So these values we have actually. Let me go back. All right. Now we have two type of template. I told you that we have CLI template, we have template from features. We are going to use both the templates to bring up our configuration or to understand more about the configuration. Now what is the method that vManage is using to communicate with the vSmart and the edge devices? So they are doing netconf to configure itself or to push the configuration to other devices. Configuration template are defined for a specific device model, not for vMon. So we have long list of devices nowadays that from vManage you can push the configuration with help of netconf protocol. Now what's the impact you have? You can see here that local changes are not allowed. So once this device is managed via vManage, either CLI uh, or the feature template mode, whatever mode it is, if you log into this device, if you do any local change, it will throw an error. It will tell, no, you can't do any local change. If you want to do any local change, go to edit that template and then you push and then you can do the change. So here you can see the local changes are disallowed because vManage has the higher preference. Local changes are allowed. Local changes allowed. Confirmation of one commit is required rewritten. So local changes are not allowed by any means. If you want to do any change, either change the template or detach the template from the vManage, do the local change. That is only option. So let me show you that what type of log error message you will get if you try to do the local change. So here I logged into one of the device. If I go to VPN 0 interface gig 0/0 shutdown commit. So what is not, this interface is actually not there. So anyways, let me go out, but you can see that it is throwing an error, and I should see that what interfaces are here present. So we'll go and check show interface and description. So let's see. Okay, 01 and 02 is there. So we'll go to the interface VPN 0 gigi 0/1. If I do shutdown and if I do commit and quit, if this device is managed via vManage, it will give this error. System is managed via vManage. This device is being managed via vManage. Configuration through CLI is not allowed because this is disallowed. So we'll do one thing, we'll stop here, and next section we will attach, means we are going to create our own template. With help of that template, we'll create the template and then we'll attach to the device and we'll see that how behind the scene it is working. Alright, so let's do the configuration with help of feature template. So before doing the configuration, I should know that what's the IP address and what's the other parameters. So let me go to the configuration and template and say I want to do the configuration for this branch. Say for example, branch 1 vh1, and at the moment I can see it is not managed via vManage. So I want to manage via my feature template. Before that, I need the configuration of that particular device. So let me go to the configuration and devices. Let me go and select the vEdge list, and from there I will go and check branch 1 vh1. I want his running configuration, because from that running configuration I can figure out what's the IP address and the other parameters that I want to use in the feature template. Because in SD-WAN fabric, what important thing we have, that we need to do the planning. Before doing any configuration, before doing anything, you should plan that how you want to do it. So here you can see that I can go to the system and then the host name and the GPS and the admin tech. So first of all, system-wide configuration in short. Then we have AAA configuration. Then I have this admin and the password, logging, BFT, OMP. So many features I have. So I will mark all the feature one by one. So first of all, I want to create the feature template for system, small template. Then I'll go create feature template for OMP. Then for example, logging, AAA. In the feature template, if you go and see, you'll find they are in the alphabetical order. But any order we can go and create. I'll create the feature template for VPN 0, VPN interfaces, and all these small feature template I will go and add inside the device feature template, that is for branch 1 VH1. Correct? So before doing this operation, let's try to understand that what exact configuration we have. So I should know that what's the DNS, what's the IP address over the MPLS interface. Say for example, in my template, I don't want to use QS. So I'll remove this QS. Then in my example, just for sake of simplicity, I just wanted to deploy the or create the feature template having only one interface going towards MPLS. And then I should have VPN 512 for management. So you should have VPN 0, minimum configuration is VPN 0 and VPN 512 for your correct deployed or for your running deployed system or configuration. So apart from these things and the mandatory system configuration, I'll go and remove other stuffs. So I'll go here and I'll remove this configuration that is related to internet. So let me go and remove, and then I don't want to use tlock extension at the moment. So I will go and remove. That's why I will go and remove the tlock extension IP route. In my configuration, I don't want to use at the moment the service side VPN. So I'll go and remove VPN 10, 20 and 40 configuration. But I want VPN 512 configuration. Apart from that, I have some local configured policies. So for example, the QS policy. So those things also I don't want at the moment. So I'll go and remove all those things. So now I have the policy, and I should have some baseline policy, say like app visibility and the QS related small stuff like cloud QS. Alright, so now this is my configuration. This particular configuration I am going to use in my device configuration for branch 1 VH1, and once I go and push the configuration, you can go and check the changes as well. So if I go back to the CLI, let me log into the CLI, and here if I go and check show control connection, at the moment you will see that this particular device, so let me go and type show control connection first. How many control plane connection it has? So it has 4 connection with vSmart and 1 connection with vManage over MPLS. And if I go and show you show interface description, so how many interfaces he has? He has 3 interfaces in VPN 0 and rest of the interfaces are in service side VPN. After deployment, you will find that we have only one interface because I'm going to use only 1 gig E00 and one interface in the management VPN. Rest of the configuration also will be the less that I'm going to use. So let's go back and do this configuration. So for that, you should go here to the template, and now we have two options. Either I can go and click here create template and say for example create template, I can choose the device. Now one by one I can go to these templates, I can create the feature template from here. So what I am telling, that two way we have, either you can go log into the device feature template, and from there you can create a small feature template, a small feature template like this. Here also, here you can go and create a small template. That's the one way. The other way, that you go to the feature template itself, create all a small template first and then call inside this. Okay, and that is actually the logical way, that we should create a small feature template first, and then we should call inside the main template. So let's do in the other way. Let me go and click cancel here. I'll go to the feature and I'll create a small feature template for my cloud edge router, starting from AAA, banner, and all those. So let's just stop here, and in the next section we'll create this small feature templates. All right, let's continue. So for AAA, I don't want to change much thing inside the AAA configuration, but I'll give the name as test AAA new, and test, say, AAA new. If you know all the configurations, the CLI, more precisely CLI configuration of AAA, then what are the things you have to give? Give the authentication, the local database parameter, radius, TAC access parameter. At the moment I don't have all those things, so I'll click save, and that's very much my template related to AAA. Again, I'll go here to the cloud. I don't want to create any archive. Banner I want to create. So we'll go here and create, say, test banner, and I want to create login banner. Now you can see I am giving the global parameter. So it will not ask me that what you want to create. Means, is it a variable? So for example, one banner I'll give as a variable, he will ask you, and one of the say MOTD message of the day I will give as a fixed value, that is the global value. So do not log in. Alright, let's click save here. So now we can see that how quickly I have created two feature. Then I'll go and create feature for BFT. Again, if you know that how BFT is working, what are the parameters we have with the bidirectional forward detection, say you BFT collecting information per tunnel, or it's a multiplier or Paul interval. If those things you know, you go and put those value. Otherwise you can leave this as default. Sorry. Otherwise you can leave this as a default and click save. So now we are increasing the templates. More precisely, we are increasing the feature template. And in this section, if you see, template type is non-default. So obviously whatever template that we are creating, those are coming under the category of non-default. So you have non-default and default template. Since we are creating the non-default template and I am giving some common name, so test is my prefix. If I want to go search my template, so whatever test template I have created just now, you can see those templates. If you want to edit, you can go to the more button or menu button, you can go click edit, you can edit it. But at the moment I don't want to edit. Let's go and continue our work. BGP I don't have, bridge I don't have, DHCP, IGMP, logging I'll go and create on logging as well. Here also I'll give say test triple A. Sorry, not triple A, this is the logging. Say logging. So your name also should be as per your corporate policy or as per your organization. At the moment I'm giving any random name, but it should be say uh, even if you're following the nomenclature for that particular organization, you can follow the nomenclature for the templates as well. And nice thing about this template that in future if you want you can edit and reuse also. Multicast NTP OMP. So for example for OMP also I will create test overlay management protocol test OMP. What is the basic configuration? By default, whatever default configuration or whatever variable related configurations are there, those are good only. But if you want to change as per your policy, you can go and change. There is no problem. So now you can see that our template is populating and we are creating new templates. So I am not using OSPF PIM security. I will use default security. SNMP, I will use some default SNMP, then the system. Let's go and create system wide template. So I'll go here and give say test system. That's the name of my template. Test and system. Now you will see that you have multiple options here. So if this particular template is going to use by various devices, then site ID I mark as a variable. So by default it is a variable. System IP I mark as a variable because different devices has different system IP. Overlay ID leave it. Host name different devices has different host name. That's why. So it will ask these things. Oh, you are looking for host name? You have to put this. And then we'll see that what options we have to put those values while we are going to assign the template to the devices. Tracker, if you want to track any NAT, WAN facing NAT interfaces, advanced, then you have the DTLS, port hopping, DNS. So much options you have. Route consistency, idle timeout, eco-friendly mode. Say some of the terms, suppose if you are seeing, oh, gateway tracking, and I don't know what gateway tracking is doing, you simply copy this term, go to the SD-WAN site, put there. So let me show you that how you can do this. I have copied that thing. I came here to sdwan-docs.cisco.com and then I can go and search this particular feature. So what is gateway tracking? And then you will get nice document related to tracking and all. So this is the way that you can go and check if any of the parameters you don't know. You can go and verify what this particular feature is doing inside the template. Alright, so we can click save. So our system-wide template is also built. Then again, I will go and create the VPN template. So we'll go scroll down, we'll go to VPN. See, you have VPN option and then you have VPN interface option. So we'll go here inside VPN. First of all, I will create the template related to VPN 0. What configuration I have inside the VPN 0? Let me show you that. So if I scroll down, here it is. So first of all, we'll create the template for VPN 0 and these values we are going to put. Then I will create the template for VPN interface. Okay, so let's go and create that. And what's the DNS IP? Let me copy primary and secondary IP. So I'll copy this primary and I will edit the secondary. So we are here. This is nothing but test VPN 0. This is name is test VPN 0. What VPN is this? I'll put the global value. Global is green color globe. Then name ECMP keyring. TCP optimization off by default. What's the primary DNS? I'll go and put global value because the DNS things will not change. It will be constant and common for all the devices. So I'll go and give primary and secondary DNS. Then it is asking about the vBond DNS. So we have the vBond DNS, the name of that. I should give the name and the IP. So let's give the name and then we'll give the IP for that. Let's go back and check what's the IP we have. And if you have multiple IP addresses, you can use the comma separation and you can provide that. So we'll go back here, we'll put this, and then we have 21, add this. So now our DNS configuration is done. We have saved that. Then you have OMP configuration, IPv4 configuration. Yes, I have a static route pointing towards this particular gateway address. So we'll go here and we'll add the IPv4 route. Go here and scroll down. You can give the prefix and what's the gateway. We should go there and add the next hop. This is the next hop. You should click add here first. You should click add here second. So this will be added. Then IPv6 I don't have, services I don't have, GRE I don't have. So I will click save. So now you can see that we have successfully added our VPN 0 configuration or template. Now I will go and create the template for VPN interface. So let's go and create for that also. And I should know and I should put the correct values related to the interfaces and the other parameters. So let me show you that. So this is VPN 0 and then interface MPLS. Yes, the same name I will go and use here. And then shutdown. Yes, it is shut down by default. I should go here and click no shutdown. First of all, what's the interface name? So we should give the correct interface name, that is gig E0/0. So here you can see the interface name. I'll go there and then I'll give the interface name gig E0/0. If you want, you can give the description, otherwise you can go here. And now it's optional. You want to give the variable for this particular IP because maybe this template will be used for different devices in the same site or in the same branch. So here I'll give the cheat sheet that this is MPLS IP. So this is MPLS IP. Put correct IP like that. So what's the use case of that? We'll see. Then that particular interface is tunneled interface. So I should go here and click tunnel interface. Click on. Once you click on, you will get other options. So inside tunnel, what type of configuration we have? Let's go and see. So tunnel interface encapsulation IPsec preference 200, color is MPLS restrict and the default value. So we should go here and give the color as a MPLS. Still, if you want to make this variable, you can create it. Restrict is off by default. I'll make this on. Restrict simply means if two different sites has same type of color, and if restrict is on, they will form the tunnel. So MPLS, only other side is MPLS, it will form the tunnel. If restrict is off, then MPLS can form the IPsec tunnel with internet or other colors. Alright, so we are very much done at this point. Likewise, we'll scroll down, and we have to put the IPsec preference as well. So here, if you scroll it carefully, you will get some advanced options as well. So let me go down here and I'm looking for that. So let me click tunnel, and inside tunnel, if I scroll it slowly, so I can't see that advanced option. Let's scroll down. Here we have, yes, here you have the advanced option. So in the advanced option, you can see the IPsec is by default on, and what preference you want to put. Say for example 200. IPsec weight is 1 by default. Rest of the things are okay. Let's see here. Yeah, rest of the things are 100% okay. So what we can do now, we can go back here and we can click save. So ARP I don't want, 8021X I don't want, advanced I don't want. I'll click save. So we are very much done. The only things that we have to create now is two more template. One is for VPN 512 and then one is for VPN 512 interface. So we will go here and then we'll give the name as a test, say VPN 512 test VPN 512. What's the VPN? This is 512. And what's the configuration, static route configuration I have for this? So let me scroll down. The routing configuration is static route pointing towards this gateway. So we'll go here, I'll go here and click IPv4, put the gateway and the route. Let me scroll a little bit down. We'll go and put 0000/0 and then I will give the next hop. Give this next hop, add it once, add it twice, click save. Wow. So we are creating all the template. Let me go and create the last template. That is nothing but the VPN interface related to VPN 512. Alright, so we'll go here and type test, say VPN 512 interface, and the same thing I should copy and paste. Yes, and then shutdown is no. What's the interface? We should give the correct interface name and the IP for that interface. So let me copy the IP. But suppose if you are using the DHCP, you can go and use the DHCP server. Means you have to give the option. So let me show you the option. This dynamic. If you are using IP via the DHCP. Otherwise, in our case, we are using some static IP. So I'll use this globe. That means it is fixed. If I do not use this globe, I should go and use this wireless router, and I should give something here that this is for management interface. Alright, so we are almost done, because apart from that we don't have tunnel, we don't have NAT, VRRP, etc. We can click save and we have all the necessary templates created. We can stop here, and then the next section I will go and show you that how you can attach, first of all how you can call these templates, and then you can attach to the device. Alright, so let's continue here. First of all, let me show you that what type of templates we have created. We have this long list of templates. Now I want to use this template inside the device configuration. So I'll go click device and then create template from feature template. What's the device model? That is the Velocloud, and this is, say for example, test for branch 1 VH1 template. And then now we have done all the hard work. Simply I have to go here and call all the templates that I have created. Suppose if you want to add any new feature, you can go click here, it will come here, you can add it. Otherwise, if you don't want, leave it. Simply click here to the drop down, use this template, click here to drop down, use this. If you have the template that you have created, you can call it. Suppose if you haven't created this and if you have existing template, you can use it. Otherwise, you can leave this as a factory default as well, if you know that what is the configuration inside the factory default. Okay, I can go and give the test that we have created, then VPN interface that we have created for MPLS interface. In our example, we are taking only one interface. So we'll choose that, and see, in VPN 512 I don't have interface, so I should go here, click add the interface, and then you can go to the test VPN 512 that we have created. We are not taking any service VPN, but yes, in the banner we have created the test banner. Policy, we are not using any policy at the moment, so leave it. SNMP, I can click none. There's no problem on that. Click create. So now we have successfully created the template. You can see in the bottom this name of the template, what's the description. This is the feature template for vEdge Cloud. It is using 11 features that we have put on that. It is not attached with any device at the moment, that's why we have 0 here. So what I want, let's go here in the more section, click attach the device, and we want to attach with branch 1 vEdge 1. Click attach. So once you are here, you can see now that it is asking for these value which we have created as a variable. Now if these values you have in your Excel sheet, in your local drive or somewhere, you can upload it. First option. Second option, you download this file. This will be Excel file. Once you download this file, in that Excel put those values and then upload it. That is the second option. Okay, you have third option, that if you know that values, you can simply click here and put it. Click here and put it. You can use it. Or final option, you can click here and click edit device template, and it will ask you all those things. So remember, we have give this login banner, ask me, this is the cheat sheet. I am telling him, oh, what exact value I want, you tell me. So for example, do not log in without permission. So log in without permission. Now one by one we'll see. We'll give all the values. So what's the host name? Host name is say branch 1 and vEdge1 test. I will give some different name. Then what's the system IP? Say 1030.1, that should be correct. What's the site ID? 300. What's the IP for the MPLS interface? So let's go and check the MPLS IP that we have at the moment. So I'll scroll up and I want MPLS IP, that is this IP for the MPLS interface. I'll go and put the IP for the MPLS. Then what's the management interface IP? Because those things we have created as a variable, so it is asking at all the steps. Because we have created one generic type of template, put it, update it. Once you update, you can go next and you can select this device. The nice thing that Viptela has given, that they have given this config difference option. You can see the config difference side by side. So whatever the configuration are not here, it is not present. Whatever difference in the configuration, it will clearly highlight you. It will mark you. So these are the configuration which is missing. These are the lines which are missing. Side by side, all the configuration we can verify. Again, one nice protection mechanism that Cisco Viptela has given is the config rollback timer. This rollback timer is by default 5 minutes. So what does it mean? Suppose if you are pushing this configuration, and if this configuration, after pushing this configuration, your vManage and your vEdge, your devices with vManage, they are not able to communicate, then it will roll back the configuration. And the rollback timer by default is 5 minutes, that you can increase or decrease. Okay, so leave this as default. You save it. If anything wrong, so what is happening, sometimes you are doing some remote configuration due to some issue, some routing issue, some interface shutdown, no shutdown issue, you completely lose the site access, and then you have to call to the a remote location, some engineer will go there, or you have to send some engineer there and fix the issue. In this case, suppose if anything is wrong in configuration and control data plane will not communicate, then within 5 minutes it will roll back. That's the rollback timer we have. Alright, so click next. And now the job has been scheduled. On the top you can see this is 1, and if each and everything will be correct, so first of all it is validating the configuration. The validation is successful. Now with help of netconf mechanism, my vmanage is pushing the configuration to the vEdge device, and all those messages exchange and everything we can see from here. If anything will be wrong in progress bar, it will give you a red signal, but it has pushed the configuration. Let's go back, log into the device and verify. So I have my branch device here. If I press enter, the host name will change. Say that test. Now if I go and check show interface description, I have only this interface and these interfaces operational. If I go and check control connection, now I have control only over the MPLS. Again, if I go back to the dashboard, configuration and template, then now you will see that this particular device is attached with one template. And if you go here and click attach devices, you will get the detail about, okay, not here. If you go here to the more and click show attach devices, then you will see that, okay, this is the chassis number, this is the host name, and this is attached here. Even if you want to verify furthermore, you can go to configuration and devices, and here also if you scroll it, you'll see that branch 1 vh1 test managed by the vmanage with this particular template. Okay, so this is the way that we can create the feature template and attach to the device, and we can do the basic verification. Now the next thing we have to do is to build the CLI template. So let's go and build the CLI template. For that also we should go to the vmanage, and from vmanage we can go and create the CLI template. So you can go to the configuration and then template. Here you will see that you have option to click the CLI template. You can go and take that. So now which particular model you want to create the CLI template? That is the cloud. This is, for example, CLI template for branch 1, vh1, or maybe I want to make it a generic template for all the devices in the branch 1. So that also it will work. So two form we have here. First of all, simply I can go and give the CLI configuration. So I can go and copy paste. So I have in my notepad the CLI configuration is there. I will copy that and I'll come back. I will paste here. That's the one option. Other option, I can go and call that particular file where I have saved that text file, and automatically it will come and populate here. Now in this particular template, let's see this template. Okay, so this is the template, the same type of configuration that we have for VPN 512 and then VPN 0, etc. Now I want to push this template. So before pushing this template, what I will do, I will give some wrong word. So for example, ABC here in the bottom, and then I will add this. Just wanted to show you that if you create a wrong template, then how the vmanage will react while you push this template to the actual device. So we'll go and push this template. Now what I have to do here, I'll go here and click attach devices. There I have device that system IP is 10.3.0.1, that is the branch 1 vh1. Let's try to push that template. So because we have given some wrong code, if I see this message, you'll find somewhere in the bottom it will throw an error. So validation is in progress, but it got failure. Why? Because some unknown command he found. And what was the unknown command? If I scroll it down, it will tell you, see, ABC, is something that the device is not able to understand. So that's why he has thrown that error. So next what we will do, that we'll go back to the template and we'll edit this template. So you can go here and click edit. Whatever wrong configuration are there, you go and remove those wrong configuration and then give the correct configuration and then update this template, and again we are going to repush this template to the device. So we'll go here, attach the devices, select the device, so it is coming up, select the device, and you can push this template. Again, if you want to see the differences, you can go and check the differences, side by side differences, and you can verify it. So we'll wait for a time when we'll get the successful message. If everything is okay, good and working, we'll find that it will push the template and device will come back online. And this time again, if you go back, you'll find that the counter will increase here to 1. So if I refresh this, at the moment it hasn't pushed the template, but if it pushed the template, we'll see that the counter will become 1. If any failure is there, that means it will not work. I can go to the jobs on the top and I can see that still any job is there. Push CLI template success. So I'm getting successful message there. I should see 1 here. See, the counter become 1 here from 0 to 1. Now that means this particular template is managed via the CLI template. If I go back and see in the vManage dashboard and the devices, you'll see here that I have branch 1 vh1 and this is managed via vManage, but we have this template CLI branch 1 vh1 generic that is connected with this particular device. Now if I go back to the device and if I go and check show control connection, so it is running by the CLI template and we have the control connection from my edge device to the vManage device. Now what I can do here, again I can go back to the template and I want to do some changes. Now what is the best practice while you are doing the changes, and it's a very important point, that whenever you want to do any change in your existing running template, so whatever template that is running, in that template if you want to do any change, so what you do, first of all, you create the copy. So create the copy of the running template, whatever running template you have, and then do the change in the copy template and then attach this copy template to the device. And while you are creating this copy template, give some proper name, give the change ticket name, the date and purpose, why you are changing this, due to some security feature, due to some routing, due to some other requirement. So you should justify your changes. So what you can do here, you can go and click copy, and here the template name generic for testing, say for example, and then the change management number and the date. You should give like this, so in future you will understand, oh, in that day I have done this change and I have the description about that change, what's the justification about that change. So now you can go to the edit section, and now here you'll see the same template we have. This particular template I want to create variables. So how you can create the variable in the CLI template? That's actually very easy and straightforward. You go select the name, click create variable, and then give the name of the variable. So this is host name. Click create variable, and now you can see your variable has been created. Say select this site ID, and then you want to create variable for site ID. You go here and say site ID variable. So now you have your site ID variable. Likewise, whatever things that you uh, are thinking that, okay, these are the things I need to create as a variable. So in future I need to change the value parameters dynamically. So I can go there, select that, and I can create the variable. So this is a MPLS interface IP. So once you create all these variables, then what will happen? You click update because this is not attached with anything, and then I want to attach this variable CLI template with the device. So the same process you can follow. You can go here to branch 1 VH1, push this and attach this, and then you can see it will ask you again you can use the same process. You can download this Excel file. So from this download button you download this, then put those values whatever is missing in that, say for example host name, site ID, MPLS interface IP, and then upload that. Automatically all these fields will be filled. The other option you have that you can go and click edit here. So let's go and click edit here. Once I click edit here, then it will prompt, okay, what's the host name? So for example, branch 1 vh1 variable, and then what's the site ID? Site ID is 300. What's the MPLS IP? So we'll give the MPLS IP whatever we have. Let me go and check that what is the interface MPLS IP we have. Interface gigi 0/0. So the IP is 172.163.2. I'll go there and put this value here in the field and then update it. Click next. If you want to see the difference, you can go and see the difference. Now it has been scheduled. If I go back here and if everything is correct, we know that if everything is correct and working, then the name, you can see the name has been changed. So this is the way that we can create the CLI template with variables. Next section we will discuss more about what is the use case, why we need to create the variables. So far we have studied that how we can create the feature template, CLI template, feature template with variable, CLI template with variable. Now let's discuss little bit that why we need to create the variables, why we need to create the generic template. So what you can do, first of all, you can classify your branch site. Maybe you are using some TLOC extension, maybe you have dual connected, maybe you have VRRP, maybe you have OSPF running, single site has single ISP connection. So you can categorize what type of branch you have. For those type of branches, whatever location are, you can create same type of variable for all those same type of location. Then you may have site who is dually connect, dual broadband or dual internet connected. So for that also you can create a template. Maybe you may have site who has dual MPLS connected. So for that also you can create the template, or you can create variables for the IP and the interface name, and you can use the same template for dual internet or for dual MPLS. Then you can have site, a small site where you have internet and backup as a 4G, LTE or 5G. So for that site also you can go and create the template. So first thing that we should classify the sites into category. Then we can define the configuration feature. So what features you are using? Here I am using OSPF, here I am not using OSPF, here I am using primary and secondary link. So you need to define that what features are associated to that particular site. Then according to the features, according to the site, according to the variable, so you have to define host name as a variable, system IP as a variable, site ID as a variable, MPLS IP as a variable, internet IP as a variable, gateway as a variable. So if you count out and if you work out on the templates and the variables, you will find that mostly 15 to 20 variables you need, or you are changing 15 to 20 values in different generic template, in different template and variables. So if you plan out and figure out properly, then you can put all these 15 to 20 values in the Excel sheet, and while you are uploading the template with the Excel, you simply put these 15 20 values, and then you don't need to create different template. Same 10 to 15 template can manage, say for example, 1000 to 2000 devices. So you can see your configuration consistency is there. You are doing the standardization and you are reducing the amount of configuration that you need to put inside your database or inside your vManage device. So planning, preparation, designing is the key in all the SDN solution nowadays.
Hi everyone, welcome to SilverPeak SD-WAN course. In this course, I will explain what is the SDN, SD-WAN, what are the components, terminologies, technologies used inside the SilverPeak, and what are the technologies improvement related to optimization, WAN optimization, traffic optimization, and finally, overall, what type of mechanism we have inside the SD-WAN. So I hope you will like this course related to SilverPeak SD-WAN and you'll learn new things about this technology. The first thing that is coming in our mind is that what is SDN and how I can utilize SDN inside the WAN. So SDN is nothing that you have to decouple, or if you decouple the control and the data plane. Now, if you see any normal, say traditional Cisco router, you'll find that, okay, in the router you have control plane, you have data plane, you have management plane. Management plane means you can SSH, Telnet, SNMP, etc. Data plane from where the routers, they are sending the packet. Means routers, they are never the destination, but they are in between the traffic. They are providing the route that you have to go this direction, you have to go this direction, you have to go somewhere. And those instructions they are getting from the control plane. So these plane, if you decouple, so what does it mean? So suppose if I have one IT infrastructure, I have, say for example, data center, say DC1, I have DC2, I have n number of branches, correct? So for example, branch 1 up to branch n. Now in all these places I have devices. Say for example, I have edge routers in all these places. Now what I can do, that these edge devices, that whatever we have over all the sites, I have, say, control plane and data plane over all these devices, correct? Control plane and data plane. So what I can do, I can move these control plane to one central location. So now I have centralized control plane from where I can take decision for the data traffic. So I can create various policies, various optimization, traffic flow, data policy, control policy, etc. I can take decision from the control plane. Now doing so, what's the benefit I have if I do this? Now the main advantage or main benefit we have in this decentralized environment, like you can think like that you have hardware, and these hardwares, they are there. Say this is my IT infra or IT hardware, means these hardwares are used to provide services. Now these hardwares are there, and if these hardwares, I can somehow create multiple views over all these underlay hardware. So I may have virtual network 1, virtual network 2, virtual network 3. In SilverPeak, we'll come to know that we have something called business intent type of network. I will discuss more about that. But if with the same fixed hardware, I can create multiple instances, and who will help me to doing so? The control plane. With help of control plane, I can create multiple logic virtual network that will lead us the new thing that we are doing nowadays, that is network virtualization. So when we are thinking or when we are talking about network virtualization, say whenever we are using SDN network, we are very much close towards the network virtualization. So most of the technology nowadays, say for example, ACI application centric infrastructure in Cisco, they are using network virtualization. Say digital network architecture in Cisco, they are using network virtualization. We have SD-WAN in Cisco also, they are doing the network virtualization. Why? Because whatever underlay you have, you can create multiple view, multiple looks of those underlay or those physical hardware, and then you can create
virtual network. Even if you see VMware NSX, they are also doing this. In terms of say SD-WAN that we are studying, so we have multiple vendors. We have say for example Cisco Viptela, we have SilverPeak SD-WAN, we have Velocloud, and number is there, so many. Now all these SD-WAN solution, they can also create the virtual network if we do the decouple of the control plane and the data plane. So not only we are creating the virtual environment or virtual network, but now you have the independent control plane. You can write the codes for the control plane. You can make those control plane programming much more mature. You can enhance the code all the time. You can take help from the automated system or a script. You can improve those because the data plane, there is no effect even if your control plane is down. So you can improve the code. An open solution for VM mobility, say in case of data center, because you are not dependent upon the fixed location or the IP, you are not dependent upon the IP or the VLAN, etc. So you can create the dynamic VXLAN tunnel in the data center environment. You can do that. You can reduce the capital expenditure. Why? Because now the management is easy. You can use the unutilized bandwidth. You can your operational things will be easy. So you will find that not only you have the scale, not only that you can check multiple application, the downtime recovery is very fast. Not only you are getting the fast throughput, but overall the management of the entire IT life cycle or the IT infrastructure will be reduced. A solution to build virtual topology, yes, that we have discussed, virtual network. A mean to scale my fixed mobile network optimize. That's also true because say whatever SDN solution we have either with respect to LAN or WAN or campus area network or data center, whatever, what they are giving you that you have data plane. Maybe if you are in data center, you have data plane VXLAN dynamic tunnel. If you are in the SD-WAN, you have say IPsec dynamic tunnel, means you have auto VPN or those VPN will create automatically. Even either here in data center or here in the SD-WAN solution, you are not writing a single code, a single line to form your IPsec tunnel or to form your VXLAN tunnel in case of data center. So that's why you can see all these points are valid if you are using the SDN solution. A way to configure my entire network as a whole rather than individual device. Yeah, why? Because now you have centralized management. You have centralized control plane, you have centralized management plane. So you have control plane somewhere, from there you are giving the instruction and you are improving the performance of the data plane devices. One point I want to add here when we are discussing about the traditional network and the SDN solution is now the traditional network and the SD-WAN network or the solution will find, or even SDN solution, what you will find that in traditional network you don't have databases. You don't have any device, any type of device or any type of controller where you are storing the databases, where you are storing the serial number, chassis ID, certificates, etc. But in the SD-WAN solution, in the SDN solution, what's the new thing you have? That they are coming with some database. And it's true, you have the database for all the solution that you can check. Whatever XYZ solutions we have related to SDN, you'll see that they are coming with the database. Now again, I want to add one very important point here is that SD-WAN is not an RFC. This point is huge. So that's why all the vendors, they are coming with their optimized WAN solution or optimized SDN plus WAN solution. So every vendor implements its proprietary. SD-WAN devices from different vendor will not work together to automate your WAN. The different vendor, if you try, okay, I have S device from SilverPeak, S device from VMware, S device from Cisco, and then I have common control plane. With common control plane, you will not you're not able to track, monitor, manage, configure, etc. to all the different vendor devices, because this is something like vendor locked proprietary system. All right, so at this point I hope that you understand the SDN and why I want to add SDN inside WAN to make this SD-WAN solution. Let us see what type of components and the terminologies used inside the SilverPeak. You can see in the diagram that you have three different type of component. One is the edge connect, that is my data plane device. That may be physical box, that may be virtual. I have cloud portal that will be work as a database to register all the customer serial number and all those things. Now you can see that I have connection between my orchestrator and the cloud portal. Now, what is the use of orchestrator? Obviously, to orchestrate the infrastructure, to manage the infrastructure, correct? So here in the diagram, you can see that you have the data plane and you have the control plane. You have, obviously, you have centralized control plane from where you can manage each and all the devices. So let's see in the slide some of the more terms related to data and the control plane. So the data plane, there may be physical appliance, hardware purchased from SilverPeak that come with software loaded, comes with burnt in serial address used to identify the cloud portal, which can use to automatically register the device. So when you are doing the registration of the devices, those hardware boxes, they have burnt in serial number, and my cloud portal, they know about that serial number. So that's why they will build some secure tunnel while bringing up the data plane device. But in case of virtual appliances, uh, that you are going to install over the ESXi or over the hypervisor does not come with the serial number and the required license information to be entered manually when first booted, so that it can register with the cloud portal. So that means your cloud portal is nothing but the database who has the information about the serial number, about the licenses. The second piece we have is the orchestrator, and this is actually very important. So we have the control plane, orchestrator, and this SilverPeak global management software used to manage, provision, and monitor the SilverPeak devices in a given network must register with Cloud Portal. So what is happening here? My Edge Connect devices, so my Edge Connect and my orchestrator both are registering with the Cloud Portal. Although this is my data plane device, this is my control plane device, but both are both having the database inside the cloud portal. Now this orchestrator can also manage the other type of SilverPeak devices like NX, VX, VRX. These are the WAN optimization. Remember, SilverPeak SD-WAN is one of the best SD-WAN we have in the market for WAN optimization, and they have their own devices related to WAN optimization. Let us quickly discuss about the cloud portal. SilverPeak portal is on internet. This is like you have means like ISP or the OEM. They are providing cloud portals for different customers. Say for example, if you heard about Meraki, inside Meraki also different clients, they have different portals, and from their cloud portal or from their centralized GUI, they can manage all their MX, MS, whatever devices we have inside the Meraki. So here also I have the cloud portal, but what's the use of cloud portal we have? That use of cloud portal is to manage the licenses of all the SilverPeak devices in the customer network, talks to orchestrator and edge devices. Correct? So my cloud portal, they will talk to the orchestrator, they will communicate with the edge connect or branch devices, maintains the database, that's the key. So where is the database in this SD-WAN solution? So cloud portal is the database. They are maintaining the database for all the customer account, knows which physical device serial number goes to which account. So now that means they have account an account with serial number. So which particular account or which particular client having which particular serial number. Generate serial number for virtual devices that connects to and associate with the correct account based license. So suppose in case of virtual device, the cloud portal, they are generating serial number, and again they are accountable that that serial number is connected with which particular client or the account. Facilitate automatic connection orchestrator and appliance in the customer network based on license serial number information. So what are the things they are accounted with? If I give the points, point number one, that they are connected with the edge connect device and the orchestrator, so they have connection with them. Point number two, they are tracking the account and that account with the serial number and the license information they have. So that is the use of the portal. In summary, if you want to memorize this, just have a look on this diagram and then you can visualize that how behind the scene the SD-WAN SilverPeak is maintaining those database and all the connections. Let us discuss various definitions inside the SD-WAN. So what does it mean by encapsulation, tunnel, FIC, forward error correction, boost or WAN optimization flow, optimized flow, stale flow, pass-through traffic, underlay, overlay, business intent overlay, and the software-defined WAN, SD-WAN. Now, when we are talking about the encapsulation, say all these things obviously they are related to the data traffic. So suppose I have one edge connect here, one edge connect here, in between I should have a tunnel. Now the actual payload, so whatever traffic that is coming, when it will reach to the WAN interface, obviously I want to do some sort of encapsulation, and when it reach to the destination I should have to do the decap. So incap and decap will happen. Now it depends that if you want to do the optimization for these flows. So what does it mean? The data traffic from, say for example, one source to the destination, they can have optimized or they can send without optimize. So I can use some sort of WAN optimization inside the tunnel to boost the traffic flow or the flow of traffic, or I can send as it is. So with boost, without boost, incap, decap, all these things one by one we are going to discuss here. So the first thing is the encapsulation. When we are talking about encapsulation, at what time, at what point you are going to do the encapsulation. Here you can see the end device packet becomes the payload of the encapsulation packet. The end device means my edge connect, is usually unaltered except possibly be encrypted. Means if you are doing encapsulation at one side, decapsulation at other side, at that time you will do incap, decap, and then the payload will be encrypted with certain IP addresses. Again, it's important to understand that what type of IP addresses will be used for the encapsulation and the decapsulation. So here you can see the encapsulation packet uses the source and the destination address of the appliance with the logical connection between them. The payload packet still carries the source and destination of end device. So that means you have your edge connect and you are forming the overlay tunnel. So you have the tunnel. So here over the tunnel, the source and destination fields, they are related to the tunnel. But when packet will come from here, the source and destination will be the actual source and destination packet. Correct? So actual source and tunnel destination, whatever you have. So suppose I have payload, then I have actual source, then I have actual destination, then I have encapsulation. So for example, ESP or any type of encap. Then I have, say, tunnel source, and then I have tunnel destination. So that's the overall overhead and the encapsulation. What is tunnel? A tunnel is that where That will be the exit or entry point to the connect devices, correct? So a logical connection between two devices, in our case the SilverPeak appliances, traffic transported through the tunnel is encapsulated. The tunnel packet carries the source and destination of the SilverPeak devices. The payload packet that carries the original source and destination of the end devices. Just now we have discussed about this. Note, a tunnel can carry other tunnel inside it, adding a layer of encapsulation. So I can have tunnel over tunnel. So tunnel encapsulation is also possible in our SilverPeak. Then we have other terms like what is FEC, forward error connection. Not only SilverPeak but even Cisco also uses FEC. This method is something like it compensates for loss in a data stream by allowing the devices that terminates the far end to tunnel to compute the content of loss and reconstruct them, avoid retransmission. So this is some sort of mechanism that will uh, fill those type of loss in data. So data is there, some missing data is there. It will fill those fields without doing retransmission. Because suppose again if you do retransmission, then again you have to build the source and destination stream, and then you have to send the packet. So if you see something forward error correction, that will check the error and then fill the data, and it will try to overcome the loss in between the transaction or in between the transmission. So the main thing about the FEC is that they are avoiding the retransmission. Alright, then we have the boost and the WAN optimizer. For that in SilverPeak, uh, we have different devices to do all these things, but one point I want to highlight here, that suppose if you have two data plane devices, two SilverPeak appliances, and in between you have tunnel. So either you can send the boosted traffic, so either I can send the traffic with boost, or so I'll highlight with boosted, without boost. Both possibilities there. A set of technology that allows tunnelized traffic to be accelerated, compressed, and deduplicated for improved performance and bandwidth saving. Extra cost option with WAN edge. Yeah, you need to add extra devices for that to do so. Next terminology we have is the flow. What is the flow? Obviously, flow of data that is inside the tunnel. So a stream of packet transmitted between two endpoints usually identify at least protocol, source address, destination address, and maybe source and destination port numbers may or may not be tunnelized. So it may be inside the tunnel, it may be not inside the tunnel. Optimized flow, that means you are using some sort of boosting and then you are sending the flow of data. So that will be optimized flow. Likewise, in the flow, we have a stale flow as well. So suppose if you have two devices and they are tunnelized and you are sending the data. Later on, the business, they decided to, okay, boost this traffic. So then you are using some extra mechanism to boost this flow. So if you boost the actual data or actual transmission that was happening earlier, once you start boosting, this actual stream will behave as a stale flow. Okay, and that's the example of a stale flow. So you may have some flow that is used earlier, now you have boosted, you need to refresh this stale flow, and then you have to send those data via the boosted mechanism. Then we have the pass-through traffic. What does it mean by pass-through traffic? The traffic received by SilverPeak but not tunnelized, optimized, etc. So if a traffic is there that my SilverPeak appliance will get without tunnelized, without optimized, those are the pass-through traffic. Pass-through, we can apply this shaped methodology. Pass-through, we can apply the unshaped mechanism with help of quality of service. So in quality of service, we have like buffering capability that is termed as a shaped. If do not do the buffering, that will be unshaped. correct? Then we have the underlay, overlay. Underlay, I all the time I used to tell, okay, whatever hardware or infrastructure you have, so whatever edge connect devices you have, whatever connections you have, those are underlay. And when you are creating virtual network, when you are creating logical network on top of these underlay network, those are overlay. They are termed as a virtual network because now in this SDN solution, we are doing something called network virtualization. So we are not doing hardware virtualization like VMware virtualization, etc. We are creating multiple views of a network, and that is the virtual network, and that's the overlay. So the underlay, the physical, you can say physical transport network, and it's the site-to-site connection that could be MPLS network, internet, LTE, or private. It also includes the tunnel built between the SilverPeak appliances across the physical network. The overlay, the complete set of logical connection. So this is physical, this is logical. Making use of tunnels and physical connection in the underlay network between SilverPeak appliances, these are associated with particular business intent overlay, and that's the key. So you have logical connection and you have business intent overlay. So all the time we are going to discuss about BIO, business intent overlay. Each set of overlay connection between these sites, in particular BIO, might make use of multiple underlay connection, and overlay might use some or more of the physical network, tunnel, etc. So think like that. You have your physical infrastructure like underlay. On top of that, when you are creating different logical or virtual network, those are your overlay. You can term that as a business intent overlay. Now, business intent overlay, a configuration template in the orchestrator that defines the criteria which will be used by orchestrator to automatically create the overlay connection between the appliances. Multiple business overlay can define to create different set of overlay connection for different source of traffic, different types. These can connect to different sets of sites using different types of physical connection with business requirements. So what it is telling generally, what you can understand with the business overlay. Now, since you have the physical infrastructure, you may have different applications. So what you can do with respect to application, you can create different policies related to application loss, latency, jitter, etc. So what you can do that different application, you can provide different business intent overlay. That is again, by the end of the day, this is again overlay, and this is something like this overlay, this overlay, this overlay. So you can segregate. You can see here that multiple business intent overlay can define to create different set of overlay connection for different source of traffic. Different source of traffic, or maybe different type of traffic, that you can assign with different business intent overlays. Correct? Then finally, we have SD-WAN that we are studying. So SD-WAN is that combination of whatever we have studied. So if you summarize all those things, what you want, what is your end goal with SD-WAN? That you want control plane to handle your business data from one location to other location securely. So that's why you have tunnel. Now, since you have tunnels, since you have multiple, say, connectivity to reach from, for example, source to destination, maybe your branch to data center and vice versa, what you want that these tunnels, obviously they will do some sort of in cap. So either you have, say, optimized flow, or you have non-optimized flow. Irrespective of optimized flow or non-optimized flow, you have something called business intent overlay. So what I can do with business intent overlay, that with respect to application or set of traffic or traffic. So with respect to traffic flow, And with respect to loss, latency, jitter, and other SL parameters, I can provide path A versus path B. So that's the overall goal of the SD-WAN. The set of network overlay, this is virtual network virtualization, running on the underlay network. I told you this is physical network, this is the virtual network, that are dynamically created and maintained. This is the key, dynamic or auto. So automatically so many things will be created for you in the SD-WAN solution. So you are now free from the lengthy configuration that you used to do. Based on a defined set of criteria such as loss, latency, jitter, traffic can automatically routed. So you have auto tunnel, and if they are breaching the loss, latency, and the jitter criteria, means whatever SLAs you have, they will auto reroute to the best path. And that's the overall goal of SD-WAN solution we have in the SD-WAN. Alright, so I think you understand up to this point. Let's just stop here. Let us discuss more about business intent overlay. Here in the diagram, you can see that, okay, I can create multiple business intent overlay dependent upon traffic class. So in the next diagram, I'll show you that how we can create multiple virtual network that is equivalent to business intent overlay. But one thing is important here to note, that the deployment profile, the template that control the site configuration and how the individual site will be conducted to the network. The thing importantly here related to deployment profile is that an appliance can have only one deployment profile. So that means that you have only one profile. Inside that profile, you may have multiple business intent overlay. You may have multiple overlay. And why you need multiple overlay inside a deployment profile? So you can see in the diagram what you can do now, that you have your underlay. So I have my physical infrastructure, I have my edge devices, I have my virtual or physical devices, I have my ISPs like internet, MPLS, 4G, means I have the transport. They are known as an underlay, but this particular underlay, I can have multiple virtual network as overlay, or more precisely in SilverPeak, those are business intent overlay. So for example, voice, I need a good service. So for voice related services, I can have full mesh. I can use MPLS fallback to LTE. I can have max quality, means I have better SLA parameters for VoIP traffic. For data traffic, I can use MPLS and backup traffic or backup link via the internet. This is again the max availability. For guest Wi-Fi, I don't want 100% reliability. I want to use only internet circuit. So all the traffic, they can go to the gateway site, that is my data center, or that may be my hub location, and then the traffic can go outside. Correct? So I have multiple business. So this is business intent overlay 1. I have business intent overlay 2, 3, but all these intent overlay, they will be part of single deployment profile. That's the overall idea we have. Correct? Now, if you want to learn more about this, and if you want to see some of the terminologies related to business intent overlay, you can go to this particular site. Let me log into this particular site and show you. All right, so I am inside this particular link that I have given inside the PPT, and you can go and check what's the definition you have. The same sort of image I have taken from this particular site. And then if you want to learn more about BIO, underlay, overlay, building overlay, these terminologies and terms, then you can go click and check. You will get the answer. You'll get some sort of definition that you can refer. Okay, on the top you can see you have the welcome, getting started, You have the configuration, you have the BIO, you have template group, you have dynamic rate, traffic redirection, quality of service. Then you have configuration, you have deployment profile, configuration deployment profile. You can see different type of deployment profile, deploy the orchestrator, add appliances. Then finally you have the troubleshoot, that you have multiple options inside the troubleshoot. So let's stop here and we'll continue as our topic. Means we have one agenda and we are following that. Next we have SilverPeak products. As we know that in SilverPeak we have Unity Edge Connect or Edge Connect. Either it is a virtual or physical. Now what are the things we have and what features we have that they are providing? Zero touch provisioning, ZTP. They have dynamic path control, that is DPC. They have WAN hardening with 256-bit encryption. They can do the path conditioning, and they are cloud intelligent for various type of SaaS application. Now, whatever list that we are seeing here with respect to Edge Connect, so for example, cloud integration. So easily they can integrate with the cloud. I can do a ZTP. They can do dynamic path control. They are supporting say WAN encryption, path conditioning, etc. Most of the SD-WAN solution they are providing these features, and I can say that almost all the SD-WAN solution they are providing these features. Okay. Then nice thing about SilverPeak is that we have the orchestrator. So suppose a device you want to join the fabric, the SilverPeak fabric, so they will be registered from the orchestrator, and then orchestrator will push the configuration, policy, intent overlays, business intent overlays, all those things to the devices. So this is a single screen administration, automated business intent overlay policies, because it will push those policies to the Edge Connect. It has visibility into legacy and cloud application, bandwidth cost saving reports. We can create some reports as well from the orchestrator. Now again, in the upcoming slide, we'll see that we have boost licenses. So we have licenses for different purposes. Why we need license? Again, we'll discuss. So when we have the license, they can uh, perform optional tasks, like if you have SaaS, software as a service integration, for example, Office 365, or say any type of SaaS application you have, say Salesforce or maybe AWS or maybe Box, whatever. So at that time, with respect to license, they will provide you feasibility and flexibility to check what is the quality of experience, what is the overall SaaS-based application score, and according to that, they can shift the path A versus path B, correct? Now, the list of the devices that we have, the hardware devices, you can see is starting with small, then we have for little bit bigger branches than a small, then we have medium, then we have large, then we have extra large. So these type of hardware devices we have. With respect to throughput, you can see throughput from 2 Mbps up to 10 Gbps. It can support how many connections we have, or simultaneous connections we have. This is 2 into 10 to power 6. Up to this much connection we have. Again, it depends that what is the size of the branch. If it is a very big branch, we can use XL. For the mid size of branches, we can use M or L, and the small branches we can use S or S. So we have Edge Connect in these variants that we can use. Now, what about cloud-based Edge Connect? What is the throughput and the related terms? Most about these information you can go to the SilverPeak site and you can check the data sheet and the document. For the virtual appliances, this is identical UI and provisioning. Physical appliances requires hands-on configuration for licensing. So the difference here is obviously this is the software-based appliance, but this is not fully ZTP. It's not 100% ZTP. Overall throughput limited to 1 Gbps. If you want to increase more than 200 Mbps, you need the license. And what type of license we have? So let me quickly show you the licenses and then I'll come back. So here you can see that once you have the appliance, then we can see that, okay, I have Unity, either physical edge connect Unity, either physical or virtual. Base license, annual basis, company will charge you. In base license, you have ZTP, dynamic path control, and application overlays. So if you don't have much, say, use cases, means if your throughput is less than 200 Mbps, you are not using the SaaS application, you are not using the boost or the WAN optimizations like here, then you can go with the base license. If your throughput is more than 200 Mbps, you need plus license annually. If your throughput is, if you want to boost the traffic between two endpoint or two appliances, then you can use the boost license. And then suppose if you have the SaaS application hosted, you want to do the full visibility and you want to check your cloud hosted application, then you have the SaaS license. So here you can see the list of licenses we have. Correct. Let me go back, and here you can see that we have the Unity orchestrator. Although we have discussed about this orchestrator, from the orchestrator you can push the policies to any of the edge device. Now remember, these data plane devices, they need to join the fabric. So once they want to join the fabric, what are the things are going to be happen? Let me show you in the next slides. So let us discuss about that. And then I'll come back and show you that slide in a summary. So suppose this is the Edge Connect. He wants to join the fabric, SilverPeak fabric. Then he has to communicate with the orchestrator. Orchestrator has to validate the license and the serial number. Once orchestrator will validate, means he has to do the registration. He had to approve the registration actually. New appliance boots is discovered by the orchestrator. The orchestrator is discovering the device and he will do the approval. Once he will do the approval, then he will push the configuration and everything is like zero touch provisioning. So now what he will do, now the orchestrator will do, he will push the deployment profile, template group, business intent overlay. Remember, we have discussed about this business intent overlay. You can refer the previous videos. We have discussed about the deployment profile as well. Deployment profile will be one. Inside that you have the business intent profile. You may have multiple business intent profiles or overlays. And then you have the template groups as well. So finally, what is happening with respect to orchestrator? Orchestrator, they are discovering the appliances. They are doing the registry process. Registry will be approved, and then they are pushing the configuration, these profiles and the overlays and group. So finally, configuration push to the appliance and the network connection built automatically. And then they will build the network connectivity. So whatever connections they have, you can see I have full mesh tunnel created automatically. So this is the process. Most of the SD-WAN solution, they are following same type of process. Now here you can see that you have a Unity device in the branches. So all the branches, data center branches, you have Unity device. With respect to this Unity device, not only you can communicate from branch to branch, branch to data center, but from branch you can go to the cloud, from branch you can go to the other data center and cloud, or from data center you can go to the cloud. So all these type of flow of traffics are possible. Overlays existing infrastructure, quickly leverage broadband cable, DSL, LTE, 4G. They provide zero touch provisioning, dramatically boost application performance. So now if you are applying the boosting or the enhancement of the traffic flow inside the encapsulation or inside the tunnel, to be more precise, then you can boost the performance. And again, we have seen that we have licenses for that. Slash network cost, yeah, overall cost of the network will decrease because we are increasing the overall performance, we are increasing the overall uh, improving the overall downtime, and we are using the unutilized ISP bandwidth. In this case, everything is like active. All right. So now you can see that what different type of products we have in the SilverPeak. So we have NX VRX, VX VRX versus Edge Connect EC, Edge Connect, and Virtual Edge Connect devices. What we are discussing is the Edge Connect devices, Unity Edge Connect devices. They are focused on SD-WAN automation. Orchestration is required. We need orchestrator. From there, we can do various things. Boost WAN optimization is added cost. So if you are adding, you have to add these costs as well. Different pricing licensing model with the VX and NX. Now, when we are coming here to the other SilverPeak product, those is the NX, VX, and VRX. Focus on boost WAN optimization, include prices. This is basically focused on the WAN optimization, this particular product. Capable of operating without orchestrator, that's the key. This is SD-WAN capable. Very different licensing from the Edge Connect. So they have different license suite. They have different license suite. In this particular course, at the moment, we are going to discuss this path, this section. So in the upcoming section also, we are going to discuss more and more about the three component like Edge Connect, Orchestrator, and the cloud portals. All right. So far we discussed about the terminology. Let us discuss about the technologies inside SilverPeak. One of the important thing we have is the path conditioning. SilverPeak devices, they are doing the path conditioning. So why you want to do the path conditioning? You can see what is the loss latency and jitter you have over MPLS, you have over public internet. So you want that your critical application, suppose if they experience some sort of loss latency jitter, either they can change the path from A to B, or there should be some method that will improve the overall application performance. Correct? So that's why we are doing the path conditioning. What are the symptoms we have for path conditioning? Like suppose you have video quality, it's very poor, and like you have pixelation, and you have some sort of glitches inside the video, like the halts and glitch. That is the symptom. Transmission, suppose if you have critical application and due to congestion or due to any issue in the network, you are doing the retransmission. And suppose if you are doing the retransmission of the signals or the retransmission of the packets, then for the critical application that is not good. VoIP, in terms of VoIP, if you are experiencing jitters, then calls may get dropped, echoes, clicks, etc. So overall, if you have issue in a network, then you may have call drops, you may have pixelation with respect to your critical application. You need some sort of path conditioning mechanism, and that good news about this, that SilverPeak is providing path conditioning. Okay, so why we need path conditioning? Because, for example, we'll see this point, like commonly seen in the shared infrastructure such as MPLS or internet. Why we need this type of mechanism of path conditioning? We have discussed earlier that inside SilverPeak we have something called forward error correction. So what is this forward error correction? Now my SilverPeak Edge Connect devices are very intelligent. Those devices, suppose if you are sending the packet, say 123, it will reach to the destination, and in between, suppose if packet number 2 will get lost. What is happening, that we have one extra stream of duplicate packet. something you can think like RAID or mirroring. So we have some sort of mirroring for the packets. So whatever packets I have, I am having the copy of that packet. So suppose if number 2 is lost, now I am not telling the source to do the retransmission, rather than I am filling those gaps. So I will fill this number 2 because I have the duplicate packet or I have the mirrored packet, and then it will go to the destination. This is the FIC. Now, if you do the FIC, obviously you have some plus, you have some minus. So we'll see what are the cones we have with the FIC. Ratio of the FIC packets can vary dynamically. Priority data added to the data stream. If your packet loss is due to congestion in a network, FIC might make things worse. So suppose if you have congestion in the network and you are using FIC, FEC method, FIC method, then that thing will become worse, because not only your primary packet will get lost, your duplicate packets will also get lost, and due to less bandwidth, obviously you're not passing your both the primary and the duplicate or the mirrored packet inside the uh, WAN link. Now we have other option also with the path conditioning. Here you can see that we have high availability link bonding policy. This is actually very cool in SilverPeak. So what does it mean by link bonding? Now here you can see, it's very interesting. Now here you can see that for all the packets, so I have very critical application for all the critical application packets. Not only I am sending the packets, but I am sending the backup of the packets as well. So the primary path I am choosing via internet. If there is any loss, the duplicate packets or the mirrored packet I am sending via the MPLS. Suppose I have losses in the internet, I have losses in the MPLS. Both places also I have losses. Still, my destination, they are able to rebuild from the parity. So that's the power that I have with the Edge Connect, that they are intelligent enough to rebuild the information, rebuild the file, rebuild the stream of the packets from the misses. So from the misses, either those misses are in the MPLS, either those misses are in the internet. And that's the power, means the user, they will never experience that there is any loss, glitches, audio, video quality loss, etc. The packet are lost in the transit. My SilverPeak devices, because I have the priority or the copies, they will collect the data, they will rebuild those packets from the priority, and then they will deliver to the destination. Now you can see the power of SilverPeak. This type of mechanism you will not find in other SD-WAN solution. This is FIC is actually very important, a powerful tool we have in the SilverPeak. And when we are talking about the applications and application understanding, application flow, application conditioning, application optimization, SilverPeak is one of the powerful SD-WAN. I think one of the best in the market at the moment. Path conditioning when the packet is out of order. So how it can do? Out of order means they suppose you are sending a packet 1, 2, 3 from here. So packet 1 can go via this, packet 2 can go via this link, and packet 3 can go via this link. Now when it reaches here to the destination, it is so I have sent 1, 2, 3, but it reaches like 3, 1, 2. Now my edge devices, they are intelligent enough that they can build the packet like 1, 2, 3. Okay, suppose if I have sent 3 to 1, they are intelligent enough, they reassemble the packet and send like 3 to 1. And that's the cool thing we have in the SilverPeak, that SilverPeak reorder prior to delivery. So first of all, it will reorder, reassemble, and then it will deliver. So now you can see that we have nice optimization options, that we have FIC, we have 1-to-1 FIC, we can, means our edge devices can do the reorder of the packets before delivering. Finally, we have the QoS support as well. In this QoS, we can provide some sort of priority for real-time traffic, for high priority data, for everything else that will go to this particular pipe. Okay, so not only that we have this priority, but we can do some sort of marking as well. So remember how the packet flow? Packet will flow from one device. So suppose I have one edge connect here, and here is the source, and then I have other edge connect, and here is the destination, and in between I have tunnel. So obviously this will be the WAN facing interface, and this is, for example, LAN facing interface. So when the packet will come from any of the LAN side, that will be one interface. Suppose this is a LAN interface, it will go to the other WAN side, that will be the other interface, that will the WAN interface. So that means in these places, I have option that I can do the marking. And that's true. You can see here that we have the two type of marking. So I can set the marking here as LAN. I can set the marking at the WAN. It depends. What is the default behavior? Default behavior is that do not set the marking at the LAN side, but for the incoming traffic, you set the marking at the WAN side so they can match the LAN side marking. That's the default behavior. But apart from FEC, apart from one-to-one FEC, apart from out of order packet reassembling or assembling out of order packets, we have very nice QoS support in the SilverPeak SD-WAN fabric. Now we have very important topic and feature inside SilverPeak, that is dynamic path control in the hybrid network. Traditionally, what was there? Everything backhaul towards MPLS, because traditionally, in the traditional network, we don't want to send our traffic over public network or public domain. But nowadays, things have been changed. We can create overlay tunnels over the internet or the MPLS, and then our corporate network, we can send that corporate traffic over internet as well. But there is problem that internet is not like well efficient with different application, because there is high loss and latency. And we have seen that parameters that over internet, over broadband, over LTE, what type of loss and latency we have. So it's still my primary traffic I'm sending via MPLS, but the secondary traffic I'm sending via the backup traffic I'm sending via the internet. So this type of model also we have in the traditional network, but what change we have in the SD-WAN environment, that dynamically the application. So here you can see in the bottom, say I have real-time traffic that is preferred towards MPLS, but suppose if this link will go down, any outage with this link, the traffic will automatically divert it towards the internet. Now again, we can debate that, okay, traffic can divert to internet, but still at that time they will experience higher loss, latency, jitter, etc. That is true, but instead of complete outage, it can fall back to the internet. The other important thing here is that rest of the least important traffic I can send via, say, internet link, and I can save dollars, means because the MPLS circuits are highly expensive. So those things I can send via the internet. Even the backup, whatever backup is there, I can send all the backup traffic via the internet. So that's one thing. The other thing is, let me write here. So point number one is that in case of any failure, the traffic will go via internet, or actively I can use that link for the backup traffic or for the less important traffic, correct? And that's the overall goal for the SD-WAN solution we have. Now here again you can see that if you have any failure, then what will happen, that automatically the traffic will divert it towards the internet, and then it will reach to the destination. That is something available in the SD-WAN solution. Now in case of parallel links, what type of load balancing we have? Coming 8.1.x, and we can mark like 8.1 and higher. Not only we can do the flow based load balancing, we'll see in the next slide that we can do the we can do packet based load balancing as well. So before coming to that slide, let's discuss that what type of load balancing we have. We can do the flow based load balancing. WAN utilize circuits that are currently unused. So if you have unused link, I can use both the link as an active link rather than active passive. Any failure will come here, then the traffic will divert. No, these are the active link. Intelligently direct traffic used based on percent tunnel utilization. So here you can see the path is load balance. So if you choose the load balance, it will do the load balancing across different or multiple path. But the new feature that SilverPeak has introduced, not only we can do the flow based load balancing, but we have option that we can do packet based load balancing. And that is something that SilverPeak has a higher hand, or SilverPeak has a win situation with other SD-WAN solution, that here we have the packet based load balancing. That means that one edge connect, whatever source is there, when he is sending the packet, he can use, for example, LTE, MPLS, internet. So 4 packets he is sending via MPLS, 4 packets he is sending via the internet, and the destination device, he is reassembling that packet in order 1 2 3 up to 8, 1 to 8, and then it is going to deliver. So here you can see the packets are distributed proportionally across the aggregate link. Packets are reassembled on the egress when it is coming out. So these are the nice feature we have related to dynamic path control, DPC. Now what caveats or best practices we have? Suppose if we have 2 different type of tunnel, you use same device to terminate the flow. Okay, these are dot tunnel. So what is the caveat? That do not terminate one tunnel here and other tunnel here. This is not the supported design. If you want to do the DPC, dynamic path control, then please terminate the tunnel over the same device, rather one tunnel here, other tunnel here, and like that. So this type of load balancing, application load balancing to more precise, is not possible. All right, so this was related to the DPC. Let's stop here. The other option we have is to boost the traffic. So in case of long distance and say in case of delay generated by device itself, here you can see that what are the cause of latency. So distance, the equipment, loss and congestion, these are causing the latency, and that's why we have the performance issue. So in this case, what we can do, the first solution is that the edge connect devices or edge devices, they work as a TCP proxy and they can do the application acceleration. Now since they are working as a TCP proxy, what's the key here? Here you can see from the LAN to the edge, from the LAN to the edge, the latency is very less, like 2 millisecond, 2 millisecond. Now, if these edge devices, they will work as a TCP proxy for the application, they should know the TCP sequence number first. Knowing the TCP sequence numbers, a sequence 1, 2, 3, etc., that's the client and server, and you have the example. I'll come back to this and explain the sequence number importance. But knowing the sequence number, now these devices can work as a proxy, and this 150 millisecond latency will be reduced drastically. So what will happen? These devices, they will think, means these source and this destination, they will think that they have 2 plus 2 plus less than 150 millisecond of latency. So that's one key aspect we have, that we can boost this traffic. Now here you can see that while this device is working as a proxy, they should know what is the sequence number. Here you can see whenever we are doing three-way handshaking and windowing, at that time the sequence number that is randomly generated, the acknowledgement number. So when the return traffic will come, means when the acknowledgement will come, acknowledgement is sequence plus 1, and then he has started with his random sequence number. When client is sending the acknowledgement back, that will be 2000 plus 1, and then he is sending the sequence, that is sequence plus 1. It's like three-way handshaking, and then they will start the TCP sliding window concepts. But the idea here is that my edge connect devices, they can work as a proxy. Now here is one example. So for example, if we have 50 milliseconds of latency without boost, and with boost you have approx 2684 divided by 10, means overall you have approx 200% of 200 or maybe 300 or 268% to be more precise, uh, percentage of application boost up. In case of 100 millisecond, that will be 1342 divided by 5, maybe something around okay, we can calculate, but again it will be like 200 to 300% boost in the traffic, correct? So that's the thing here, that you can see that if you are boosting the traffic, if you are using the acceleration, if you are using a TCP optimization, the overall performance will be increased drastically. It will increase like 300, 400, 500%, correct? Now, what is the important thing here while doing the TCP acceleration? That your flow should be same. So it should not have asymmetric routing. You should have symmetric routing. If we cannot see a flow in each direction, we cannot see the sequence number. That's the key here with us. So if you do not see the sequence number for A to B and B to A, then you can't proxy. Therefore, the flow can't be accelerated. Asymmetric flows cannot be network accelerated, but still can be network memory, fake, and path conditioning. But suppose if you are not able to do the TCP acceleration, still we have some other methodologies to give the optimization. So for example, the network memory, what is that? This is actually very common thing. What you can do here, that suppose if you have two device A and B, you try to send some file from A to B. Then what you can do, you can compress this file here, and you can use some dictionary for doing the compression, because there are so many different methods of compression. So you can use some sort of dictionary or some sort of uh, common word compression, something like that, like deduplication is the term. That suppose if you have common term coming n number of times, you can create one dictionary with the common term, and next time when you are sending the flow, you are not sending the entire flow, but you are going and checking the dictionary. Oh, this is the common thing I have already stored, so I don't need any reference. I can send it with the same logic, correct? So this is the way that we can compress from one side and decompress to other side, and we can send the packets. So links to the WAN is frequently fully utilized. User complains of slowness, long delay, replication fails, cannot push the data fast, commonly seen in environment where bandwidth resources are out of date, and etc. Still, if you have bandwidth issue, you can use this deduplication and compression. What you can do, that while sending the data, you are storing some elements of data somewhere. Obviously for security you have the fingerprints as well. So here you can see the no cast method and cache method. In cache method, data match in the disk cache, send fingerprint, get local data from cache, deliver. No cache, byte fingerprint as store, compress and transmit, and other side you have to decompress and deliver, or uncompress or deliver. So both the methods are there, that you can do the compression method, compression method with some sort of dictionary if you have local cache. So compression with cache, that is the cache, and then you have compression without cache. Both methods are possible in SilverPeak. So now you can see, now if you list a number of optimization method, you will be surprised that in SilverPeak they are supporting advanced level of compression methods and application optimization methods. Next we have SaaS optimization. In SaaS optimization plus infrastructure as a service optimization, how SilverPeak provide such uh, application and such optimization we'll see. But before moving there, uh, you can see that traditionally, initially in the traditional network, everything we are assuming that is hosted over single cloud. So now we are moving from single cloud hosted application to the multi-cloud or single cloud hosted applications to the hybrid cloud. Correct? So you can see that you have the devices in your left hand side, and assuming that all these branch devices, they are using the application over one cloud. That was the old way. Still so many companies they are using in this way. But when we are coming to the SD-WAN solution, in the SD-WAN solution, we have privilege that we can see the application, or a better way to say this, that we can reach towards the application, or we can check our application and the flows reaching towards the cloud in the optimal way. So those things are possible with a mix of multi-cloud. So either it's an infrastructure as a service, IaaS, or software as a service, or any type of private or mixed cloud. Everything is possible in the SD-WAN solution because this solution is meant to integrate the cloud services. Correct? So now if you see the report from IDC, you'll find that 85% of companies, they are evaluating or they are using the public cloud. 87% of them taken a step towards the hybrid cloud. 94% of the companies plan to use multiple cloud. Why? Because obviously if we use cloud hosted application, the cost will get reduced. Correct? Now in the diagram you can see that what was the yesterday approach, today and tomorrow. So everything assumed to be hosted over single cloud, all the application. Then we can have the mix of cloud, even we have different gateways to reach to the cloud applications. Now we can go and think this cloud as is, for example, regional access, SD-WAN cloud for colo-location. So these two strategy we are moving towards, and yes, our SD-WAN solution, they are providing these strategy. So either is infrastructure as a service or software as a service. In both the cases, the SilverPeak SD-WAN, they are providing optimal routing, best path selection, and network extension. Now what is network extension? That you can create a VPN tunnel from your SilverPeak towards your public hosted cloud or maybe private virtual cloud. So either it's Amazon or Azure, I can use infrastructure as a service. I can create VPN tunnel from my SilverPeak to these vendors. They are providing optimal routing and the best path selection. How they are providing this? Let me show you in the next diagram. So here you can see that I have multiple cloud hosted in different locations. So I have services over different cloud. So those are the provider. Then I have gateway defined, and then I have the branches and the users somewhere here. I have the users. So what is happening in the first place, that the gateway devices, they are checking who are the best possible or who are the nearest location from where I can take the services. So the gateway advertises to the edge connect. You can see I have the gateway for different SaaS application, for example, Concur, Salesforce, Workday, Box, Office 365. So they are advertising their nearest possible applications gateway or nearest optimal path to the branches. And next, what they are doing, that now they are sending their users towards those gateway, means they are using those application provided by those gateways, correct? And this is the way that the branches, they are getting the optimal path or the best path to reach towards the destination. Let us discuss about Edge Connect deployment and some of the use cases. We know that we have three main components in our SilverPeak SD-WAN. One is the Edge Connect, one is the orchestrator, one is the portal. So now this portal, all my orchestrator and all my Edge Connect, they should register with this portal. Now what is the use of this portal? This portal, all the licenses, either say device base, plus, boost, and SaaS, are managed with the portal, no customer action required. So portal is there who is managing and maintaining all type of licenses. Then we have the orchestrator. This is the management software for the SilverPeak device. Must register with Cloud Portal, required for Edge Connect appliance registration approval. So what is happening that whenever this Edge Connect, they want to register, the orchestrator will give the approval. But what is the process that the Edge Connect will follow to get a register with the orchestrator or to join the fabric? We'll see that in the upcoming slide. Now the Edge Connect appliances must register with Cloud Portal to operate, create a network connection and move data as directed by orchestrator. So they need to integrate or they need to authenticate, that's the correct word, from the Cloud Portal, and then they need direction or they need all type of configuration from the orchestrator to get operated. Devices must register with portal periodically. That's correct. Let's move on and see that what is the registration process. Now these devices that we have inside the Edge Connect, so that will come next. So for example, these Edge devices, they are doing completely ZTP, zero touch provisioning. I'll come to that. But first of all, let's see that how the orchestration installation process will come into the picture. So these orchestrator, they have the account name, account key, plus the license. They need to register with the cloud. So you can see that license, account name, and account key are sent to Cloud Portal. After contacting Portal, they are going to register. Now what this Cloud Portal is doing, that obviously they have all the databases related to the orchestrator. They will check their database, cross-verify, and then they approve the registration. Account name and key are the same in the orchestrator and the appliances. This orchestrator can now manage devices associated with this account. It's actually important. So something called as a org name, organization name, associated with all the edge devices that is going to be managed via this orchestrator. They first get authenticated or associated with the Cloud Portal, correct? So now this is the thing, that this orchestrator can now manage devices associated with this account. So this particular account that you are seeing here, so for example test account, this should be there, this should be common there to all the Edge Connect. Orchestrator will constantly talk to the Cloud Portal to learn of any new device that have been attempted to register. So what is the flow here? The flow is very straightforward, that you have Cloud Portal. First of all, your orchestrator will register and they have the account name. Now all the Edge Connect devices, all the EC devices, first they will get registered to the Cloud Portal and then they will get approval. That is the only thing we need to do. Then they will get approved from the orchestrator and then orchestrator will push the configuration to this Edge Connect. Okay, so let's see what's the process we have to deploy or to do the ZTP zero touch provisioning for the Edge Connect. The zero touch refers to the fact that the person deploying the device in the branch just plug and play. You have to plug it, it will get all this configuration. The only thing that admin has to do is to click the approve button in the orchestrator. So let's see the flow. I have the flow. Now here you can see the flow that I have Edge Connect. First of all, it will register himself with the cloud. So here you can see plug a new physical device into internet, either WAN 0 or 1 facing towards internet. Device gets IP DNS via DHCP, connects the cloud portal, that is cloudportal.silverpeak.com. So they will connect to the cloud portal. What cloud portal will do? The hardware device register itself with the portal. Portal gets SN serial number and does a database lookup. Portal plugs device in pending approval state. Now that's the key. So he will match the serial number, whatever burnt in serial number I have with this physical device, and then he will put this as a pending approval state. Correct? Now the portal look up the serial number in its database and contact to the associated orchestrator known IP. So now he will find who is the orchestrator associated with this particular serial number. It provides orchestrator with IP and the serial number of a new edge device. So now what will happen, what the cloud portal will do, so now the request will go to the orchestrator with the IP and the serial number, and inside the orchestrator page I will get this approve section. So once I click this approve, you can see the step 4, admin approves the registration in the orchestrator and adds into the group, and now the approval state is yes. So now the Edge Connect enable, and you can see the Edge Connect plus means whatever license it has, but the key here is the account name, the account key, and the serial number that is associated here, serial number plus the IP associated here, and then he will approve it. Correct? But this is the way that the physical devices get approval and they will get configuration, or they're going to manage from the orchestrator. This is not the case for the virtual devices, because virtual devices, they don't have burnt in serial number. So what is happening in case of virtual devices? Virtual devices require configuration because they don't have burnt in serial number. They must be provided with the account name and account key. Serial number is assigned to a VM by the portal. So what's the process? Let me show you the steps here. The step number 1, you can see that configure a new virtual device, provide account name and account key. So you have to provide the account name and the account key. IP can be configured statically or it can use DHCP. Now this virtual device or the virtual Edge Connect, they are going to contact with the cloud portal. So virtual device register itself with the cloud portal and provides its account key and account name. Orchestrator generates and assign a serial number. Now he is generating and assigning this serial number for this virtual Edge Connect. Portal associated it with an account and the orchestrated portal put device into pending state. Now the portal contacts the orchestrator and provide it with the IP and the serial number. The same thing, the step number 3 here that we have discussed with the physical devices. So these steps are different, but from here it's the same thing. Now once the orchestrator knows what's the IP address and what's the serial number, in this case assigned by the cloud portal, they will put into the approval state. So now the admin approves registration in the orchestrator and add to the group, and now this is in the approved state. Now this particular orchestrator will put the configuration and templates and all those things to the Edge Connects, and they will work. All right, so you can see that we have only minor difference here in terms of physical and the virtual appliances, and it's almost only you have to click to the approval page. Uh, Regardless that, or you exclude that, everything is a zero touch provisioning. All right. Next, we have the use case. Say, what if that your appliances, your edge connect are behind the private network? So for example, MPLS. Now, my edge connect, they don't have direct internet access. They can't directly go to the portal and register itself. Then in that case, what is happening that the SilverPeak orchestrator, so my orchestrator here, they are working as a proxy. And that's the whole goal about this particular slide and the presentation. So you can see here that what is happening in this case, say since the edge connect, these connect devices, they are not able to reach directly to the cloud portal. In that case, what you can do that inside edge connect, you can manually configure the orchestrator IP. So first of all, they try to reach here, and once they don't have a route to reach the cloud portal, then they check, oh, from my gateway, can I reach to the portal? So either I can assign it manually, or you can see that Edge Connect resolve SilverPeak GMS to learn the orchestrator IP address from the customer local DNS server. Correct? So either they can learn from the local DNS or they have the manual IP. Now once they resolve or once they reach to the orchestrator, so this point or this point, now the EC Edge Connect connects to the portal through the orchestrator as a proxy, EC register with the cloud portal. Now what I want to tell here, and that's very important. So what is happening here that, see, although you are able to reach to the orchestrator, but still orchestrator doesn't know that they have to do the approval. At the moment I am just reaching here, he will work as a proxy to take that request. So he is taking the request of the Edge Connect, my orchestrator, and then he is taking that request and carrying forward towards the cloud portal. That's the whole idea here, that he is working as a proxy. So that doesn't mean that he know that he has to do the approval, means the orchestrator has to do the approval for the Edge Connect. Simply he is passing the information to the cloud portal. Here you can see require that the appliances to be able to reach to the orchestrator via the management 0 or the WAN interfaces. Now once this thing will happen, then what is going to happen? Now you can see that the orchestrator and the cloud portal, they are communicating, means now the cloud portal will send the request to the orchestrator that, hey, this is the serial number, this is the device IP, you have to approve. So now you can see that now it is going towards the orchestrator and the request is going towards the appliances. Once this process will happen, then only you can see, then only the orchestrator will push the configuration to the edge devices, and then this will be part of the fabric, SilverPeak fabric. Correct? So here you can see for the incoming traffic, this is going like this. From the portal, the traffic will go like this. Once it will work as a proxy, then these things will be completed, means this device get registered here and he has sent the approval request to the orchestrator. You have to go there as an admin, click approval, and then he can push the configuration to the appliance. Correct? So this is the flow in case that you don't have direct internet access. The other thing we have here, that you can go to the SilverPeak dashboard. From there you have various tabs like topology, deployment profile, template, business intent overlay, discovered appliances and licenses. You can check the licenses, either the base plus boost. SAS CPX EC orchestrator. So whatever licenses here it has, this number is showing that out of 6 you are using 3. Okay. All managed EC devices and license capabilities are viewable from the orchestrator. That's true. That from the management plane I can see all the licenses and their state. Finally, suppose if your license will get expired, still you have 30-day grace period. What is happening, suppose if you are not enabling the license after 30 days, then your device will turn into policy drop mode. Either it's a physical or the virtual, but they will not take any policies. Now what is happening for this license, that all the time orchestrator polls portal every minute. So this orchestrator always polling the information and they are checking the licenses are active or not. At the moment they find that okay, the license is going to be expire, they start sending notification, and in the notified time we should renew the license. All right, so this was the process that we can use and register the appliances inside the orchestrator and the cloud portal, and we can check the licenses for the Edge Connect.
Next, we have installation and deployment overview. What portions we have in the installation and deployment? We have labels, we have deployment profiles, and finally we have business intent overlay. So what does it mean by label? Label are just the identifiers for the interface. So here you can see that I have, say for example, LAN, type is LAN, that is the interface type. Label is data, LAN is again voice, WAN is LTE. It's just the identifier, it's just the label over the interfaces. Now the orchestrator will treat interfaces with the same label in the same way when we are going to apply these labels inside the business intent overlay or the policy. So we'll check that. Next we have deployment profile. What does it mean by deployment profile? Deployment profile means that how you are going to use the label and then you are going to deploy these profiles, correct? So what does it mean? It's simply telling that configuration templates for the interfaces configure of the side, the labels to be applied to the interfaces, the label, the interface speed, etc. So what is happening here? Let me draw a diagram so you can understand this. So suppose I have one edge connect and it is connected with WAN interface. Here I can put what label it has, and then inside the deployment profile, that from the orchestrator this deployment profile can be created, and inside the deployment profile you can see that the profile name, the router bridge server. So for example, LAN interface, what is the label? Data. What is the interface? LAN 0. If you have the IP for the WAN interface, obviously either MPLS or internet, WAN 0, WAN 1. So it's like this, that you have your connect device and your LAN means your source is here, where you have, say for example, LAN 0 and label is data, and then you have say WAN 0 and WAN 1, where one of the interface is say MPLS and one is going towards the internet. Then you can define what is the shaping and the other parameters. So once we have the labels, once we have the deployment profile, then finally we have the business intent overlay. Now these are the overlay obviously configured from orchestrator, used to dynamically create the overlay network of tunnels that connect the appliance together. Define which interface at each site should be connected based on the labels applied to the interface. Defines which source of the incoming LAN should be associated with the WAN overlay. So now finally when we are creating the business intent overlay, now here you can see that okay, the topology type, either it's a mesh and hub and spoke. Then what is the overlay policy? The overlay policy, so for example, traffic access policies for voice,
Now, this particular section is important, and this particular section is something that will provide you insight about the application aware routing type of thing. So what it is telling that, okay, I have the classification for the traffic, that is what? That is voice, or I can use ACL to match the traffic. So both the option I have, traffic type that is coming from the LAN port, or the ACL that is matching some sort of prefixes. Now, when I have, say, first point is the topology. So I have topology 1. Then secondly, I have, say, traffic, what type of traffic I have. Then third, you can see the policy. So if the loss is 2%, latency is 0, jitter is 0, then they will prefer MPLS. If this SLA, this is nothing but the service level agreement, if this SLA will got breached, then you go via internet. And if you want, you may have, say, a fallback option, that maybe LT if you have in your infra, or maybe any backup network that you have. So now you can see that we are defining the topology, we are defining the traffic, we are defining the SLA, and then finally in the bottom you can see that we have link bounding policy as well. So what type of link bounding policy you have? Do you have high availability, high quality, high throughput, high efficiency? So in this case, say for example, this is a type of wires, I want high quality option. High quality means failover is less than 1 second, use the best quality path, path conditioning, bandwidth efficiency greater than 80%. So it will do the path conditioning. We have already discussed about path conditioning, and you can see the failover. So for example, if you have other type of traffic where you want high availability, so then failover 0 second, that is for high availability. Path conditioning is set to 50%. Now all these are the algorithm set. So for example, high throughput, the failover is load balance path, the path conditioning is 80%. For high efficiency, bandwidth efficiency is 80%, failover is less than 1 second, load balance. So one by one you can correlate that what options you have, but now you can understand that the segments of the configurations that we have, the label, it's a LAN or it's a WAN, the deployment profile, with those labels, how we are going to apply or map the interfaces and the speed and even the VLANs as well. Then finally, you are using those logics inside the business intent unit. So if certain SLA will break down, then how we will react. Next, we have the order of operation. The order of operation is something that is dependent that how you are going to deploy the devices. We have already discussed in the previous section. First of all, what you need to do, install the orchestrator and license. Make sure it register with the cloud portal. So I have my orchestrator, I have installed to the portal. That is the step number 1. In orchestrator, what you want to do, create appliance group entry view, create additional interface label. So create the appliances group, create the interface labels, create ACL optional in configuration templates and other required config templates, create deployment profile. So now we know that we have the label, we have the deployment profile, we have the business intent overlays. Create the business intent overlay, create the route policy, but before that you need to create the BIO. So for the BIO, business intent unit, you have to create the route policies. Now the second, actually the third thing is to install the appliance, either it's hardware or the virtual. If they are virtual, configure license interface MAC, means serial numbers and all, assigned from the cloud portal. Make sure they can reach to the cloud portal and able to register. Approve the, obviously these steps also we know that orchestrator will go to approve, that green button is there, click approve. Once the device, so my, say for example, Edge Connect will connect with the portal and then it will get approved from the orchestrator, then the orchestrator will push deployment profile, business intent overlays, and config templates, and then they will be the part of the fabric. So actually this particular recording is very important, that how in general the SilverPeak appliances they work and how all these things are fitting in a picture. Once you logged in inside the orchestrator, what are the things you will find? So here we have all the options, possible options that we are going to implement towards the Edge Connect. So I can go and check the monitoring, configuration, administration, maintenance, GMS, administration, support, and share. Now here you can see that we have something called tree structure, and inside tree structure, if you go and select, then you will find different tabs. So I can have tab for topology, tech support, SNMP, date, DNS, NetFlow, users, and banner logging, means all of the things related to configuration and the business intent unit and the label, etc. So everything related to configuration you can go and check in the tab formats, and actually it's very easy to go and check, verify all those things. Now here you can see that various options that we have the tree view and the grouping, we have this topology view, we have the alarm, where is the alarm, how many alarm, we have the context sensitive menus, we have the legend, and all these the tabbed interfaces, or we have the tabbed view. This tabbed view is actually very good and useful, because generally in whenever we are doing the web browsing, at that time also we are very much familiar with the tabbed view. Now this tabbed interface, here you can see that you can go and click to the tab, and inside that if you want to enable any of the feature, say for example templates, so inside template the system wide configuration, the subnet sharing, network monitoring. So whatever the things you want to enable, you can go and enable. You can go and enable. So those features will be enabled. Correct? Likewise, you can go and check the tab. So suppose if some tab I want to close, I can go and click close, and that might will uh, uh, they will get hided. Suppose if you want to unhide, then again you can go to the drop down and you can select those things, those tabs, and again they will come here and show you. Okay, so overall the thing is that it's very easy to handle. You can easily go and check, click what are the things you want to see. Suppose if I want to monitor the tunnel, I can go to the monitoring, and then we have various color code. Say green is up, red is down, brown is admin down. So these tunnels that you are seeing, say at the moment green, that means they are up and running. But if you see, for example, yellow, that means performance degradation, orange, reduce functionality. So it's very handy, and visually we can go and verify. There is no problem on that. And from one central location, we can manage entire SilverPeak fabric. Hi everyone, welcome to ABC of NSX SD-WAN, that is nothing but the Velocloud. So VMware, they acquired company called Velocloud, and then nowadays they are rebranding the SD-WAN of Velocloud as a NSX SD-WAN. So in the course, if I refer Velocloud, you can think that okay, this is the VMware SD-WAN or NSX SD-WAN. What are the things we are going to learn in this particular course? That how the Velocloud is addressing the existing WAN issues. This NSX SD-WAN or Velocloud SD-WAN components. The controller familiarities means what type of components and the controllers and what are the things we have inside the controllers and the edge devices. How we can create the profiles and the policies, the configuration and zero-touch deployment or zero-touch provisioning, the security and lot more design stuffs. So the agenda here is like, suppose if you know, say for example, Viptela SD-WAN or other SD-WAN product, this particular course you can come and compare those features. But you will find that the Velocloud is one of the trending SD-WAN from last 2 years inside the Gartner. You will see all these things in the upcoming recording and videos. In the Gartner, it is placed as number 1 or 2. So that's quite interesting, and the feature wise and the ease of configuration and multiple features and multi-tenancy and all, you will be surprised that Velocloud is offering all such features. So thanks once again to enroll for this particular course. So before going further and deep dive into the Velocloud SD-WAN, let's check that what is SD-WAN offered from Velocloud for 2 to 3 minutes. So here you can see the clear definition of this, that this is cloud delivered software defined WAN from Velocloud assured enterprise and the cloud application performance over internet and the hybrid WAN while simplifying deployment and reducing cost. So moreover, if you see all the SD-WAN solution, they will give you the same type of definition. But here, what's the difference between, so for example, Cisco SD-WAN and the Velocloud SD-WAN is that the overall goal is that it's a cloud delivered software or cloud delivered SDN solution or software defined WAN solution. It's actually interesting because, say, in all the cases for the branches or maybe for the data center, you may have the hardware form factor, but you may have a software form factor as well. So you may have hardware device, you may have software devices, you may installing your software devices over the ESXi or any hypervisor, or maybe you are deploying over Azure or AWS. You may need hardware devices to pair with the same brand of hardware devices or non-SD-WAN hardware devices. So everything it is supporting, and that's the advantage we have with the Velocloud with the other SD-WAN product. Now here you can see that in the branch you have the Velocloud Edge, which is supporting multipath. You may have internet, you may have MPLS. So SD-WAN goal is that irrespective of transport. So now the transport are not very much what we can say that is not important. As long as you have transport, then you can build the IPsec tunnel on top of the transport, and then you can communicate from branch to branch, branch to cloud hosted branches, branch to data centers, branch to non-SD-WAN locations. So the key components, you can see that you have the edge cloud, you have the orchestrator, you have the cloud gateways, and one of the cloud gateway you can clearly see it is going towards the software as a service hosted applications like Office 365, Box, AWS, etc. You may have hardware to hardware device, means you have branch to branch or branch to data center device where you have the IPsec connectivity. So like that, means most of the SD-WAN solution are offering such uh, features. Now again, you will see and you will heard in the upcoming recordings that, yeah, it's up to the customer that how they are comparing the features like cost, prices, and the licensing cost, and the features and the ease of use and the integration with the API and the other stuffs. Okay, but overall you'll find that they have very nice GUI, a very powerful orchestrator. Means the In summary, means that the Velocloud will provide most of the features, not 100%, because again, if we are checking the security and the firewalling option within the box, so those features are not there. That is there in the Cisco Viptela ISR boxes, where you can create the container, put the IPS IDs and all those things. So, but what are the goal of the SD-WAN, or what's the goal of enhance or optimize WAN? All those features you will get from this Velocloud or NSX-SD-WAN, and that's why it's trending at the moment in the market. Let us see what market players we have, and let's compare with the Gartner report. If you see the Gartner report for 2018, you can clearly see the Cisco was trending, and still the VMware was there in the race. So here you can see the three major SD-WAN vendors, SilverPeak, Cisco, and VMware. Still you can see Versa, and you can see others as well in this list, although the font size is very small. Let me go to the VMware report. So if you go to the VMware site for this 2019, you will see that VMware is way ahead than SilverPeak, Fortinet, Cisco, Versa, and CloudGenix. Although all these are very nice SD-WAN solution, and most of the customer are using these SD-WAN products at the moment. Even we can see that Juniper is also matching up, or it is growing up. If you see the Juniper report, initially it was very bottom, now it is gaining its space and the customer. So clearly you can see that this is one of the interesting thing that we are getting, like from last continuous 2 years, VMware is still in this particular zone. And even I also have seen that many of the customer, they compared VMware, SilverPeak, and Cisco, and due to some cost, due to some other features, we'll see later on what features we have in the VMware Velocloud. They finally given the bid, or they finally move, or they went for VMware Velocloud. Later in this course, we'll go and study about different features of SD-WAN product. One good thing about SD-WAN is that once you learn, say for example, if you are very good and you learn Cisco SD-WAN, that is Viptela, then if you want, and if you learn SilverPeak or VMware, you will find that 90% of concepts are the same. So they have almost the same concepts, only maybe the orchestration plane, the GUI interfaces, those things will change. But all the devices, they have to do the cloud integration. You can create the policy push to the edge devices or branches devices. You can do sort of traffic engineering. You can create some app-aware routing policies. All those stuffs are there that we can do. Now let me quickly go to the Cisco site, where Cisco has given their comparison. This is 2018 comparison. Let me quickly go to the bottom. Let me see the date as well if they have given. Yeah, I think this is last year comparison when Cisco has integrated their devices with the security uh, plugins. Say for example, they have added their devices with ISR and ASR with uh, firewall, IPS, IDS, virtual containers, AMP, URL filtering, etc. So now if you see this particular comparison chart from Cisco website, you can go and search this. You will find that, okay, with respect to security, Cisco has edge over all the other product. Although Versa, they are also offering the security features. You can see clearly network sensor, trustworthy system, Basically, I'm comparing here with Cisco and the Velocloud because these are the two major players. Most of the places you can see, except security, they are providing both Cisco and Velocloud. They are providing the same capabilities and features. Some of the places Velocloud is not strong enough, but Cisco is strong enough. Now, again, if you go and uh, check with the solution architect and the design architect, so they will tell it depends that what type of design you have. Suppose in your design, if you don't want firewall inside the branch or firewall inside the same box because you don't want to overburden the device capability with all sort of security patches and then the routing and the other stuffs, because already there is so much optimization and enhancement inside the box. So it can do local exit, it can do cloud unramp or cloud express directly, it can go out, it can do firewalling. Suppose if it is doing firewalling, AMP, URL filtering, etc. So you are putting so much load on the device. Some of the design architect, they are telling, okay, I can redirect the traffic towards a central hub where I have the security devices, and from there it can go out and come in. So it depends that what is my design, what is my obviously what is the uh, bill, or what is your budget for that solution. So depending, you have to compare each and everything. What is the license that Cisco is providing for 3 year and 5 year subscription? With respect to Velocloud, how much they are charging, what is the license cost, what features they are providing, is this the unlimited capability for application filtering or application routing, etc., etc. So it depends that how the licensing is coming into the picture, what are the features inside the licenses. So while creating such type of reports that you are seeing here, they are comparing each and every parameters, and then why clients are taking a particular solution with solution B, C, etc. All right. So that's why this course is very important for us. We should learn that how VMware is doing their SD-WAN with help of Velocloud. In this session, we'll discuss about SD-WAN benefits and feature. Now, if we use SD-WAN and if we compare with the existing WAN, we have benefit, we have advantage. SD-WAN having business agility, internet economics means we can run the corporate network or corporate traffic over internet circuits. We have optimized cloud architecture. Yes, it's very easy to integrate with the cloud, and directly my branches can uh, break out and reach out to the cloud. They can use cloud hosted applications. Apart from that, you can see that some considerations are there, like ease of adoption and management, ability to migrate to hybrid WAN. So not only that you have two private MPLS circuits, but you can run the services over MPLS plus internet or broadband, or LTE circuits, or you can run over dual internet or broadband services circuits as well. Uh, it is supported, means full automation is supported inside the SD-WAN. What are the features we have? Now these are the features, and all these features that listed here, this is supported to other SD-WAN vendors as well. So if you take Cisco SD-WAN or SilverPeak or Versa or any Juniper, Talari, whatever we name it, and you will see that all those SD-WAN, they are supporting virtualization of network, enable secure overlay, simplified service delivery, provide interoperability, leverage cost-effective hardware, support automation with business policy framework, uses monitor usage and performance. So we have full visibility, supports interoperable and open networking. Yes, we can do the programming, means not only we are restricted with the CLI or GUI, but we can do everything with respect to API, that is application programming interface as well. So mostly in the Velocloud, it is recommended either you use things from the GUI or you can use the API as well. But more or less, all these features are there in all the SD-WAN. What are the key components we have with the VMware Velocloud? So we'll see that key component. I have one diagram after this slide. I'll show you that. Before going to that, you can see here that if we use Velocloud, then we can use cloud hosted application. It's very easy to integrate. It's independent of transport. All SD-WANs are independent of transport. We can shift the MPLS cost or MPLS load to the internet circuit. Apart from that, we can improve the real-time voice and video applications. You have full management and visibility that we have discussed in the previous slide. Simplicity, we have a zero touch provisioning or zero touch deployment. Link remediation and correction. Yes, it can do the link remediation and error correction. Again, I have seen that in Cisco also we have the forward error correction, FEC. We have the FEC inside SilverPeak as well. So assuming that all the vendors having this feature, link remediation and correction, it is supporting multi-tier and multi-tenancy. Most of the vendors, they are supporting multi-tenancy. Some of the vendor like Velocloud has edge with the Cisco multi-tenancy feature. In Cisco, we have some restriction related to tenancy. Now here you can see the overall architecture of VMware Velocloud, and I can see that, see here we have the data center and you have your hardware box at the data center. Now from this data center, two links are going. This is just a logical diagram to interpret that what exactly we are doing. So that's why I have one data center and one branch showing here. So what is happening here, that I have my data center and two circuits are going. One is going to internet, one is going to private MPLS, and then I have the branch that can do zero touch provisioning. Multiple links that is going to the internet. One of the link is going to the private network. Then here you can see that we have feature Velocloud dynamic multipath optimization. So path optimization feature we have. From the client, from the branch, it can directly go to the cloud as well. So it can use software as a service applications related to, say, for example, Office 365, Box, and so many cloud-based applications. Service insertion is there, means you can redirect the traffic towards the security devices or gateway. And then you can see that we have the cloud hosted Velocloud orchestrator from where I can create the policies and push to the data plane devices. So this is the orchestrator who is orchestrating the entire Velocloud fabric. So this is the top view of Velocloud architecture and the components that is going to be used inside VMware Velocloud SD-WAN. In this section, we are going to discuss about the architecture overview of Velocloud. Velocloud supporting both the enterprise deployment and the service provider deployment. So let's discuss first the enterprise deployment. Now here you can see this diagram looks like very busy, but this is my data center. This is non-SD-WAN data center, so it is going towards the hub location, I can say at the moment, or it is going towards the gateway. That is the VMware SD-WAN gateway by Velocloud. It's an embedded controller. So non-SD-WAN traffic can come here. The other data center I have here, you can see this is SD-WAN enable. So this is coming and going to this is a part of SD-WAN fabric. So non-SD-WAN fabric, SD-WAN fabric. Then you have branch. So for example, in this diagram, I have only one branch. This branch is also SD-WAN enable. One interface is going towards the MPLS, other interfaces are going towards the internet. And then I have the cloud gateway. From there, I can go and use the SaaS based applications. So Office 365, Box, Azure, and AWS, etc. Now, if I draw this diagram in a simple manner, so how it look like, suppose you have DC1, suppose you have DC2, DC1 is the legacy one, DC2 is SD-WAN enable. Now for DC1, I should need a gateway. And then suppose I have ISP MPLS and then ISP internet, and then I have one of the branch, say for example, branch 1. So branch 1 edge devices are connected with both MPLS and internet, and then it is going here, and this is going like this. From here also it can go like this and go like this. Means we may have connections. So if it is going here, here also you should have gateway, etc. We can think like this in the simplified manner. So you have non-SD-WAN network, you have SD-WAN network, you have branch and overall fabric. So now this is the fabric you have, and this non-SD-WAN fabric will also become part of SD-WAN fabric, because here you have the encapsulation, decapsulation will happen for this particular traffic. But overall fabric up to this point will be managed from the VCO, Velocloud Orchestrator. So we can think that everything here will be managed by the orchestrator. This is the enterprise level deployment. Now, when we are talking about the service provider deployment, at that time what is happening, because for service provider, you should support multi-tenant architecture, and that's the key here. So data plane in the cloud, not just management. Your data plane is also hosted in the cloud. Yeah, you can host your data plane devices in cloud. It's not a big thing. All the SD-WAN, they are supporting this feature. Then you should have two multi-tenant gateways and orchestrator. And that's the key actually for the ISP. All the ISPs, because they are supporting multiple clients, so they should have full and true support of multi-tenant architecture. So think about the DNS hierarchy or architecture like that. You should have your root, then you have your A, B, C, and then you have A dot B. Like that you can think. So it should be in the pure multi-tenant architecture. Again, you can see multi-tier role-based management for SP. So it is supporting everything. All these things are orchestrated or managed via the orchestrator. Then here you can see that provider cloud. Then you have the legacy enterprise data center. If it is a legacy, it will go to the gateway. From here, it can go to the SaaS-based application. Then you have your private MPLS. Then you have the gateway. Then you have the branches. So say for example, this is example of one of the client, but think like you have same box for multiple client, and then you have the multi-tenant architecture. So it's something like in advanced term, in bigger term, it's a pure virtual network. So one network, one client, like that we can think. What are the components we have in the SD-WAN? We have the VCO, that is the Velocloud Orchestrator. What this orchestrator can do, it will support multi-tenant cloud-based management, configuration, monitoring. VMware or any service provider or MSP, managed service provider, can host in their premises, or we have the on-premises deployment as well. So over the cloud, over the VMware or the on-premises, all those features are supported. They have the business policy abstraction. They are supporting APIs. They are supporting zero-touch deployment. That's a big feature we have in actually in all the SD-WAN. We have that feature. Most of the SD-WAN we have these features. So all the SD-WAN, Cisco, SilverPeak, everyone is supporting APIs. That's true. Next component, we have the edge devices. So we have the virtual edge and we have the physical devices or appliances as well. Fully flexible in deployment, purpose-built hardware, virtual edge for cloud or the white boxes. In the next section, we will discuss about which type of hardware boxes we have for branches, data center, and cloud. So we'll see that edge devices, what are the series of edge devices and the capabilities in the upcoming section. Then we have the gateways and the controllers as well. So here you can see for the SaaS based application, we have the gateway that is optimized cloud on-ramp for the SaaS or the infra as a service applications, fully managed and operated by VMware and the service provider. It's multi-tenant supported, a static worldwide location, and they have the location in the cloud across the globe, very much like AWS availability zones. So you have the availability zones or regions across the globe. So these are the major components. In the next section, we will learn and understand more about the hardware edge and its capability. Let us discuss about the edge devices in the Velocloud. Now, VMware, what they have done when they acquired this company called Velocloud, you will see in books and various places that they are referring this as a NSX SD-WAN instead of Velocloud SD-WAN. So some places you'll find that the term used as a NSX SD-WAN. What are the edge devices we have? You can see we have the hardware and we have the virtual form factor as well. In hardware, we have Edge 500, then Edge 800, and then Edge 1000 and 2000. It's actually very much similar like uh, Viptela edge devices. If you see Cisco SD-WAN Viptela, at that time also you will find some Viptela Edge 100 and uh, Edge 1000, 2000, 5000, etc. So even the numbering are also very much similar. If you want to know more about these devices and their hardware and interfaces and the activation process, you can go to this particular URL. So let me go and uh, open this particular URL. So here I am. Once you open this URL, you can see this is the activation guide for all the edge devices. Which edge device you want to activate, 500 or 800 or 2000. Suppose if I go and click here, select 2000, and you can see that this 2000, even if I go back and if I show you that what are the capabilities and interfaces supported. So here you can see in the 500 you have two LAN interface, you have two WAN interface, you have two WAN interface, 8 LAN interface, etc. You can go and check the capabilities and the overall throughput supported in these devices. Now let's see the standard configuration steps. So what you need to do, connect the power cable, remove the front bezel, press the power button, connect with the internet. So some interfaces you have to connect with the interface. Some of the interfaces you can connect with the laptop or the switch, where you can go and configure or activate these devices. Simply go and follow these simple steps. Once you follow these simple steps, here you can see the steps related to you are using the DHCP, or you are using the static manual IP assignment, or you are using triple PoE. The steps are simple. You can go and do the configuration, select the interface, put the static IP, give the subnet mask, gateway, auto negotiation on, use this interface as a backup, no, done. Likewise, you can go and check triple PoE, how to activate with triple PoE. If you want to know how you can insert the SFP ports, here you can see the arrow mark pointing towards the SFP port. What are the supported SFP port list you have? Here you can see the supported list of the SFPs. So you can go and navigate those link, and you can get the activation process. It's very easy. In the lab section, we'll see that how we can do the ZTP, zero touch deployment, or ZPD, zero touch deployment or provisioning. Both are the same. Still, if you have any issue, they have the 24/7 support. You can go and submit the support case as per your company email address or your company licensing process. You can go and raise the case. All right, so let's stop here. In this section, let's discuss about the core features of NSX SD-WAN or Velocloud SD-WAN. One by one, we'll see all 1 to 7 features. I have slides for that. zero touch deployment or provisioning. So what you can do that at the branches, you don't need network engineers or technical support guys. Simply someone can go and plug in the cable, means that edge device, if someone will plug in with gig E1 or gig E2, automatically it will take all the configuration, policies, everything in that particular box. So it's like zero touch deployment. It's very easy to deploy the devices at the branch level. It will do dynamic path selection, all the SD-WAN having this feature. So as per your policy and configuration, suppose this is your edge device, and in one of the directions, suppose it has two direction, one is MPLS, one is internet. From one path it has any issue, dynamically it will change the path and it will prefer to go to the other path. Now, not only they do the dynamic path selection, but they are supporting something called the application aware path selection. So it has multipath optimization, compression, automatic link monitoring, auto detection of the failure, auto configuration, etc. Means it has so many features. In the upcoming section, we'll see that what type of business application support and the link failure options we have. Then you can see we have the link steering and remediation, and this is actually a huge feature we have in the Velocloud. You can see clearly that we have the on demand per packet. Now the Cisco SD-WAN, they are supporting per flow feature, but at least two of the SD-WAN, one is the SilverPeak and this Velocloud, they are supporting per packet link steering. Uh, and it is measured. We'll see how they are doing this thing. While doing the configuration, you'll come to know that what are the parameters and what are the options we have to configure the link steering and the remediation. But behind the scene, they are checking per packet uh, input, and according to that, they can do the steering and the remediation. So it has the intelligent application learning. I told you that application aware. So these devices are application aware, and they can sense what is the metadata of the application. According to that, they can take decision. They have the business priority of the application and the link cost, deliver sub-second backhaul and the brownout protection to improve the application availability. Remediates link degradation through forward error correction, and this is there in the Cisco as well. Cisco recently they have added FEC. In the previous videos also I use this term FEC. So they can do the forward error correction. Even in Cisco ACI also, if you see that, you'll find they have the link forward error correction method that they are using. Activation, jitter, buffering, and synthetic packet projection. So all these features, one by one, if you go and search about these features, you'll find that the explanations are there. I have explained all these things in my SilverPeak course. So if you have time, just go through and check the SilverPeak course where I took time and I explained all these features with the diagram and what's the use case that you can check once. But yeah, in Velocloud also it is supporting almost same features we have in the SilverPeak as well. Some of the features are not there in the Cisco SD-WAN. Then Cloud VPN, we can create any to any VPN. And good thing about the Velocloud is that you can create NSX SD-WAN and non-NSX SD-WAN VPN connection. So that is a nice feature. I can mark this as a nice feature, because if you compare with Cisco SD-WAN, you will find that Cisco SD-WAN devices can form IPsec tunnel only with Cisco SD-WAN devices. But here this restriction is not there. You can create the IPsec tunnel with the non-SD-WAN to the SD-WAN sites, and rest of the things are the same as the other VPN. So what we can do, you can create the IPsec tunnel with the SD-WAN with non-SD-WAN, then obviously SD-WAN to SD-WAN, and this is something say any to any. So you have any to any. connection from SD-WAN to SD-WAN devices. And not only that, but third option is also there, that you can create tunnel with SD-WAN to the cloud uh, service provider like Amazon or other cloud service provider. You can see the third party data centers, at least with the Amazon AWS. So I can create the IPsec tunnel with the cloud hosted gateways or the third party provider like AWS as well. In short, you can create IPsec tunnel with all the use cases. So either it's SD-WAN, non-SD-WAN, hosted in the cloud, everywhere I can create it. Now the feature number 5, this is again, you have the advantage in Velocloud with respect to Cisco SD-WAN, at least because Cisco SD-WAN has a major restriction in the tenancy mode. But in the Velocloud, all the Velocloud components like orchestrator and gateways are multi-tenant in nature. So we can create multi-tenant architecture. If I have a design or requirement related to multi-tenancy, basically this multi-tenancy is very much suited for the service provider network or service providers. They are looking for multi-tenant architecture and the deployment. So for them, it's very much suited or suitable architecture. But yeah, you can see that the Velocloud components, orchestrator and gateways, they are multi-tenant in nature by default. We can create segments because what I want, that suppose I have the corporate traffic, suppose I have the guest Wi-Fi, suppose I have the PCI traffic. So for all those traffic, I need different VRF or VPN. VRF is almost same as the VPN. So there is no restriction. We can create n number of VRF or VPN, and we can segment the traffic from a particular VPN to other VPN, and irrespective of the same branch. So even the same branch traffic also will not communicate if they are in different VPN by default or other branch. So here in the diagram, you can see the corporate of other branch. So corporate VPN of other branch can communicate with the corporate uh, network or corporate VPN of the other branch. Means the same VPN can communicate, but different VPN, either they are in the same device, so same device also they will not communicate, and other device also they will not communicate, because we have the restriction by default they will not communicate. So we have the segmentation. Now you can see that major of the features are supported, and finally you can see that they are supporting the virtual network function. So you can create the virtual, or you may have the virtual form factor with respect to SD-WAN gateways, with respect to SD-WAN hardware, SD-WAN edge hardware. You have the full support of service chaining as well. So all these major uh, features are supported. So if major features say independent of transport, they are independent of transport, say link steering and remediation, that is again a very big feature. We have the dynamic path selection they can do. Then you have the auto or dynamic VPN, and any type of VPN is supported. Then you have multi-tenancy support. Then you have VNF, and you have the service chaining, and the last point was that it has the segmentation. So almost each and every feature is supported in the Velocloud, and not only these features are supported, but they are unlimited. Means we can create unlimited number of segments, we can create unlimited number of tenants, etc. Means theoretically we can create, as per our device limit, unlimited number of segments and the tenants. All right, so let's just stop here. Let us see that how Velocloud Edge 500 look like. Let me show you the diagram. Here you can see that this Edge 500 having 4 wireless LAN connector. You can see the USBs. So 1, 2, 3 and 4. Then you can see you have the power cable, you have 4 LAN interfaces. We have two RJ45 type of WAN interface and one SFP WAN interface. We have the reset button as well. Now what is happening, because there is no CLI in the Velocloud edge devices, so you need to log in. This is the front panel and this is the back panel, and the LEDs are there like green, red, amber, etc. So you can check the status with the LED colors. So all these icons will glow and they have their LED status. According to that, you'll come to know that services or devices or interfaces are available or not. Now, when you're configuring the device first time, what you need to do, once you are in that particular network, you have to go and browse this device via the UI interface. The UI interface is edge velocloud.net. Now once you log in, I'll show you that once you log in that what option you will get in the next slide. But once you log in, you have options to check the overview, properties, diagnostic and the reset setting. One by one we'll see all those things. This is very important here, this important note. You can see that this is the first time configuration or setup. Now next time onward, you don't need. So you don't need to log in via this way, because everything will be managed via the Velocloud orchestrator. So everything will be managed via the VCO. Now, if you log into this particular URL, you will get this particular page. In this particular page, you can see that you have the diagnostic option, reset setting. You can see the connections or connected, both unconnected, overview and details. Now in this particular page, you have option, you can go and click to Internet 1, you can go and click to USB, you can go and click to LAN. So everywhere you can go and click. Suppose I want to see the WAN connectivity. So I will go to the wired WAN. I'll click there. At the moment you click there to that UI, you can see the status, you can see the configuration. Now it is recommended that you do the configuration like static or PPPoE. Even if you have the DHCP server somewhere, you can get the IP from the DHCP as well. Once you do the changes, once you go and click save changes, at that time you have to give the username and a password as a admin. That means you are saving the configuration inside the UI. Now the next options we have is the diagnostic and the reset. So here you can see that if you go and click diagnostic, you have plenty options there. So we have option, we can go and check the ARP table dump, we can do the bandwidth test, we can do the ping test, we can have the route table dump, VPN test, Velocloud status. So inside the diagnostic, you can see it's a small UI, but still we have that capability and features that we can check the various services and the bandwidth. Then finally we have the reset setting. Inside reset setting, we have these four options. I can identify. So you can identify, means once you go there and click identify button, this will flash the edge device for 30 seconds to locate the edge. I can restart the service, I can reboot the device, I can do the factory default reset. Like in mobile phones also you have this reset configuration. The same type of things. Once you do the reset, everything will be returned as a factory default configuration. And here you can see inside the Edge Velocloud, if you go, this is the UI to log in, and one by one you can go and use different services. So if I go back here and from the diagnostic, I can go back to the reset setting. Once I reset, you can see the device LED will flash for 30 seconds in the identify, the restart service, the reboot, and reset the configuration. So this is the way that in first time when you want to log in, you want to do very basic IP setup, or you want to test various parameters related to ARP table or bandwidth, or you want to do the ping test, Velocloud status, etc. You can go log in and verify like this. Now we have the same type of configuration, UI configuration, to all the other Velocloud edge as well. So if we know 500, so I can go and then I can configure 5x0 or Velocloud S1000, etc. In this section, I'm going to walk you through the Velocloud Orchestrator dashboard. So let me log in to the Velocloud Orchestrator dashboard. Now here you can see I put the URL and the first page will be look like this. Then you can go and put the username and the password. So let me put the username and the password. So once you put the username and the password, then you will get the main dashboard. In the dashboard, you can see that we have only four category or four rows. So I have monitor, I have configure, I have test and troubleshoot, and the administration. So these four tabs we have, and if I go inside the monitor, what I can monitor? So I can monitor the vEdge or the Velocloud Edge, the network services, the routing, alerts, events, correct? Now once you are inside the edge, and suppose if you go and click, say for example DC1 hub site, so once you click that, you will see that you are inside uh, edge and administration and configuration. So what I try to tell here that there are multiple ways you can reach to a certain place. So same thing, I can go here to the configuration and I want to configure to the edge. So here you can see if I want to configure to DC1 hub site, I can go and click, and then you can see I have the configuration option. So likewise, you can reach to the same place with the various options you have. Although all the tabs that you are seeing here, it is very straightforward, but if you go and click, we have multiple options to configure it. Okay, so say for example, I'm inside DC1 hub site, and if I click configure this device, you can see this is the edge overview, device, business policy, firewall, etc. What does it mean that now you're inside the configuration? Again, let me show you this. Monitor edge. If I go and click edges, I have the list of edge devices. It's very much like Cisco Meraki. In Cisco Meraki, also you have such type of dashboard, not exactly same, but uh, I can say 30 to 40% similarity. Now, inside monitor, I click that. Again, if I go and click the configure this edge, so you can see clearly now I am inside configure an edge. Correct. So let me go back and quickly summarize all the things. So inside the monitor, we have edge, services, routing, alerts, events. Then I can go and click configure. If I go inside configure, I can configure the edge. I can create the profiles, segments, overlay flow control, network services, alert, and notification. Once you are in the edge, you can select obviously search certain device you want to configure. So for example, the DC1 hub site, then the activation state, then the authentication mode. You can see we have the profile option. Later we'll see in the upcoming section that how we can go and create the profiles. So let me go and click DC profile. Then you can see that services, segments, then the contact and location, RMA reactivations. So you have these options that you can go and check. If you want to raise the RMA, you can go and create that. Then you can go to the devices. Inside devices, now you're getting the robust option. So authentication setting, radius is not there, DNS setting, public DNS we are using Google, NetFlow is not configured. Later on we'll see that how we can go and create all these configurations. Static route setting we can create. Then we have the ICMP probes, ICMP responder, VRRP uh, settings for high availability, and then we have this cloud VPN. You can see this is on for branch to non-Velo cloud side, branch to Velocloud hubs, branch to branch VPN. Then you can see the OSPF BGP setting, high availability, again high availability in between Velocloud active standby pair or Velocloud cluster or Velocloud to non-Velocloud VRRP pair. So we have the VPN configuration with Velocloud to non-Velocloud, plus we have the VRRP configuration with the Velocloud with non-Velocloud. Then we have options related to WAN setting. You can see we have options related to interface setting. I can add the sub interfaces, secondary IPs. You can see multiple options, interfaces and segments. Then we have the WAN setting, MPLS, and the other WAN setting we have multi-source, QoS, SNMP setting, and NTP setting, visibility mode. So plenty of options we have in the device section. Then you can go and check the interested applications, a business application. Officially in the Velocloud official document, they are telling that Velocloud is supporting more than 2,500 applications. And these are the applications and application families you can see here. They are the group of the applications. Then SD-WAN, traffic class, and the weight mapping, so that you can go and check the real-time transactional and the bulk traffic, what is the priority, policings, etc. The rate limit for that. Again, at least this section or this type of section we have in the Meraki also. Then firewall options. So now you can see that we can create the application filter rules related to firewall. At the moment everything is blank. Again, this is also very much like Cisco Meraki. We have support access, SNMP, local UI access, etc. So I can create the rule related to outbound firewall rules, inbound firewall rules. If I am using NAT and the firewall. So this was the configuration and edge. Likewise, we can go and create the profile. So we have the profile related to devices, business policy, and firewall. We can go and create the segments as well. At the moment, we have the global segment, but we can create n number of segments. We have overlay flow control. So we have overlay protocol, which is running as a BGP. And you can see here that we can go and enable this overlay flow control, and the priority is edge, partner gateway, routers, and hub. You can see here all the options that is checked. We have option, I can go here to edit, and then I can use the priority and these settings. Let me leave it as default. Then we have the network services. Inside network services, we have the edge cluster, cloud VPN hubs, non-Velocloud sites, cloud security services, and alerts and notification. What type of alerts and notification you are looking for, we can go and check. 100% same like Meraki. When in Meraki, we have robust options related to alerts and those things. Then when we are talking about the test and troubleshooting, if you want to collect the diagnostics related to any site, if I click here, then it will go and run the diagnostic. It will take some time to generate all the, say for example, tech supports, core dumps, etc. that I don't want. Then remote action, if I click any of the device, you can see this is the same that we have seen in the local device UI. So we have the identify, so 30 seconds the LED will flash or it will blink to identify the device. Restart services, reboot, shut down, deactivate. Then you have the packet capture. If any troubleshooting related things we have, we can create the PCAP. We can take the captures and we can check inside the Wireshark, same as Cisco Meraki. Finally, we have the administration tab where the general information, the edge configuration, privacy, and the other stuff. So In terms of tab, you can see that only 1, 2, 3, 4. 4 tabs we have inside the configuration. We have plenty of option. If I go inside the configure edge, again we'll find some options: profile, segments, and overlay flow control. So you can see the overlay flow control is one and the profile is the other one that is very important. And overall this configuration section is very much important, and we should spend much time here understanding that how I can configure, because once I configure, then the monitoring and the troubleshooting and the administration is like easy to understand. One point I want to add here, that suppose tomorrow if Velocloud has to add certain feature inside their orchestrator, simply they can run the program and then you will find one extra tab here, two extra tab here related to some new features that they have added. So that's the nice thing we have when we have the programming oriented control planes. So we can do changes as per the customer requirement. If customer tell that, oh, I need certain features to be enabled, so at that time programming can be done in these controllers.
In the upcoming series of videos, I'm going to compare the VMware versus Cisco SD-WAN, the Velocloud versus Viptela components. So let's see one by one. Now, Velocloud having the Velocloud Edge, and we have seen that we have 500, we have 1100 series Edge, we have both the form factor, we have the form factor related to software, and we have hardware as well. So here you can see that both the Viptela and Velocloud, they can do a zero touch provisioning. They are enterprise class device. They can be hardware, they can be software, provide secure and optimized connectivity to private, public, hybrid application, compute and virtualized service. Same. This particular feature is same in both places. Now in Velocloud, the devices, they can do deep packet inspection, and here officially they are supporting 2500 plus application recognition. Now application and the packet steering, on-demand remediation, performance metric and end-to-end QoS, in addition to hosting VNF services. In Cisco official guide, their N bar 2, so Cisco application recognition engine is N bar 2. That is in the ISR and CSR devices. In the V edge, that is the Viptela edge, that engine is Cosmos, so Cosmos, COSMOS, and they are supporting these many plus application and all those features that we are seeing here. Now, quality of service is one of the feature that can be checked between the Velocloud and the Cisco solution, because in Cisco solution, quality of service is a little bit weak, I assume, and we can check here that how quality of service supported in Velocloud. And edge pair can be deployed to a HA, so there also we can apply it as a HA. VRRP is supported in Cisco, also in Velocloud also, and rest of the things like it can be used in a large site or data center or small branches. So all type of hardware appliances we have with respect to Velocloud. So most of the things are almost same in terms of branch edge. Now let's see the difference in the orchestrator. Now if you know SD-WAN, Cisco SD-WAN, you know that you have vSmart as a brain, you have vManage as a management plane, you have vBond as an orchestration plane. So you have control plane, you have management plane, you have orchestration plane in the Viptela. Here you have something called VCO. Now this particular Velocloud orchestrator, it can be hosted in the cloud, and that's the recommendation from the VMware, but it can be in premises as well. Uh, Now here you can see that what the orchestrator can do. So centrally manage and monitor means whatever you can do in conjunction with vSmart plus vManage. So this VCO can do.
and we have one-click provisioning for the edge devices. Later, we have lab related to zero-touch deployment, and we can see that. Now here also you can see the complexity has been reduced, because at time customer will tell, okay, why I will manage multiple appliances or virtual appliances like that if I have option everything is combined inside a single box. All right, let's see the other component that we have, the Velocloud gateway. Now this is again a huge thing that we have in the VMware, and Cisco also has introduced CSP in their, I think 18.4 or 19.x onwards in Cisco Viptela Core. You can go and check, you can Google it, CSP, that how non-SD-WAN traffic can come and reach out to the gateway, and from there it can go to the SD-WAN domain. A Velocloud gateway, here you can see that network consists of gateway deployed. We'll see more in the designing and the architecture that how these gateways actually will come into the picture. And if I have the diagram, let me show you that I have one diagram related to Velocloud. Here you can see all the components. So here you can see the orchestrator, you can see the edge devices, you can see the gateways. So these are the places where you can find all the Velocloud components. Let me go back. Now clearly it is mentioned that these are the gateways, and they can be present in the cloud as well, and VMware has partnership with multiple ISPs, so they can provide the gateway as well, and it can be gateway for software as a service, infra as a service, and the cloud network services. It is multi-tenant. These virtual gateways are deployed both by Velocloud Transit and cloud service provider partners. So partner can also provide you the gateway, and the Velocloud Transits also you have the gateway. The gateway provides the advantage of on-demand, scalable, redundant cloud network for optimized path, as well as zero installation application. So what is the importance of gateway? Actually, what is happening in terms of gateway, let me quickly show you the idea behind the gateway. So suppose you have application hosted in the data center, the SaaS based application, and maybe you have application here also, or maybe you have application directly hosted here also. So suppose this is the nearest, you can go and use those application, or you can go and use the application in this direction, or you can go and use the application in this direction. So now the same SaaS based application you can reach from three different places. Now it's a use. Now then what's the use of this gateway? Now gateway, or maybe if you have direct breakout, so it's a local exit. Now the Viptela box or the Velocloud box, both are doing the same thing. So either say Viptela or the Velocloud. In this case, we are discussing about the Velocloud. So now these boxes, what they are doing, that they are comparing the loss latency jitter in path 1, 2, and 3. And that's the optimization and multipath support it has. So suppose in this direction, if although you are going directly out to the cloud-based application, if you have issues, then you can prefer this path or this path. And that's the whole idea behind the scalable gateways, redundant gateway, and cloud or service provider hosted gateway or partner hosted gateways. Now a cloud edge may also be configured as a Velocloud gateway to provide internet inbound firewall protection. We'll see later on in the upcoming section that in terms of security, how Cisco has enhanced their security and what integration they have. But you can say that they have the gateway devices which can easily provide the good efficient routes, optimized path, quality of experience related to SaaS and infra as a service hosted services. Now just to compare with, if you are not doing the if you don't know the Cisco SD-WAN components and all, so I put this diagram here. You can see the vManage, you can see the vSmart, vBond, and then you have the edge devices. They are forming the IPsec connections or tunnel in between them, and with the control plane they are forming the DTLS or TLS connection. This is the architecture of the Cisco SD-WAN. Now let me go to the VMware SD-WAN or Velocloud SD-WAN. You can see this control plane. All the functionality is inside this control plane. So your VS, your vManage, your vBond, everything is inside this. And then you have the gateway devices, so providing the optimization and the redundancy. And then you have the edge devices. Okay, so this is the comparison video recording one. Next section we'll learn about the capabilities comparison between Viptela and Velocloud. Let us do the feature comparison between the Viptela and the Velocloud boxes. Now you can see in Viptela we have all sort of supports. So they are supporting the application SLAs, means we have quality of experience. For SaaS application, we have application SLAs. We can create app-based routing policies. So we have that capability to create app route policy. Nowadays we can create app route firewalling policies as well. We can do the traffic engineering from the VS Smart. We have per segment topology, means we can create the segments. We have full firewall feature, and not only the firewalling features we have, but we can do the uh, filtering as well, say in terms of content filtering, in terms of URL filtering. We have malware protection, we have advanced malware protection, we have, say, DNS security in terms of Cisco umbrella if we integrate with that. Then you can see that cloud path optimization. We have Cloud Express or Cloud on-ramp features. We can do the cloud acceleration with certain gateways. We have transport hub. Again, we can define the gateways. We have the new capabilities and features in terms of CSPs and all. So all sort of features we have related to application. Then we have routing capabilities, security, segmentation, QoS, multicast support, service insertion, survivability, means we have the uh, you have the high availability and redundancy uh, across the data plane devices, across the control plane devices, etc. We have zero touch provisioning. It is independent of transport. So whatever SD-WAN capabilities and features we have, everything is there in the Cisco Viptela Cisco SD-WAN. Now let's see that what is offered by the Velocloud. So Velocloud, first of all, they can do link steering and remediation. They can do per packet link steering, and that's why I am highlighted it in the bold letter. You can see per packet link steering automatically based on embedded knowledge of network requirements. But say in case of Viptela, that is per flow. Even in case of SilverPeak, that is per packet, and Velocloud also doing per packet link steering. The other important thing here, you can see that in the Velocloud, a business priority of application. So what is happening that you have classifications of application, and they are supporting more than 2500 plus applications. According to classification of application or the business priority application, they can perform the priority, or we can do the classification and we can provide some priority for the business based application. Then we have other feature, that is on-demand mitigation of individual link degradation, that is the FEC. This feature is there in Cisco as well. Cisco has added, I think, after 18.4 or in 19.x if you see. So Cisco having this feature of FEC. Here, Cisco don't have this per packet, they have per flow. That is the one thing. Next, see what other features we have. Cloud VPN. Now you can see that in Velocloud, you can create a IPsec tunnel from Velocloud to Velocloud, means inside the SD-WAN fabric, but you can create IPsec tunnel in between non-Velocloud devices as well. Plus, you can create IPsec tunnel with the AWS or Azure cloud as well. So you have full flexibility, but if you see the Viptela, they can create the IPsec tunnel only in between the SD-WAN devices. And IPsec tunnel, there also it's fully automated. Here also it is a one-click type of provisioning you have for IPsecs. But here you can see that you have more flexibility to create IPsec tunnel. Now you can see that we have the multi-source inbound QoS. So what does it mean? That the box is coming with all type of QoS configuration and classification and everything. As an IT engineer, what I need to do, I simply need to uh, you can see that the knowledge of network required for different application type. What I need to do, I simply need to classify it. That's it. So they are coming with 2500 application and all the configuration, all the QoS required configuration. Now, what is my job as an IT guy is to, here you can see I have highlighted here, IT required only to establish application priority. I have to just set the priority. That's it. That's again one nice feature. Then let's see what other things we have. We have firewalling capability. Now here Cisco is way ahead to Velocloud. But Velocloud, they are also, these firewall features are also good. They are providing the content type of filtering. Not only we have the content filtering, but you can see that over a certain application. So for example, a Skype. So inside a Skype, it can disable the Skype video, chat, etc. So not only the application, but the sub portion of application, or not only the major portion of application, but whatever application inside application also they can we can filter from the Velocloud firewall. Now in this field, uh, Viptela having complete say SD-WAN security operation course, means you can do n number of things with the integration of the ISR and the, if you put the container, means inside ISR I can have a container and I can put virtual image related to IPS IDS. They are supporting zone based firewalls, and there are n number of things that is supported in Cisco, but here it is not. So what Velocloud is telling that you use my firewall, and for advanced feature you use the company standard based firewall, that is Palo Alto. And most of the organization nowadays I'm seeing that Palo Alto is integrated not only with the Velocloud, but even with the Cisco SD-WAN also. Companies or corporates, they are integrating their SD-WAN solution with the Palo Alto. Then service insertion and redirection means your corporate traffic you can redirect towards the firewall, and then it will go out and come in. So service insertion we have inside the Viptela, inside the Velocloud cloud, both the solution they are supporting the service insertion. Here Cisco is recommending you can use the Cisco DNS security, that is Cisco umbrella, and Velocloud they are telling you can use any good industry standard cloud solution, say for example Zscaler or WebSense. So integrations are there. Whatever features I have, use that. Otherwise you can use whatever best in the corporate, whatever best in the market. Now again you can see in terms of routing, uh, in Viptela we have OMP, Overlay Management Protocol. It is very much customized BGP. So many nice things inside the OMP. But Velocloud is using OSPF and BGP, and OSPF I can obviously use as a IGP, and BGP I can use as a IGP plus as an overlay protocol. But for overlay solution, they have overlay flow control, that is OFC, and is which like to comparing what OMP is doing is overlay management protocol, OFC can do. So what OFC can do here, it's a overlay protocol for Velocloud. The Velocloud Edge learns route. You can see the similarity here. Learns route from adjacent routers through OSPF and BGP. It sends the learn route to the gateway controller. In Viptela, these devices, edge devices, they are sending routes or prefixes to the VSmart, and VSmart is working as a route reflector. In Velocloud, they will send those things to the VSO, Velocloud Orchestrator. Now, in both the case, Orchestrator is also working as a route reflector. VSmart is also working as a route reflector and send the learn route to the other SD-WAN edge. And the OFC enables enterprise-wide route visibility and control for ease of programming and full parcel overlay. So you can see the difference here. Both are working as a route reflector. It's a similarity, but here I have VS, here I have the orchestrator. Here I am using OMP, but here we have the mix of OSPF and BGP to doing that thing. Segmentation, initially the Viptela, they have restriction with the segment. They can create only 500 tool segmentation. With ISR devices, now limitation is gone. You can create more segments. Here also we can create L2 and L3 segments, and in Velocloud also we have end-to-end segment support. So end-to-end, they are supporting the segments. That means that you have global routing table and you have VRF. You think like this, you have global routing table GRT and you have VRF for corporate traffic, for guest Wi-Fi, for PCI, for other nature or other type of traffic or other segments of corporate traffic, etc. So you can segment the corporate traffic inside different VRFs, or you can create the virtual routing forwarding instances, and those are supported end to end. Then very important thing we have related to policy. For this business policy framework, inside VSmart we used to create policy, either it's a local policy or global policy in the Viptela. But here in VCO, in the Velocloud orchestration, you can see that you have business policy framework, quality of service, resource allocation, link path steering, automatic correction of the link, etc. Means you can create the policy at the level of VCO and you can push this to any n number of devices. So we have the business policy framework inside the Velocloud. Now you can see, if I go to the next slide and compare little quick that how they are doing their work as an underlay and overlay. So suppose this is your underlay and then you have your VCO as overlay. You have connection and the underlay, they are communicating, and then you have cloud hosted devices, they are also communicating. Now if we compare some of the things, so here we have VCO, here we have VSmart, vManage, vBond. Here edge device, here also you have edge device in all the forms, either virtual, either hardware or cloud hosted. So this is similar. Here you have the difference. Here you have the BGP and you have OSPF running. Here we have overlay protocol as a OMP. We have OFC as a equivalent to this OMP, and a mix of BGP, OSPF and OSC, they are working as a overlay protocol. Here we can create the business related policy, and here from VSmart we can create the localize and the global policy. Here we have the firewall, and here also we have the firewall, but there are so many things that is supported in the Cisco devices. So this is the feature-wise comparison, and in the upcoming sections we will learn more about this Velocloud and their solution. This section I'm going to walk you through the Velocloud network topology and what type of topology supports they have. The first topology support, you can see that the branches to private third-party VPN. So what is happening here, that the non-SD-WAN fabric or non-SD-WAN traffic is coming to the Velocloud gateway. So obviously from this location to this location you have the tunnel, IPsec tunnel, and again from gateway to the Velocloud devices you have the tunnels. So this is one of the supported topology we have in the Velocloud. Then the others in terms of branch, we have bronze, silver and gold type of topology support. So let me show you one by one what does it mean. When we are talking about the bronze, you can see that one of the Velo Edge or Velocloud Edge device, they have two connection going to the internet. So this is a type called bronze. Then you have the silver side topology. In silver side topology, you will find that you have two different type of topology. This is silver type topology 1, this is type 2. MPLS is connected with the CE device, then you have the L3 device in between. Uh, this is one of the supported design, and the edge device is connected with internet, and you have the gateway here. Likewise, you have MPLS and you have CE for MPLS and you have CE for internet, and in between you have the uh, edge device connected. So these are the supported design and the architecture. Then one third option we have, that is the gold, and this gold site is not currently in the scope of this release. So actually we are talking about 3.2.2 release, and very soon this particular design will also get supported, where you have, so let me show you that gold design. So here it is, and you can see here in this particular design that you have L3 interfaces connecting here. Uh, L3 interfaces connecting here means we are supporting multi-path in the design, say with respect to OSP of our BGP. Now, this particular device, you can see the edge device having two L3 interfaces, so we can use some sort of virtual IP to the edge device, very much similar to the loopback 0 IP address. That will be the IP over the system or the box, and then the n number of interfaces will support that. This is still in progress. This is the gold design, and it is in progress. Now, adding all those design inside the branches, you can see here the overall hybrid SD-WAN structure. So these are the branches. Say this is the gold dual L3 switch. Then here you can see that this is the silver side where you have uh, MPLS-C connected with the MPLS, and then your edge device is connected to the internet or broadband. Then you have the legacy side. So legacy side is also here. Then you have the bronze side, means you may have one or dual connection going to the internet. So all these uh, edge devices, obviously they have the IPsec tunnel towards the head end, and that's why you can see that you have the existing VPN hub, and this is the very much flexible and the supported design inside the Velocloud. Velocloud, they are supporting uh, failover if suppose if you have the multiple data centers. So here you can see that the edge device, suppose you have DC1 and DC2, and as per the OSP of cost and priority, you can make DC1 as a primary and DC2 is working as a secondary data center. So in case of failure, obviously the traffic will shift it to hub 2, so this will become the primary. So all those failover active, 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 passive is supported inside the Velocloud structure. Velocloud is supporting the fabric or the failover as well. So here you can see that you can create the cluster, and inside the cluster you can have the interface marked as L1 as a failover link, and suppose if this link will go down, so the secondary device will block all the interfaces, and this will be the active forwarder, very much like Cisco BPC, where you have the peer link and peer link is down, then the secondary switch will block all the interfaces. Correct? So these are the supported designs, and you can see that how flexible and how many features, and not only the SD-WAN to SD-WAN, but SD-WAN to non-SD-WAN, SD-WAN to cloud, all these type of traffic, then manipulations, path manipulations, link steering, all these things are supported inside the Velocloud. So let's just stop here, and in the next section we'll see the configuration components of Velocloud. This is the important video, and here we'll discuss about the Velocloud key concept. What are the key concepts we have? First of all, we can create users and role-based access. So what type of user I can create? I can create IT administrator and site contact. Now site contact is a type of local type of user. This is for the non-IT person. So when we are activating the edge device, at that time it will be used. After that, we have the IT administrator. Inside IT administrator, we have three roles. You can see we have a standard enterprise admin, we have super user, and that's interesting. That super user can create profile policies. He can create some more users for other customers. So that's the role of super user we have. Then you can see that we have the enterprise support. So support, they can check the configuration, they can monitor the task, etc. So the highest privilege we have with the super user. Then we have the standard admin can perform all the configuration and monitoring task. And then the enterprise support who can do the monitoring and uh, configuration review, etc. Now after that, when we are coming inside the configuration, that's the key here. So we should take our time to understand the configuration and the hierarchy of configuration. In this diagram, you can see it's very straightforward that you have network services. So you have two object that is going inside the profile, and then profile is going inside the edge. Very straightforward, but I'll show you in the last slide for this particular recording that how it can be enhanced, or how it is used inside the Velocloud in the enhanced fashion. So the profile that we are seeing here, I can have same profile applied to n number of edge devices. I can have same network objects applied to n number of profiles. So those object reusability, and that's the complete use case for the templates. So once you have the templates, or once you have the object, you can do the reusability of the object, and that's the key we have in the SD-WAN. So let's go one by one. The network, what we can do with the network, you can see inside network, you can define the VLANs, you can define the networking objects, etc. Network services having cloud VPN, non-velo cloud side, cloud proxy services, DNS authentication services. Profile, profile define a template. That's the template we have. So it's a template for the configuration that can be applied to the multiple edge. A profile is configured by selecting a network and network services. That's why we have that diagram. So you have network services going inside profile. You have network services going inside profile, correct? Applied one or more edge devices, you can apply this to one or more edge devices, and then you can configure SNMP, NetFlow, business policies, firewall configuration inside profile. So now it is interesting to see the summary slide. I'll come to this slide, but before that, let's quickly check this edge. Now when I create this edge configuration, and edge having profile, and profile having network and network service. So it has network and network service. This configuration should be downloaded by the edge devices, because remember, everything is configured and monitored from the orchestrator. So I can create everything at the level of VCO, and then the edge devices should download that, first thing. Second thing, in the edge device also, you can create certain parameters, you can define certain rules. Now if you create certain parameter or rules, so here you can see an edge configuration also overrides settings or add order policy that is defined in the profile. So suppose if we have same rule in profile, say for example ABC is the rule, and again if I define same rule inside the edge, so he has the precedence. So that edge rule will precedence, or having higher precedence with the profile rule. Now why it is important, here you can see in this slide, that now you can see so many boxes, but it's actually very easy to understand. If we understand this diagram, that I have edge, I have profile, I have network, and I have network service, then it become very easy. How? You can see edge and profile, overview, overview, and then I'll log into the device and I'll show you this also. The same thing you will see inside the, obviously in the orchestrator configuration as well. So overview, obviously you are calling profile, so that's why you are seeing profile. Here you have the network and services, you have contact and location. Then this is common, business policy and firewall, business policy and firewall rules, common. Then you can see the devices. Inside device, network, cloud VPN device, Wi-Fi, DNS authentication, SNMP, network flow. Here also you have network, cloud VPN. So some of the features are common, but some of the features are not common. We'll see. But if you create those rules at the level of edge, then it will override the profile configuration. Then you have the network and network services, correct? Now in the diagram, you can clearly see that one profile is applied to n number of same type of edge devices, other profile is applied to n number of same type of edge devices, and this profile they are calling network, network, and the network services. So we have complete reusability of the objects inside the template. In other words, this profile is nothing but the templates only. So let me log into the orchestrator and let me show you how we can verify, how we can see all these configuration at least from the orchestrator point of view. So here I am inside the orchestrator. You can see if I go to the configure, you can see edge, profile. We'll check later about segments and other stuffs, but if I'm inside the edge and I can see the list of devices here, if I go to any of the sites, for example DC Hub site, now you can clearly see that you have edge overview. Inside edge overview, you have properties and profile, and if I scroll down, you can see contact and RMA reactivation. Same thing, same diagram we have seen just now. Then inside edge, you can see that you have the device, and inside device you have configuration segment, you have authentication, DNS, NetFlow, ICMP probes, VRRP, routing configuration, cloud VPN configuration, multicast, LAN, interfaces configuration, etc., SNMP and all. Now if I go here and click business policy, you can see that you have the same business policy option here, you have the firewall option here. So in short, the diagram that we have just seen, if I redraw it, so let me try to redraw it. Inside the device, you can see we are inside the device, and you have the edge. Inside the edge overview, you have the profile, contact, and the location. Then inside devices, you have all sort of features. So what we have seen, let me try to draw here in this box. Even you can go back in the recording and you can check that. So overview you have one, and then you have business policy, you have firewall. So these things are going to be common, business policy and firewall rules. And then you have the devices, this devices here, or device, where you have all sort of options related to network, HA, cloud VPN, and the network services. So what does it mean? If I go back to the devices, you can see you have the authentication service, DNS service, probes, areas, routing configuration, static routes, Wi-Fi configuration, all sort of configuration you have, correct? Likewise, let's go back to the profile. In profile also you will find the same type of things. So for example, I can go and click any of these profile. Let me go and show you by clicking new profile, say test, create it. This is the new profile. And now again you can see the profile overview, device, business policies. It is popping up. You can see all those applications, supported application, firewall rules. So you can see all those firewall rule options we have. If I go inside the device, you can see authentication, DNS, and all those features. Then configure the VLAN, which particular device model you're creating this profile for. All sort of options you have, correct? Visibility mode, NTP, and all. So this is the way at least we can understand at this point of time that uh, what is a Velocloud supported network topology and how the configuration look likes. And these two are very important tab. Actually, the profile is very important tab because inside profile we are creating the network services, and this profile is called via the edge. So now if I am here in the profile, you can see I have the branch BGP, OSPF, DC profile, etc. If I go inside the edge, if I go to any of the device, here you can see the profile calling option is there. So I can call any of the profile, even the test also you can see. So I'll go back and I will select the test. Let me quickly delete this because I don't want to use. All right, now we'll go back to the profiles, to the edges, and now we'll not see that option. So this is the way we can at least understand the configuration and the object oriented type configuration for the Velocloud edge devices. Let us learn that how we can activate the vEdge device. You can refer this hands-on lab from this particular VMware URL, and the same lab I'm going to show you here as well. What is the minimum requirement you have related to uh, RAM, the memory, the storage, CPU process that you want to install this particular edge device over the hypervisor. So here you can see the minimum requirement. Now, what is the process? What is the step that we can do? Uh, and we are going to follow to install this. You can see, and I'm going to show you this via the lab. So first of all, we should have a valid image, valid virtual image or virtual vEdge image from the VMware download page. You can download that. You should have minimum hardware requirement to the hypervisor. And the other thing is the other important thing is that your orchestrator should have a reachability to your edge device, and that's very important because uh, what we are going to do and what is happening in SD-WAN is that everything is managed via the orchestrator. So our orchestrator, that is the VCO, Velocloud orchestrator, everything will be managed via that. Now we have two portion here. One thing that we are going to deploy the OVA file over the hypervisor, and once we deploy that, then we need to authenticate that, for example, the serial number from the VCO, from the orchestrator. So how it is happening, that you have to push the configuration from the VCO to the edge device that you are deploying inside the hypervisor or over the hypervisor, correct? So while doing this, we should match the serial key. We'll see that how we can do that. And here also you'll find that it's very much automated process. It's very much zero touch deployment or provisioning. How we are going to use this, I will see both the options. So I will go and log into the VCO. From VCO side I will show you the configuration, and from the hypervisor side also you will see the configuration. How we are going to create the activation key, we'll copy that key inside the notepad and then we'll paste, and once we done the deployment, then we'll go on inside the VCO and we'll see that the device is already deployed. Okay, so all the phases the installation will see. Now in this particular lab setup, I'll show you that the lab setup, we have the VCO who having the subnet 30 uh, uh, 200/24 means it having subnet 30 dot x slash 24, and the gateway having subnet 40 dot 0/24. Now we have one Linux router as well in the lab, and from that Linux device, because everything is actually simulated in the lab setup. So that Linux router, actually they are going to provide the IP address to the edge device that we are going to connect. So let me quickly draw here the small topology so we can understand what exactly we are going to do. So what is happening here, that I have, say, I'm going to install VCO here, that is my edge device. So for example, edge, and assuming that it has two WAN interface and two LAN interface. So we'll see that we have gig E1 and gig E2 as a LAN interface, and WAN interface we have gig E3, gig E4, but behind the scene these interfaces are actually connected with one of the Linux router, and from Linux router it is getting IP via DHCP, and from this Linux router two devices, one is VCO, one is VCG, that is the gateway, and the orchestrator is connected. So this particular router behind the scene, who is actually providing the gateway or the reachability from here, and to here. So I'll show you the routing inside the Linux router as well, how the routing is done, or what is the routing output here in the Linux device. So these are the subnets and IP going to be used. Once we will go and use all these instruction, follow all these instructions, you will see it will be deployed. So let me go and log into the VCO and the hypervisor, and we'll see that how we can follow the steps. Alright, so I logged into the orchestrator. Here you can see that nothing is there. If I go to the configure, and you can see configure and edge, I can click new edge. What's the name? So I'll do this thing. I'll give the name, say, branch 1, and this is the Velocloud edge, say for example 001. What's the model? Model is edge, and profile, we'll start with quick start profile. Certificate is disabled at the moment. High availability we are not using, serial number we are not using. Let's click create. So once I click create, you can see I am getting one OTP type of serial number. We can think this activation key as a one-time password key. It will be there for first time. This will be used as OTP. All right, so once we do that, and you can see that we have used this the profile, I can click here, save the changes, no changes. Now if I go back to the monitor, now here you can see that branch 1 VCE001 status is pending activation. It should show you green, and the profile is quick start profile. So now what we have to do, we'll go here to the vSphere client, and I want to install. So here you can see I have three devices. One is the router, one is the gateway, one is the orchestrator, already installed in the lab. If you want to see the configuration for the Linux router, let me show you the configuration and the IP routes that it has. So if I go and log in, alright, and if I do route -n, you can see that it having 30 network, that is for VCO, 40 that is for gateway, and then these two IP addresses. We'll see that what IP addresses that my WAN interfaces are going to get. This is working as a DHCP server. It will provide two IP in the two WAN interfaces inside the edge router, and then this will be used as a LAN 192.168.6.0, and 192.168.110.0 is the out of band management IP. In this IP we have some security devices as well, our DNS server as well. So let's exit from here. Let me minimize this. All right. So how we can do, I can go here, I can do right click, and I want to deploy OVF template from the local, because in the local file system I have the image. Here you can see that image. This is 3.2.2, and we'll do next. You have the reason A0, and inside that what is the compute. So we have ESXi01. You can choose that. You can go next, and it is validating. Then we can go next. Here what I want to do the thin provisioning, so let's do that thin provisioning, and next. Now let's select the interfaces as per our PPT. As per our diagram, we'll go and select. So what are the interfaces we have? Say 1 and 2 will be used as a LAN interface, so we'll go and use, say, branch 1. Here you can see branch 1 we see on LAN, and then this is used as a WAN 1. Then I have 2. I'm going to use as a LAN, that is IP having range 192.168.6.x, this LAN, and WAN having different IP range. Alright, then 1, 3, and this 4. So this is coming in this number, but we should follow 1, 2, 3, 4 like that, and we can assign the LAN and WAN interfaces. So here you can see the 1, 2 are LAN interfaces, 3 and 4 are the WAN interfaces. We'll go next. Now customize option, template, where you have 15 different settings. So here you will go and give the name, say branch 1 VCE 001. This is the is 001. What's the IP of the orchestrator? That IP is 30. So let me type it, 200. What's the activation code? Now this activation code that is coming into the picture. So this is your OTP, one-time activation key or one-time password. Let's copy this and go here, put here. We'll ignore the certificate validation error at the moment. Let me go and put the password as per the password standard. Should be a strong password, mix of various characters, special characters as well. Let me give the DNS, and that is 110.10. Secondary DNS we can leave it. Now here you can see that some of the interfaces that we have, you can see that 3 and 4, those are my WAN interfaces. They will get IP automatically from the Linux router that we have. So we'll leave it. So far we have done all these things. You can go and verify, click finish. Once you finish that, you can go and check the task. So if I scroll this, you can see deploy the Velocloud template, and you can see the task as well, and it will go and start its process. So you can see, so process has been started, 19, 20, 30, 35%. We can wait for some time. Once the deployment will done, then what I will do, I will go to the Velocloud edge. So I can go here, and then we have the power option. You can go and click power on, and you can check the logs. So we'll wait, and meanwhile if I go back here, We have the alerts and events. We can see here profile we have set. So we are getting the messages here, you can clearly see, and the events they are also coming. We'll go back here, and here now you can see it's completed. So do the right click, go to the power on. Once the power is on, I will go and open the console as well. So let me open the console, because what will happen now that behind the scene my edge device and the orchestrator, they will try to communicate with each other, and once the orchestrator will verify, oh, this is the edge device with the correct serial number, then I have to push the quick configuration profile. And here you can see no activation attempts yet, so he will try to uh, send his key, the OTP, to the orchestrator, and once he sends, oh, this is the correct key, I have to push the profile, or I have to push the configuration to edge device, he will push. We'll go back here, let us go back here, let's see that what's the status of the, you can see they are trying to communicate, so it is degraded. Initially it was not activated, it should show you the green. It will take some time. We'll go back to the Velo. Now here you can see that activating to the VCO successfully activated, and we can see that they try to give the IPs as well to the interfaces. Successfully activated. So we are getting the successful message here that the device is successfully activated, and let's go here, and if I can go back, let me, yep, you can see they have the IP over the interface. You can see the IP that is 66 and the 98, they are stable, correct, with our quick profile. And if I go to the events, now here you can see all the events, correct. So clearly you can see the events, and edge interfaces up, edge interfaces up. So this is the way that we are activating the edge device. You can see how easy and straightforward that once we have the communication between the VCO and my virtual edge, we can easily deploy, we can easily bring up the site or the branch. After the installation, we can go and verify this. So let's go here and go to the console of the edge router. It is coming up. Let me quickly log in. So after giving the username and password, it will show you like this. You can see branch 1 VCE 1001, and if I want to see the route, so I can go and check route. Clearly I can see that I have two gateway to watch these two WAN interfaces that we have created. Let us go back here to the orchestrator, and once I am inside the orchestrator, you can see that the status is green. It is connected. It having two WAN interface 3 and 4, and if you want to see that, you can go to the configure. Even we can go to the monitor just to verify this. So I can go and simply click this branch 1 device, and here you can see that you have the interfaces which is up and running. You can see the overall throughput category. We can see that's the SD-WAN, this is the edge, and various parameters that we have discussed little bit about these parameters earlier during the section 1 of this particular course, even in section 2 also, when we have done the feature differentiations and all. So what is happening while you are doing the installation of a device, of a edge device, it is recommended that you should go to the uh, administrator, not administrator, but you can go to the test and troubleshooting. It's recommended you can go to the test and troubleshooting, and you can do this remote diagnostic. If you go here for first time, it will take some time to generate the output, but here you can see that you want to see the ARP dump table. View the contents of the ARP table. If you click run, it will run that command, this ARP dump table, and it will show you that. Basically, what is recommended that once you do the deployment, you should go here and you should do this ping test first. So you give the public IP, any public IP that you have. So for example, Google DNS IP. We'll do this ping test. We'll wait for the result. It is coming up. And if I go here, you can see the ARP. You can see alive. The two interfaces ARP is running properly. Then here you can see the ping test. It is generating. It will pop up the result. We should go and check the system health. So I can go and check the system health. You can see the view current system load and the recent WAN stability stats. I can go and click run. It will show you that. But most importantly, we should go and check. So it's recommended you check most of the things, but it is recommended at least you go there and check the list path. So let's go and check that the list of active WAN links that we have, and it is generating the report. So once you do the baseline deployment, here you can see that I have two paths. You can see the bandwidth, upload and download bandwidth for these path. It is generating. The DNS is unreachable. The public IP is unreachable. It's okay. That's not the fault. And if I can go and check my local DNS, that is 192.168.110, and let me click run. So it should reach to the local DNS. We'll wait. Now here you can see the system health. So very nice output we are getting. So just after the deployment, we can go and check the traceroute, VPN test, Velocloud gateway, the WAN link bandwidth test, all type of test and diagnostics we can do. And this is one of the nice feature we have that I think in other SD-WAN vendors you don't have this feature or this type of implementation you don't have. So here you can see the deployment is very easy. Once you do the deployment, you can simply go to the diagnostic and you should do this basic parameter check. So once you do the deployment, you should know that your basic things are working, and then you will be 100% okay that okay, it is working properly, and then that particular device will be the part of production. Okay, so all right, these are the basic things that we should do after the deployment. When we are deploying the edge device, at that time we are assigning the profile. Now here you can see in the diagram that profile consists these four things. So profile having profile overview. Inside overview you can see network and network services. It having business policy, firewall policies, and devices. So these four tabs actually we have, and after these slides I will show you. I will log into the VCO and I'll show you all those options. Now how we can go and create the profile? We'll see that you can go to the configuration and the profile option. You can create profile. Once you create the profile, you have multiple options. Some options you will see that are related to segments, and some options are in general, like general configuration. So here you can see that I can go to the configuration and the profile, and here let me mark here, let me highlight here. So here you can see I can go and click create profile. Once I can create the profile, that is the new profile, then you can give the name and the description. I can give any logical name related to maybe branch 1, branch 2, or any generic name. Once you go and click create, then your profile will be created, and then you have option. So suppose I have given one name called Velo Branch 1 profile, and now with this particular name here, you can see I have profile overview, device, business policy, firewall rules. So those things I can go and create. We'll see that. I will log into the VCU and I'll show you that. In our last section, we have used one quick a profile just to bring up the device. But this time what we'll do, we'll create our own profile. We'll do some sort of customization inside the profile and policies, and then that particular profile will push or will attach. Now, if you go to the device section, so in those four sections, you have two things. You have segment aware configuration, you have common configuration. I'll show you that what type of features you have in the segment aware configuration and common configuration. In segment aware configuration, you can see you can set the authentication, DNS, NetFlow, voice, cloud VPN, routing protocols, multicast, and some other features. In the common configuration, so you have the common configuration where you can put the VLAN, device setting, a Wi-Fi radio, multi-source QoS, SNMP, NTP, etc. We'll see that in the VCO, all these things. Then once you create this, obviously you have to go and you have to assign this profile. So we'll go and we'll assign this profile as well. And one change I want to show in the configuration is that you can create segments. So as per your voice, video, data, as for your classification of traffic, you can create the segments. And nice thing about this Velocloud is that once you create the segment, then you have option to apply the segment to all the places. So I can go inside the firewall and I can apply particular segment policies, firewall policies related to that segment, business policies related to that segment, device options related to those segments. So those options will get, and that's why it's actually very flexible in terms of configuration and configurational changes. It's actually very flexible. So here you can see that inside device, I can go and by default it will be the global segment, but you can use any of the segment that you have created inside the configuration and the segment. So I can go inside the configuration segment, I can create n number of segments, and then I can go inside the configuration and profile and I can call those segments. All right, so let me go and log into the VCO and I will show you all these options where you will find all these options. Last time we bring up one of the edge device and here you can see the interfaces and all. I can go to the configuration section and first of all let me go to the segments. I have certain segment like VPN 10, 20 and 40. Let me add one more, and global segment you can see that is there by default. So this I name as a test and this is for example 30. The service VPN is 30. I'll save the changes because once you have the segments created here, if you go inside the profile, I think we have one profile already. Let me delete this profile and I'll create a new, and this profile is not attached with anything. We have one quick start profile. With help of that particular profile, my Velo Edge is working. So here we'll go and create new profile. You can go and create new profile. Say I have say Velo branch 1 generic profile, and you can go and give a description to this. I'll click create. Once you create, you have these four tabs. You can see profile overview. Now this particular profile here you can see uh, in the name and the description there is no problem, but you can see the profile overview, enable models, all these devices are supported with this particular profile. I don't need all edge 1000, 2500, etc. What I need, I just wanted to create this profile for virtual edge. That's it. The services, you can see that multipath optimization is on, application recognition is on, identity, DHCP, and some other services are on. In the segment section, you can see business policy 22, firewall 1 outbound rule. So by default, it is something called quick base profile or quick profile. Means quickly, if you want to deploy without having any profile, you can use this and you can deploy the edge. But we can go and do the changes in the standard profile, and by default you have all the business policies and firewall rules will be there. So what I want now, I'm inside the device section. If you go and see here, select the profile segment, you have option that you can select all these. So let me do the cancel, because before that I want to show you. If you go to configure segment, if you click, there's only one. Now for that you have to go here, and for example I will use data and test. Here you can see one of the segment is locked, means you can't do any changes for this particular segment. This will be there by default. This is the base rule or base segment, so we can't do any alteration or change. Means we can do some changes but we can't move that. Now once you done that, now if you go to the drag down button, you can see here that you have data, you have test. So which particular segment you want to apply the features or the network services. Now here you can see you have 1 2 3 4 5 6 7 8 features. If I go and select data, 1 2 3 4 5 6, so 2 is gone, because 2 of the features are actually not applicable for the service side segment, or for that segment that we have created. So that is one of the difference we have. Now you have option, you can go and add the VLANs. You have the management IP. By default it is this. I don't want this particular profile for all the devices, but rather I want just for virtual edge. So I have virtual edge, and this profile is apply for that. Inside that virtual edge, we have used certain interfaces for LAN, certain for WAN, so that's okay. I don't want to enable any radio setting, so I can disable it. Then I'm not using any multi-source QoS. SNMP, I'm not using NTP, I'm not using visibility mode. So here you can see that in my global segment, I have these policy applied to this particular profile segment. Then I can go to the business policy. I should save this before moving there. So click save it. Changes have been saved successfully. We can go to business profile, and here you can see in business profile also whatever segments that I have chosen here inside the select profile segments. Here also you have the option, correct? So I can use data, test, etc. The policies, again, the box is coming with the pre-configurations. So here you can see the much configuration is there related to application aware routing, because the Velocloud, they are supporting 2500 application, 2500 plus application support they have, and they have very nice application recognition engine inside the box. So these rules we have. I leave this as a default at the moment, and we'll go to the firewall. In firewall also, if I go and click, I can select the segments. I will leave this as default at the moment. The outbound rule, you can see any source to any destination, apply, allow. The inbound, if you want to change, you can change it. Then you can see the edge access. By default, once you do the configuration, the local UI is denied. For local UI, you can have the HTTP access. The SNMP access, you can see that you have deny all, etc. All right, so our profile is ready. I'll go here to the edge, and inside the edge you can see we have the quick start profile, and I'll use my general profile for Velo branch 1. Save the changes, yes, confirm, and I'll go to the monitor. Here you can see inside the monitor the QoE, the transport, the application. So I just wanted to make sure that now the edge is working with the profile that we have attached. Okay. So applications, if I go here to the SD-WAN control, you can see the transport group, top group, the SD-WAN management traffic, and those are the things that we can check later on as well. Let me go to the events just to show you that configuration has been applied, and you won't have much event details. Here you can see the configuration that is applied. All right, so you can see that now Edge is up and running after applying the new template or the new profile. So here it is working with this particular profile. Let me make sure that I have saved this, and this is the way that we can create the profile. Obviously there are so many things inside the profile that you should go and check, like now you can see this profile is attached with one of the Edge, like inside business profile, how to tune the business profile, in the firewalling, how to create the firewalling rules and apply it globally and per segments as well. All right, so let's stop here. VPN is playing huge role in the SD-WAN fabric, and for SD-WAN, if you see, one of the feature that all the customers they are looking for is the VPN. So how much scalable VPN we have, this particular VPN, because what is happening in the existing WAN, our VPN is not scaling much. So if you see the Cisco solution, you find that Cisco started with IPsec VPN, and then you have, say, DMVPN. Then Cisco offers some sort of get VPN. Means there are so many strategy added and putted all the time with different type of uh, service vendors like Cisco or other vendors as well, like Juniper and other as well, to improve this VPN, to improve the scalability of the VPN. Now in SD-WAN, now it's completely a game changer. So either it's a Cisco Viptela or it's a Velocloud that we are doing the course for. In both the case, you'll find they have auto VPN, and this auto VPN has too much of a scaling. Even in the Cisco Viptela, we are not doing any configuration related to IPsec VPN related to VPN. At the moment you bring up the data plane and the control plane, your VPNs will form automatically. That is 100% full mesh. So full mesh auto VPN is there in the Viptela. In Velocloud, even they have took one step more. So here you can see that not only that you can create the VPN in between the Velocloud, or in between uh, there are so many terms. The actual term was the Velocloud, but you can tell this as a NSX SD-WAN also, and VMware will like if we continuously talking about NSX SD-WAN. So in NSX SD-WAN, but Velocloud is very easy to pronounce here. Velocloud, giving velocity to the cloud or giving acceleration to the cloud. So in Velocloud SD-WAN, you can see that you have option. You can create hub and spoke type of VPN. So like TM-VPN phase 2, or you have phase 3, like a spoke to a spoke as well. Or this, you can see the power. Uh, spoke to, or maybe hub to non-Velocloud devices also you can create the VPN. So all sort of VPNs you can create with the tremendous amount of scaling. You can scale the VPNs. Now I'll log into the devices and I'll show you that how you will get these options. Here you can see that I'm creating VPN from the Velocloud to the non-Velocloud, say for example Cisco ISR devices, but you'll see the long list of the devices that the VMware or the Velocloud is supporting. So we have options that we can create the IPsec tunnel with the non-Velocloud. So here you can see first is non-Velocloud. Inside the Velocloud, we can create hub and spoke, or we can create branch to branch as well. So let me quickly log into the orchestrator and let me show you that where you will get this option to create all these tunnels. Alright, so I'm inside the orchestrator. Here you can see that I have deployed two devices. One is the branch one is the DC one. And if you want, you can go and check the public IPs as well. So they're up and running. That's why all the green signs are there. Now what we can do, we can go to the configuration and the profile section. Once you are inside the profile section, we have this quick start profile. I'm using quick start profile here. The last time I have created one profile, I have deleted that. And both the edge devices, they are using the quick start profile. There is no problem on that. Now inside quick start profile, if you go inside the devices, you can see you have this option called Cloud VPN. Inside Cloud VPN, you can see that what you want. You want to branch to non-Velocloud side, or branch to Velocloud hub, or branch to branch VPN. So let's see the first option, from Velo to uh, non-Velo IPsec tunnels. What's the name? I want to give the name as a, so you can see the type as well. Inside type, you will see you have the ASA, ISR, IKE routers, Palo Alto, Sonic Wall, Zscaler, IKE1, generic firewall. You have long list, correct? And suppose if I go and click Palo Alto, so Palo VPN. What's the IP you have for the gateway? So I'll give any random IP at the moment and click next. Now you can see it is creating the no, keys and everything it is creating. We'll see the template as well. You want to enable the tunnels, so you have option. You can enable the tunnel when your VPN gateway has been configured matched to the data provided in the IKE. So let me show you the template here. Now you can see this is the configuration template related to Palo Alto. So Palo Alto configuration, this is the tunnel configuration. Then if I scroll down, you can see this is step 2, that is the network profile, IPsec crypto. You can see here, these are the parameters. Then you can see the IPsec tunnels. You can see the tunnel information. So clearly you can see that you have the template, and that's the automation we have for all the Velocloud to the non-Velocloud devices. Whatever supported in the list, you can see the list. And that's it. What we can do here, you can click save changes. Changes have been saved. Okay, and now you can have a tunnel with the Palo Alto devices. Like that, you can see there is a long list, and you can see the configuration like that. Now, branch to Velocloud hubs. If you enable this, I can click here. You can select. So branch to hub. This is my hub. Do you have backhaul hubs? So that option is also there. You can go and push that. This is the backhaul. It is showing like that. Okay. That's it. You can see it's very straightforward. Now if you go to the branch to branch VPN option, here you have some more options. So here you have that isolate profile. What does it mean? Enable profile isolation, so the V edge or the edges within this profile will not learn routes from other edge outside this profile via SD-WAN overlay. So your SD-WAN route leaking will not happen if you enable this. We can leave this as default, and apart from that also you can see you have use cloud gateway, use Velocloud hub for VPN. By default we are using the cloud gateway. Then again dynamic branch to branch VPN enable, or to all edges, to all edges within the profile, because we are using the same profile. So I'll leave like this like default. But you can see that how powerful and automated behind the scene, all the CLI configurations are automated in this VPN. And this is the way that we can create the uh, cloud VPN inside the Velocloud. Let us continue with the rest of the configurations option that we have. So let's see that where we'll get the option for authentication setting.
settings, DNS settings, and NetFlow setting. So once you log into the VCO and we are inside the profile, that is the quick start profile. Once you go inside the profile and the devices, here you can see that you have the authentication settings, DNS, NetFlow. Just now we turned on the cloud VPN. So let me quickly show you that you have the option with this radius server. Here you can go and give the name and whatever your radius server is there, you just give the IP. So I'm giving any random IP just to show you that from where you can set this. Then you can give the authentication port, you can give the accounting port, and you can click save changes. Okay, so your authentication settings are done. Then you can go and put the DNS. You can see the conditional DNS forwarding. There is one public DNS by default. If we have any other DNS, we can go and set it. If we have any conditional DNS forwarding, you can go and you can set the new private DNS. So whatever DNS services you have or DNS server you have within premises, you can go and set. Then we have this NetFlow setting. Let me quickly go there as well. Once you are inside the NetFlow setting, it will be disabled by default. You need to go and enable it first, and then you can see what's the collector IP. So for example, this is again some random IP I'm giving, and then 4739 is the port number. And if this NetFlow server is behind the firewall, obviously you should open this particular port number. All right, so once you do all the changes, you should go here and click save changes. Now whatever n number of edge devices are connected with this particular profile, all those devices will get the authentication settings, DNS setting, NetFlow, Cloud VPN. In the last section we have enabled that, so they will get to know all these configuration that will be pushed from the controller to all the edge devices. All right, so let's stop here and next section will continue from here. Let us continue the rest of configuration. In this section, we'll learn that how we can enable the multicast. Multicast feature is that you have certain servers, you have certain receivers, and servers, they are sending one copy in between that packet, or the feed will be replicated via the edge devices, and the receivers, they are getting the copy as per the multicast group. So we'll see that what is the capability and what are the features that edge devices providing. So here you can see the list that the edge devices, we can go and enable these type of features. The feature number one, you can see that we can go and here you can see the multicast support on both overlay and the underlay. They can understand PIM in the sparse mode. So here you can see that you have IGMP and PIM, and I'm assuming that you know that how multicast working. So here we have the IGMP join and uh, leave messages related to which group they belongs to. In between those membership and feeds, they are propagated with help of PIM and underlying protocol, any IGP, and then they are creating some sort of PIM in a sparse mode and dense mode. So it is supporting a sparse mode. So uh, even it is not supporting dense mode. Dense mode is like static routing. A sparse mode is something like dynamic routing. Uh, just if you want to compare, but not exactly the same. So we have the multicast tree built if we have n number of devices, and then they have to select the rendezvous point. This rendezvous point is non-Velocloud. So we have non-Velocloud rendezvous point, and according to that, the propagation of packets are happening. So in between here, you can see these green lines. They are actually showing that PIM protocol, and these red lines are the IGMP. So both the supports we have the PIM support, we have the PIM sparse mode support, we have the IGMP support, and the static rendezvous point configuration where RP is enabled on the third party router. Now when we have to configure this multicast, we have two-way configuration. Once I need to go and enable it globally and then the interface level. I'll show you that how you can do this, how we can do this configuration. So I will go globally, I can go and enable the multicast setting here. You can see this is on, and then I will go and go to the WAN interface. Locally I will go there and I'll show that over the interface level how we can do that. So let's log into the device and the orchestrator actually, and from the orchestrator I'll show you how to do it. So here I am inside the orchestrator, and let me scroll down. If I scroll down here, you can see we have the multicast setting. Make it on. The RP selection, you can see the static, what's the RP address. So let me use the same address that was there in the PPT. And then the multicast group, what is that group? So let me use that. Here I can give the list of the groups. So let me give the other also. 231.0.0.0/8. If you have multiple RP, you can go and add multiple as well. So for example 10.2.2.2, just any random IP I am giving. Then say for example 240.0.0.0/132 and 231.0.0.0/8. Like that you can go and fill this RP entries. Then if you want to enable the PIM on overlay, you can enable it. You will get some extras configuration to do here. You can go and give the IP. Then if you go inside the advanced setting, you can give the PIM timers, what is the join, prune, send interval. So I'll give, say for example 15 seconds, and then the keep alive timer, you can see that is the range from this to this. So here I will go and give, say for example 100. So now you can see this feature is on. I can go on the top. I can save the changes, but before saving the changes, I'll go here to the gig E3. That is the routed interface, and now here you can see that you have the multicast, IGMP, and PIM. So first of all, let me at least save this particular page and fix some issue out there. Please fix the problem below and try again. So it is telling that you have some problem somewhere. Let's see. Oh, so I've given some wrong address. Let me do this thing. So even you can see the marker is there and who is doing the checking, and it's still let me quickly see that what's there. Group is an invalid. So 2, 3. Do one thing. That range is almost okay. Let me try to put one more time. So I'll do one thing. Any random number I am giving. So no problem. /32. I don't think so it should do any problem. And then 231.0.0.0/8. Still it is telling, oh, now you can see that it is okay. Now we have issue here in this particular section, so it should be not lower than what we are expecting. It should just start with 60. So minimum I should give 60 and then it should increment. So now the changes are okay. I'll go to the interface and click edit. Here you can see that we have option to enable the IGMP version 2, the PIM that is in the sparse mode. You have the toggle advanced multicast setting. So if you click here, you can see the IGMP host query interval, and here also you can see the default value and the range. So I'm putting just the default value only, and here I can give the range like this, and that's it. So we have enabled the multicast over the global interface, and then we have enabled the multicast over the physical interface, correct? So this is the way that we can do the configuration for the multicast. All right, so let's stop here.
In the final section, we are going to do the configuration related to VLAN and the other configurations. So let me log into the VCO and then I'll show you all the remaining steps. So here we have the VCO orchestrator, and we have two interfaces that is up and running. What I can do here, I can go to the configuration and the profile, and we have our quick start profile. Inside that we have the devices. Inside this setting, last time I have shown you that most of the configuration how you can do. Before doing the configuration for the VLAN, let me remove these unnecessary things that I want, because we have the virtual edge that is up and running. So suppose if you want to add the VLAN, it's very straightforward. Go to the VLAN section and give the name for the VLAN, give the ID. If you have IP addresses assigned and this CIDR prefixes, then you can use options. If you have done the insertion for the virtual network function, then you can provide the option. Otherwise you can go and add this like that. I'll add one more VLAN just to show you. The other VLAN name is, say for example, PCI. Add the VLAN. Now these VLANs I can go and assign over the LAN facing interfaces. I have gig E1 and gig E2. So suppose one of the interface is working as a switch port mode access. In Cisco we used to do that, and other is working as a switch port mode trunk. So in that case I can give, or I can allow, or I can prune certain number of VLAN, etc. So let's allow all the VLANs over gig E2, and gig E1 is access port. Here you can see the summary in these columns, in these rows. So I can go and save this. You can see it's very easy and straightforward. So our quick base profile, you can see that we have these many configuration. Apart from that, we have the Wi-Fi radio setting. It's very straightforward. You can go and choose your country as well. Then we have this multi-source QoS. This is something that the box is coming with all the category. So here you can see that multi-source QoS intelligently assign bandwidth to remote sources, that is Velocloud Gateway, Velocloud Hubs, and other Velocloud Edge, based on local availability and the traffic priority. So if you enable this, that means intelligently it will auto assign the application traffic with the certain priority. At the moment, we'll leave this as a turned off. Then we have the SNMP setting. It is supporting version 2 and version 3 as well. If you know what is the community, you can give that community. If you want to allow certain IPs, you can uncheck this. You can give the list of IP addresses here. At the moment, I'll uncheck this. Likewise, you can go to V3 and you can go and assign that options that we have. Then we can go and give the NTP server. So we have the private NTP server enable. If no private servers are specified, default internet server will be used. Then finally, you can see that visibility mode we have L2 visibility mode, that is the MAC based, and then we have the L3 visibility as well. That means the visibility by IP address. So these are this setting option we have inside the profile, inside the devices. Next section onwards, we'll see that what are the options we have inside the business policy and the firewall.